Okay. Hello, good morning everyone here. Today is the second day of the conference, so today's conference opening is going to be a little bit shorter than yesterday's, but I'll go through the basics of what's happening around. So if some of you haven't been here yesterday, so I'll just go through it real quickly. If you have been here, so in 10 minutes the first talk is starting, so please just bear with us the first few moments. So first of all, welcome back if you haven't been here yesterday. There was no Pycon for the past 2 years, and we're really happy that we were able to organize it today. So welcome. And yesterday's, I think, has been awesome. From what I've seen at this conference, people are talking, chatting, having small, bigger, larger conversations. Contacts are being exchanged. So that's basically the main thing why we are organizing this conference, so that the community can gather, speak, talk, communicate in person. So that's happening, and I hope that will continue to happen today and tomorrow. The team behind the conference are all volunteers. There's many of them. Some of their names are written here. Many others aren't. You can distinguish them by the yellow lanyards. So if you have any question, if you are having a talk and you're not sure what to do or where to go, or you're not sure which room to head, so go ask someone with a yellow lanyard. If he or she doesn't know how to answer you, they'll know where to guide you for the answer. We also have a code of conduct if you've been to any Pycon. So you already anywhere in the world, so you've already heard of the code of conduct. It's basically the one which we take from the official Python Software Foundation, and it's important for us that everyone feels safe here. So everyone should be open, considerate, and respectful. If you want to read more about the code of conduct, please visit our website. It's located in the About Us section. And the volunteers are not only the people wearing yellow lanyards, but also the people who are speaking here. So every single one of the speakers who has prepared their talk or who has prepared their workshop is a volunteer, and they will be doing this in their spare time for free at this conference. So we are really, really grateful for them that they could come here and make this conference awesome. If you have any questions during the presentations, either in this auditorium, which is called the Titans Room, or in the second auditorium, which is called the Spy Room, so you can ask questions via Slido. The link is located here, and you'll also see the Slido questions in the main auditorium on the sides, on the right and left panel. If you already haven't connected to the Wi-Fi, so these are the connecting details. You'll also find them on the back side of your lanyards. And this conference couldn't be as big and as cheap as for the attendees as possible, had it not been for the sponsors, of which we have quite a large number this year. So please check out their booths. Not only they are an important part of the community because of financial reasons, but also because of the program. So some of the talks which are brought here were able to be here thanks to the sponsors, and also all of the activities which are happening in the conference venue up there on the hall are organized by the sponsors. So there are darts, there's smoked meat, there are teapots, and of course there's this breakfast organized by Bloomreach this morning. I hope everyone has already eaten, as there's a lot of food, and probably a lot of food will stay. So if you're still hungry, head out and have your bite. In the second, in the second workshop room, located right across this main Titans room, there's the Edu Summit, which is continuing from yesterday. This is a special section for teachers, educators, where you can learn about how to program hardware and how to work with students with educational tools. Another educational project which we are organizing is Učíme s hardwareom. You can learn a little bit more about them in the videos which will be showing during the breaks on this main projector. Yesterday, we had an awesome lightning talk session, so if you have a lightning talk which you would like to have today, please sign up. This board, which is right to the right of me, currently will be located directly in front of the Titans room, so during the day, anytime, just grab a pencil, write your name, and come here at I think, 5:30 or something like that. Check the schedule. If you're thirsty, there are 7 water dispensers located around the water venue. The lunch is the same time as yesterday, from 12 o'clock to 13 o'clock. And if you take your lunch out to the terrace, please, no smoking, as this is a venue policy which can't be violated. And the last notice, if you have Discord, so connect to our Discord server where you can be updated with the latest information and changes in the schedule. So please enjoy the conference. In just a few minutes, the first speaker will be starting his talk in this main auditorium. And also, our workshop is starting in the workshop room A with, I think, ESPs and MicroPython. So if you're interested in that, please look into your lanyards, find the workshop rooms. There's a little map, and you can head there. So please enjoy the conference, and we'll see you around. Thank you.
Clip one. Good.
Potom na plátno to púšťam ja, ale nevidím teraz ešte žiadny signál od vás. To tak...
Is there any signal coming? Yeah. Is there any signal coming up out of here? Yeah, we don't see any signal from here. Zatiaľ nevidno, čo to je?
Nie.
I think it's mirroring.
Yeah, you need to mirror it, I think. Yeah.
It's mirroring already.
Should we try other port, maybe? Keď nejde signál, skúsime nejaký iný port, alebo tak? 60 hertz, maybe, or 50? Oh, something's happening. Good. Okay. Nope. Should we try 60? Dáme 60?
Môžeme skúsiť.
Full HD 60 hertz is not the common thing. No input. Okay, there we go. Oh.
Nemám som to ešte potvrdené.
Flashed and disappeared. Huh. Kind of weird. Anyway, as this is being set up, we're going to have a countdown. This is the time for our talk. Then we'll have a little extra for the questions. Yeah. Don't feel obliged to fill up or anything. I mean, just yeah.
And how's the conference been? I just arrived this morning.
You just arrived. Oh, it's been awesome.
Yeah?
It's been really good. Yeah. I mean, obviously I'm biased, right?
Sure.
I heard a lot of really good feedback. So
Good.
So that was great. Is the mirroring not working? Skúsime iný port.
Nebude to v porte.
Nebude to v porte, čo? No input. That's weird.
Deje sa to, čo včera.
Skúsime nižšiu resolution, že víte? Či by si toto pomôže?
Môžem to skúsiť dať naprieho.
Let's try direct connection. Is there anything from the CD that you would like to highlight, or should I just go to the video CD?
You mean the bio?
The bio, that's correct.
Oh, yeah, that's fine.
Yeah, good.
You can mention everything that you share as open source.
Oh, lovely.
Idem sa pozrieť u seba.
Dobre. Potrebuješ od nás nejaký feedback, či? had a similar issue yesterday. So, čo ide? Ide?
PPT presentation.
Do you have one PowerPoint file? This is Keynote, right?
I can give you PDF, but still some stuff I want to share from my computer. That's the demo that I give out. It would be nice.
For sure, yeah.
So it doesn't work. It doesn't work.
Teraz niekoho mám to naplnené.
Aha, napriamo to ide, ale jasne. Teraz tam niečo flashlo, takže neviem, čo to spravilo. Okay, it just shows up and disappears for some reason. You see that? Skúsme ešte nižšie toto? Frekvenciu, nám 150 tam je, že tam do 30 alebo tak, či?
Že to mal bol. Keď mi to nezožere ani ten displej, čo zožere všetko.
Okay.
Mňa to bude zasekané. Ešte možno... Kde sa tu expanduje?
You already tried with that mirroring, right?
Yes.
Zvuk zmizla. Just flashes and disappears. Super weird. Viem, že to asi nebude ono, ale skúsime predsa len import.
Čo mám? Jediné, čo ma ešte napadá, že napájanie. Ešte môžem skúsiť.
Niečo vymklo. Napájanie. Keď sa namiesto mirroringu tie displeje extendovali, robí to isté? Keby sa namiesto mirroringu tie displeje extendovali, robí to isté?
Ale nešlo mi to tam ani zvoliť.
OK.
Proste, keď posielal čierny pozor.
To je zakázané black screen.
Let me send you a PDF. This is sticky.
Yeah, that might. So. Na ktorá by ste môže poslať PDF-ko?
Ja som sem dať nejaký iný materiál, vieš, tým pádom. Skúsim.
So I'm sorry it's taking so long to set up. We have an issue with the screen not mirroring, so we're just getting another laptop and I'm sending the PDF to there. So apologies for the technical issue.
Skúsim svojiť, či mi pôjde.
Same thing. To isté sa robí.
doesn't work.
Vieš čím to je?
So work with the Windows.
Yes. A včeraj, čo sme mali lightning talky, tak niekomu nefungovalo tiež na Macbooku cez tento oný a nejaká tieta nám požičovala, vtedy iný príklad tam to nabehlo. Čiže ja si... Cez toto? Niekto z lightning talku, čo to čakal. Vieš to, že je iný hub.
Is it because it's not a Mac? An Apple?
Because of this thing problem.
Yeah, actually I have had issues with the non-Mac adapter as well in the past. Yeah. Let's ask if anyone has a Mac adapter.
Yep, that's probably it.
Sorry guys, bit of a weird question. Does anyone have an Apple Mac USB-C to HDMI? Could we give that a try, please?
To mirror it or extend the screen?
This case extended.
Super cool. So the way it's set up now, yeah?
Yeah. So it's working, right?
Let's switch the other way.
Oh no, that's because of my settings. No, that's something my PowerPoint, the way.
Okay, so let me know when you're ready and I'll be happy to introduce you.
Yes.
Ešte mikrofón musím dať.
Correct. Oh, you just.
Okay.
Probably this.
Okay. So I remove this.
Go ahead.
Good morning, welcome back. And thank you for your patience. Once again, sorry about the technical issues. Tomáš Sabat is our next speaker, or the first speaker of the day, actually. And he's the Chief Operating Officer at Vatical, creators of TypeDB and TypeQL. He works closely with their open source and enterprise users who use TypeDB to build applications in a wide number of industries, including financial services, life sciences, cybersecurity, and supply chain management. He's the graduate from the University of Cambridge and spent the last 8 years founding and building businesses in the technology industry. And one thing that will be very interesting to you is that everything he'll be showing off today is open source. So if you're interested, you can go ahead and check out these things for yourself. Tomáš, welcome.
Yes, thank you. Thank you so much. I'm so sorry for the delay and everything, but we did get it working. Just when you're doing these things, the adapters apparently can be a little bit confusing. So thank you for borrowing yours. So you saved the day. So thank you so much for the very kind introduction. We're based in London, so I had the pleasure of coming to Bratislava actually first time after 5 years. I once transited here, so it's really nice to be here. And I want to present to you a particular open source project that has been built by the community. I've also been a main author of it. But I think just to preface a little bit on who we are as a company. So we're Vatical. We're the creators and builders of TypeDB, which is a database software that is used across different industries. So we work with life science companies, supply chain companies, e-commerce companies, and also cybersecurity, defense, intelligence, especially in the last couple of months. That's been quite an interesting development, especially with government and private contractors. And so this project is a little bit in that light. So it's aimed at people without a cybersecurity background. If you're interested to learn a little bit about the space specifically when it comes to data specifications, this particular project that I want to share is open source. It's basically there's a data standard called STIX, which is anyone familiar with STIX at all? That's what I'm expecting. It's a very niche data standard. It's a very, very important data specification, how data is described within the cyber threat intelligence space, and originally developed by Homeland Security. And that's sort of what I want to talk about today, how we represent that in TypeDB. The repo itself effectively consists of a particular data set, which is the MITRE attack data set, which is a collection of vulnerabilities, tactics, techniques that adversaries use to infiltrate systems, and that data set is open source, and so we can use that to ingest that into our database. But then we use the STIX specification to describe that data, because there's different ways of how the MITRE attack data set is provided. And then we use, of course, TypeDB as the main database. Everything is in Python, all the loading scripts, that's all been built in Python, and you can check that out for yourself. But before we look at some of the design decisions of the model, I just want to do a quick demo about how actually this, once you've got it running on your systems, how that actually looks in practice. So this is what we call TypeDB Studio. And TypeDB Studio is effectively our IDE to work with TypeDB. So you can write your schemas, you can write your schemas, query for data, and also visualize data. Can everyone see this, or should we dim the lights a little bit? Should we dim the lights or not? No? Okay. So, so basically, if you clone the repo, you load the data, you can run this query for yourself. So this is our language, TypeQL. So we invented this language. You can think of it as a replacement of SQL. And I'm happy to speak more on TypeDB later if you want, but this talk is more specifically on the cybersecurity side of things. But we can run this query, which is basically asking for, give me a course of action, which we assign to this variable course. This course of action has a name called restrict file and directory permissions. And the second entity that we're looking for is an intrusion set, which has a name called BlackTech. And then basically what we're asking is give me a mitigation relation between the course of action and the intrusion set. So we're basically asking that there's a particular course of action which can mitigate against a particular intrusion set, in this case BlackTech. So if we run the query, which is currently run, but we run it just again, and we see that the result is what we see below. So here it's visualized as a graph. We can also get the output, of course, as a log or in the console, or if you're talking with a client API, whether it's in Python, Java, Node.js, whatever, you can also push it into your application. And the result is basically showing us that indeed this course of action, which is called restrict file and directory permissions, seems to mitigate against this particular intrusion set. Now, that's interesting insofar as we now know that there's a relation between the two. But we may actually want to know more. We want to find out why is this, where does this relation come from? Because one of the core tenets that we built in TypeDB is that we've put an inference engine in the database. So we can infer new information that effectively isn't there through logical deduction based on automated reasoning or symbolic AI principles. And this particular relation here means that it's inferred. It says so here in the type, but that's just because that's how we define the type. This could have easily been whatever label you give it. And I know it's inferred because I've done this demo before, but also you can programmatically query it to ask if it's inferred. But the cool thing about, because it's inferred, we can double click on it and we get an explanation why that particular inference happened. So we see that there's a particular attack pattern that seems to be actually, that's the actual connection between the course of action and the attack pattern. And this is some sort of DLL sideloading, which is using this intrusion set, right? So even though this course of action isn't directly connected to that intrusion set, we can still infer some sort of relation just purely based on transitivity of something using something. Therefore, the first thing should be connected to the other because it's indirectly connected. But there's actually another explanation for this relation. And so if I double click again here, we see that there's actually another attack pattern that's also connected to that course of action. As a side note, by the way, we use the entity relationship diagram notation here to describe in diamonds relations, in squares entities, and in circles attributes. But we see here that this course of action is also mitigating against this attack pattern, which seems to be using this intrusion set. And this is where it gets really cool, because this usage relationship is actually also inferred. So we've got an inference, another inference. And so if I double click here again, we see that the actual underlying persisted data set that we ingested from MITRE originally shows us that this course of action actually mitigates against this attack pattern, which in turn is using this malware, this type of malware, which then is using this intrusion set. Anyway, the point of this is to show that basically I'm hopefully not full of shit, and that there's something that you can show. But the query that we saw at the bottom, at the top there, that's a fairly simple query at first glance. But if we zoom out a little bit, this is starting to already get to show a fairly complex set of relationships. And if you're trying to effectively write a query that tries to interpret all the different potential query paths in the query, well, you're going to have a much more complex query at your hands. So in effect, what you're doing is you're pushing down application layer logic into your database. That's sort of what we're encoding. We're encoding knowledge in the database. So, and because the reasoning happens across the database, you're not loading something into memory and then reasoning over it. You're doing at the database level over persisted data. And by the way, so this studio, which is the whole visualization, that's also open source. If you did want to contribute on it, or if you did find bugs, please do and let us know on our Discord server. The database itself that runs this is also open source, as I mentioned. But this is sort of a standalone application that talks to TypeDB. Effectively, what I'm saying that if you want to build some sort of visualization like this, you can actually, and some people have, if you need something specific to your domain. Now let's go back to the data, because I think this is really, really cool. So STIX, which actually stands for Structured Thread Information Expression, effectively describes graph-shaped data in the form in JSONs, which is, I mean, I don't know about you, but I think it's a pain in the ass to read. Effectively, because you've got they describe these objects. For example, here this intrusion set, which is what we saw just now. These relations like uses, and this is a malware. So this JSON here simply describes this intrusion set uses this malware, which is what we saw just now in the demo. And so you've got this object here, this intrusion set, this malware, and this uses relation. But this is where it gets really interesting, because the STIX model actually uses a lot of embedded relationships. For example, here, this uses relationships as created by ref, which refers to another entity. So we've got relations that refer to other relations, and we'll see why that's pretty cool to model in TypeDB. But in terms of STIX itself, STIX is a very fun specification. You can download it. It's a massive specification, and the technical committee at Oasis that built it, again, right now it's maintained by an open source consortium with European agencies and American agencies primarily, but it's a massive, massive document with, I mean, the PDF itself, I look at the HTML, so it's just like the scrolling takes you like 5 minutes probably if you were to manually scroll down. And it's a very impressive piece of work. But basically, the way it's structured in separate chapters, and for example, chapter 4 describes so-called domain objects, which are things like intrusion sets. Another domain object is a malware. And so it describes the attributes, for example, that should be the properties that should be allowed for intrusion set. And but the really interesting thing, and the reason particularly why we've seen a lot of adoption of TypeDB in particular, and I haven't really spoken much about TypeDB yet, is because the sticks model is very hierarchical. And one of the principles that we've implemented when we build a database, when we build a software, TypeDB is to very much use OOP type principle. So type inheritance is a first-class principle in TypeDB. So when you're modeling things like domain objects, which effectively means that you've got one type, a domain object, that has a lot of subtypes. There's roughly around, I think, 18 different domain objects with some properties that are shared, as you can see, required common properties, optional common properties, and then specific properties that are just for the intrusion set. So the really cool thing, and this is, hopefully, again, guessing, is anyone familiar with TypeDB actually at all? Good, so something to share at least. So we define first a domain object here, which basically declares an entity. So the language on the right, that's our modeling language. If you think of SQL when you're declaring your tables, same thing effectively. But instead of tables, here we're defining entities and relations and attributes natively without effectively enforcing a tabular structure on our data or going down to a third normal form. So here we're defining a sticks domain object. That's a subtype of another parent again, which is a sticks core object. There are specific attributes attached to a sticks domain object. And this is where it gets really, really cool, is that we can then define a subtype, which is the intrusion set, which inherits all of the properties and the roles and the attributes that its parent has. In this case, the created modified, so we don't have to redeclare it. Also, if you're now querying for give me all sticks domain objects, you're going to also get all the intrusion sets without having to explicitly declare for those subtypes. Now, the hierarchy is quite complex, but effectively it looks like this, just to hopefully get you as excited as we are about this model. So everything starts with a domain sticks object. Then there's sticks core objects, sticks meta objects, sticks core objects, and sticks meta objects get categorized into yet more different types. We saw the sticks domain objects that you see here on the far left. Those get categorized into a bunch of other subtypes, and then TLP markings get different types of markings, which is a particular way to mark data. I won't get into what this all means. The point being is that for this type of data, the complexity is just enormous. And this sort of type hierarchy says, particularly what the organizations that we work with, is just inherent in the data, even though you may not consider it as such, especially if you're used to using traditional database software like SQL or even graph databases. So now the beauty of, when we started the company 7 years ago is we wanted to build a language that just made it easy and elegant to model this type of data. So, this type of complexity, you can, just with one keyword, sub, we can simply subtype all of these things. And basically everything that I showed before, and I won't go into the details here, but we've really tried to craft the language. Hopefully you'll see that as you're using it as elegant as possible. So keywords like sub, trying to keep them as to 3 characters long, so that when you're reading the language, it just makes sense to you. I mean, we joke around that the type of technology that we want to build is like, if you think of the 70s when you had do-it-yourself computers before computer revolution happened, where you had to design your motherboard, your CPU, put everything together, which is really cool, for a lot of people out there. But then came the Macintosh, which basically put everything together. You couldn't choose your CPU or your motherboard anymore, but now your grandmother could use your computer, or at least your mother. And so we're trying to do the same with this type of technologies, where to build something that inherently works well as a coherent system that allows you to work with this type of data. Now, going back to sticks, there's some really cool type of data that we can model. So for example, a threat actor entity, which has an embedded relation here, has another embedded relation, and then there's an indication relation that again has another embedded relation. One of the tenets of the way we build the language is to make relations able to refer to other relations, which is something that we call nested relations. So a nested relation is basically the ability to have a relation refer to another relation. So here we've got an indication between an indicator and a threat actor, where effectively we're saying that we want to now categorize that indication as a TLP read through a relation of type object marking. So we can directly create that relation and refer to that other relation with little effort. I won't go into the syntax in TypeQL, or maybe I will. So the main thing that I want to just sort of highlight here is that this line here, if you can see my mouse, this here is now assigning this variable IND to this particular relation between this indicator and this threat actor, which creates that relation. But now because we've assigned this variable, we can now put this variable into this other relation at the bottom. And in case it wasn't clear, we're saying that this indicator relation here plays the role of marked in an object marking relation. And then we've got a TLP that plays the role of marking in a object marking relation. And so the ability to use roles allows us to contextualize how a particular thing plays a role in a relation. And then another really important fundamental concept, modeling concept for TypeDB is the ability to represent hyperrelations. Relations in TypeDB, if you're a little bit familiar with graph theory, usually you're working with binary relations. TypeDB uses hyperrelations, which effectively, instead of thinking of a relation as a pair of two things, you think of them as a set of things. So you can have n number of things in one relation. And one example of those is this ternary relation where we can represent 3 things natively in one relation. And not having to reify or sort of impose some sort of unnatural data structure on the model, this network traffic source, we can directly model natively with an IPv4 network traffic and an artifact that play different roles here. So for the artifact here, it plays the role of payload in the context of a network traffic source relation. And to go back to the demo that we showed earlier, just to give you a little bit of context of how that's actually built, sort of how the inference engine gets its insights, because you have to model your data. You're effectively modeling the knowledge in the right way in order to create those insights. And so the query that we saw earlier, where we've got this course of action between this course of action and this intrusion set, which infers into this, that first explanation that explains this relation between the intrusions and the course of action is this explanation, which is based on something that we call a rule. So a rule is part of our schema in TypeDB that allows us to encapsulate some sort of modular logic. And that's always going to be deterministic. So this is not machine learning type of inference. This is automated reasoning type of inference, where we can say that if there's a set of conditions in the database that's true, so if there's a course of action that's mitigating for this sticks domain object, and that can be any of the subtypes of those SDOs, so without having to explicitly specify every single subtype, and if any of those SDOs is being used by this intrusion set, then we want to create a relation between the course of action and the intrusion set. And so now, every time you query for the database, even if you've got terabytes and terabytes of data, you can make that inference quite easy, effectively, without having to know that this rule even exists, just by querying for this inferred mitigation. And one rule doesn't look very impressive, but if you've got a lot of data, and I'm talking trillions, billions of instances of data, and you've got just with a few dozen rules, you can almost exponentially start to grow the number of queries that you can answer. And usually when we work with organizations, and that's both academics to large governments, a lot of this is application layer logic that goes into the database. The complex queries, logic, pseudo reasoning engines in the application that now gets pushed down into the database in a very simple way. Now, the second explanation that we saw earlier, this uses relation right here, is which is because this intrusion set is used by this malware, which is being used by this attack pattern, is down to this very simple relation, which is a simple transitive relation. If something is using something, and if that other something is using yet another thing, we want to infer that the first thing is using that other thing. And so that scales exponentially the more data you have, of course. So to summarize, because I'm almost out of time, some of the reasons why we've seen TypeDB being used especially in the intelligence space, which is sort of what this talk is about, is one, because of the expressivity, so the ability to model very complex data as natively as possible. So without enforcing some sort of unnatural data structure on it, which is effectively, if you think about it, is a tabular structure. The world doesn't really work in tables if we think of it as humans. And the second is the logical inference, so the ability to infer new insights from the database with very little effort. So with that, again, everything that I showed today is available on this repo. If you search for typedb-cti, you'll be able to find it. It's in our TypeDB OSI organization. We've got a bunch of OSI projects for our community. And also, if you do want to join our community, there's people working in all sorts of applications, not just in cybersecurity. This is quite a niche application. I was actually surprised they accepted this talk for this conference, because it's actually very specific. Within cybersecurity, CTI is quite a niche field, but it's growing a lot, especially because of the security landscape since as you know what I'm talking about. And so it's something that's really, really important, and we're very fortunate to be able to contribute in our small way, working with both private and public organizations. So join our Discord if you're interested to connect with us. You can find me on there. I realize I don't have the link here, but if you go to vaticol.com/discord, you should be able to find us. So, and I see. So I'll leave it at that. If there's any questions, happy to answer. And I'm hanging around for today here in Bratislava. So with that, thank you so much.
Thank you, Thomas. And we're happy to feature, to kind of like to address what you mentioned at the end. Some very generally interesting talks, as well as more niche talks. So this year, just like every year, we had a lot more applications for talks than we were able to accept. But try to keep this interesting and fresh, and to show that Python is used in many different domains, and that there are very interesting use cases. The first question that we have is, it kind of touches on what you mentioned. You did one very specific showcase in the security domain. And the question is, this looks intriguing. Who is the target group of the software, presumably TypeDB? And what are some of your favorite use cases? So this was one. Are there any other use cases for TypeDB?
So anything that works with complex data. So if you think of complex data, if you think of data in general, you've got, let's say on the one hand side, you've got time series data. That's just like unconnected data, a lot of data, timestamps, boom, 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 boom. And then on the other hand, you've got highly, highly interconnected data with a lot of relations, a lot of types that need to be modeled. Think of the molecular structure of our bodies. That's very, very typed. You want to accurately represent that in a database. So that's the high-level use case. Specifically, that means we work a lot with pharma, so drug discovery type of applications, supply chain management systems as well. Think of a supply chain, all the different vendors, all the different chains, and all of that. E-commerce, security, of course, finance, space. We work with the European Space Agency as well. Actually, in Amsterdam, we had an event there 2 weeks ago where they presented an NLU application with TypeDB. Crypto, of course, and anything really that works with complex data. Someone once decompiled the source code of one of the Apollo moon landing sessions, represented it in TypeDB, and then used the reasoning engine to represent some of the most commonly known bugs from DARPA, and use that as a sort of a source code verification system, sort of. That was really cool, I thought.
If you were to elaborate on that a little bit, so when we talk about types, so out of any of these use cases, what would be example of like what types are you talking about? Like what specifically is that?
Yeah. So if you think of, if you saw the, let me just pull this up real quick again. So if you consider this model right here, actually let me show this one here. When we're describing this type of data, we're explicitly typing all of these types, right? So this works as schema. This works firstly for safety reasons, so that you can only insert this type of data into the database, nothing else, right? So this is going back to schema, but it's very easy to change the schema, by the way. It's not like you have to do some painful migration if you change the schema. But so now you can define, of course, that only TLP ambers can have a certain set of attributes. Sticks objects can only have a certain set of objects, because that's how you think of the world. And let's say this type cannot be connected to that type. So there's a lot of sort of semantics that you want to represent in the database. And that semantic expression is what we're typing explicitly in the database.
Got it. Thank you. The next question would be, was the solution inspired in any way by academic research related to the semantic web, representing data as ontologies and storing them as triplets?
Excellent. I'm glad someone brought the semantic web up. So we have a lot of love and respect for the semantic web. And however, we did feel that before starting the company that, I've written about this quite extensively, and you'll find some stuff online about this. But basically, if you consider the balance, whenever you're building a new language, whether it's a programming language or a query language, there's this balance between how expressive do you make it and how complex do you make it. And smart people have a tendency to make things very complex, by the way. Like, we've worked with very smart people, and trust me, it's really hard to make them do simple things. That's why Apple is such a great company, as a side note. But the semantic web, in our view, has just a very, very wrong balance between how expressive it is and how simple it is to use. In fact, it's not simple at all to use. I think anyone can agree on that. That's not to say that it's very impressive, the work that has been done, but we felt that to build software, real software for the world, the semantic web is just unsatisfactory in having the right balance between being maintainable, being simple to use, and it's depending on the serialization that you're using, it's difficult to read. So all these factors, when I refer to that analogy between the Mac, the Macintosh and today, and before that, that's sort of what I was sort of referring to. Because if you're using the semantic web and you want to have you need one standard for to have safety constraints, one standard to do reasoning, one standard to do the querying, and then there's different implementations of those standards. It gets very convoluted. Doesn't mean that it doesn't work, but you can also build a self-driving car using assembly code. But I don't think many people are doing that. Again, with all due respect to the semantic web.
How many, just clicked it away. But the question was, how many objects can you store in TypeDB before performance starts to deteriorate?
So actually, we haven't tested the upper limits just yet. As a side note, by the way, TypeDB is written in Java right now. We are rewriting it into Rust. So if anyone's into Rust, I think we're going to be the first database in the world that's going to be written in Rust. And if anyone is interested, that studio, by the way, is built in Compose. If anyone likes the JetBrains type of work. Once we do the rewrite in Rust, we're going to publicly share our benchmarks. And we haven't seen the upper limit of TypeDB yet, so I can't really comment on that. In terms of, I saw Neo4j came up. In terms of performance, right now we're sort of on par with Neo4j. Performance has been sort of a new thing that we've come up with, because the key thing for us has been a lot on focusing on the modeling language. So we will be coming out with performance benchmarks sort of in the next couple of months, early next year. Probably we'll present that at a conference in New York. So if you want to make a trip to the Big Apple, this is your excuse to ask for a ticket from your boss.
Thank you. And now that you mentioned Neo4j, can you compare TypeDB to Neo4j, the graph database? What are the benefits for using TypeDB instead of Neo4j?
So think of a graph database, and so I'm including Neo4j in there, and all of our other friends in the space as well, as a lower level abstraction than TypeDB. So we actually build our own graph engine under the hood. So we have our own graph traversal engine that works similar to Gremlin, if anyone's familiar with that does vertex in, vertex out. we built that ourselves, and on top of that, we built the type system and the inference engine and all of that. So if you consider Python, how Python compiles into C, think of TypeDB compiling into a graph database. One of our challenges that, when we started the company, we were naive and a bit arrogant, I think, to think that we can create a new category in the database space. That's sort of what we've been doing in our opinion, out of necessity. We believe the world needs it. We believe software engineers need that to work with this type of data. We don't think graph databases work. For a lot of reasons that I don't have time to get into, but there is some stuff that we've written about that looks at property graph databases specifically and TypeDB. For instance, there's no inferencing natively in graph databases. There's no typing. There's no hyperrelations natively in graph databases. They're our friends, but we don't believe that their approach works.
That was our last question. A big thank you to Thomas.
Thank you so much.
And now
Thank you.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomér. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
All right. Our next talk is by Oliver Oswald and Martin Michal, and it's going to be about the implementation of advanced analytics pipeline in solar energy industry and integration into AWS cloud environment. Gentlemen.
Thank you very much. So yeah, that's a bit of a mouthful, but my name is Oliver. This is Martin, and we want to share our journey of solar energy data with you guys. So briefly, I'm going to introduce our company, Solaris, in terms of what we do, what kind of company we are. And then I'll be talking about the analytics and the data that we work with. And then later, Martin will go a bit more into how we deploy our tools and how we actually work with our cloud ecosystem. Okay, so Solaris, we actually work, well, the tagline is that we are data and software solution architects for solar investments. I think that wraps it up quite nicely. And we work with data and software for basically all the steps in solar investment process. We've got actually over 1,000 customers all over the world, almost all countries, in fact. And we complete over 5,000 projects per year. Our founder is actually Slovak, and they have over 20 years of experience in this industry and started out as academic researchers and then later on implemented their solutions into software. So very briefly, in terms of the process and our products that cover the PV process. So at the beginning, if you are trying to set up a power plant or even your own small system, you can use our Prospect app, actually, which is at our booth. And what that does is actually allows you to drop a pin on the world map and find out about a lot of different interesting metrics that you can use to decide whether that's a good site. So you can really quickly drop a few pins and find out which ones are good and which ones are not so good. Then Evaluate, which is our second kind of service, enables you to basically go a bit deeper with a selected site, and we actually provide full time series and TMY data, so that's something that we can explain to you later, but don't worry about that. But at this tip, you can actually figure out what is your optimal power plant configuration, you know, how you want to tilt your panels, how you want to set them up, things like that. The monitor actually is something that allows you to track your performance and benchmark it, whether you have a small measuring station set up or an existing power plant. And lastly, forecast is self-explanatory. We have a forecasting team that can provide very short forecasts in terms of like the next few hours, but also the next few days and so on. So that's a little bit about the company. Oh, and in the corner here you can see Solaris Analyst, which is part of the monitor. So that is the software that I personally work with, and we've got a few people here on the booth that work with this software. So that's part of the monitor suite, and I'll be mentioning it a bit more later. So generally we work with the following types of data. So firstly, the Earth observation data. So you know, there's the satellite data, which are global and cover the whole Earth typically. Then we actually work with data that we call ground measurements, which can be solar and meteorological parameters collected by such instruments, as you can see on the middle image. And then lastly, we work with PV energy output, so photovoltaic output data from power plants. And we produce different kinds of simulations and forecasts and so on. Okay, so we're going to go a bit deeper into the ground measurement data. So that's the stuff that we focus on in the analyst team. The typical data set is a time series data. As I mentioned, that's collected by these different instruments. So what you're seeing here are, on x-axis, you've got dates, and every day you've got a few quantities that we measure. So these are different types of irradiance. So basically the amount of light you're getting. So the bottom two are basically direct and diffuse. So something that you have more of. So direct is something that you have more of if you don't have clouds. Diffuse is the opposite. If you have cloudy days, you are getting more diffuse light. And then GHI, the top one, basically combines these two to give you like an overall metric. So as you can see, some of these nice bell curves or well, some of those nicely defined ones could be considered nice days, whereas the one on the left is like a very cloudy, messy day. So where does it come from? I mentioned it comes from ground instruments like this, which you need to set up and obviously pay for, etc. So I'll talk a bit about that later. But the question is, why do people need it? And actually, so there's 2 points. So firstly, it's what's called bankable data. So if this data is actually verified and quality controlled, you can literally take it to a bank and get a loan for your PV project, and you'll get finance, hopefully. And then we also use it for other things, for example, site adaptation. So this is a process where we take data point like this and actually adjust our global model to be better using a single site like this. We actually use pretty standard Python libraries to actually deal with this data. So NumPy, Pandas, Matplotlib for statistical stuff. We use scikit-learn or stats models, but obviously we use other packages in some smaller projects, etc. Okay, so just to give you a brief overview of why ground measurements versus satellite model data. So yes, ground measurement data, as you can imagine, you set up a site and you can have really high accuracy. So that's why people want to use it. And it can go into pretty small time granularity, down to seconds or singles of minutes. Whereas satellite models, you still have pretty good accuracy, but you usually have like a mesh or like a raster, and you're tracking it every 15 minutes and sometimes hourly. But however, the ground measurements data have a lot of other, I would say, costs or potential downsides. So you obviously need to set up, you need to pay for the instruments, you need to operate them, maintain them, and you might still end up with some gaps in data. You need to do your own quality control. So all of these things that are a bit expensive to manage, actually, which you don't get with satellite models. So that's why we actually look at these issues in our software. So I'll just briefly mention a few of the issues, or the major ones, and then I'll actually go through a couple of algorithms that we use, or tools that we developed to tackle these. So obviously, we've got some basic data quality issues very often because the instruments are still operated by humans. So you might have things like data dropping out, so missing values. You might have values that are below or above physical maxima, minima. You can have some artificially oscillating values. So all these kind of unnatural things we're trying to detect. You can have a time reference shift, which is quite a big deal, but I'll get a bit more into it later. But this can be caused either by simply having a different time zone, but also by some more like complicated things. Shading is a big deal in terms of you actually deciding where to build a power plant, because obviously you don't want the light to be obstructed by objects in the horizon. So that we have a tool for detecting that as well. Dew and frost can really shuffle things up because it creates these funky shapes in our time series. So we also try to detect that if possible. We also have things like signal degradation, which usually occurs if you're not cleaning your instruments properly and your signal basically starts to degrade. Instrument misalignment and others. So there's quite a lot of issues. We are in process, or we have built tools for most of these actually. Some are performing better, some are worse, but we're still working on integrating these fully into our software. So I'll go over a couple of them, as I mentioned. So the time reference control one is really key for us because the location and time in UTC basically determines the exact solar position. So we really need to get this right, otherwise we can't really do any more data processing with these data sets, which we can't detect the shifts in. So as I mentioned, this can be as simple as a time zone shift, but perhaps can be daylight savings time. There's a lot of random shifts and drifts that you might get from, let's say, the loggers on the instruments. And also how you define your timestamp in your measurement interval. You can place the timestamp at the beginning of the interval center or on the right side, so at the end. So this is an example of how it can look like. Basically, your whole time series shifted compared to the reference, which here is the dotted line. The blue line is like the corrected data. So this is how we actually determine when we have shifts in our data set. So if you actually look at this top left plot, so we look at the clearness index on the y-axis, which is basically like a ratio between the light you're actually getting versus what you could be getting. So basically like a ratio that tells you how nice of a day you have, or like a time point you have, data point. So basically 1 should be your maximum value. On the x-axis, you're looking at sun elevation. So what this does is basically it uses the fact that the sun elevation removes the mirror symmetry that you have in sun position during the day. So this way we can separate morning and afternoon and actually get this messy pattern. But because we're getting so many values above 1, we know something's wrong. So in ideal case, or after we apply our methods, it should look something like this, where the two morning and afternoon are generally aligned, and you're not getting any values above 1, except for maybe some outliers here. So that's basically the conceptual point behind it, but we actually use something called change point detection, which uses algorithms like PELT. We can talk about that at the booth if you want, but yeah, that's some fancy statistical tool that actually can detect multiple change points in the data set. So we can actually have multiple different periods with different shifts and drifts detected. And we can even return an uncertainty bound for these periods. So as you can see in this particular data set, we found a shift of 120 minutes all the way through, but in some regions we are more or less certain about that prediction. Obviously, it comes with some limitations, so if you have wrong coordinates, that is a big deal. You need to make sure that you actually enter your right coordinates. Then if you have a mix of different issues combined together, that makes it very difficult, obviously, to detect anything. And then if you have short shifts during the day, that also makes it quite difficult for our algorithm. Secondly, I want to talk about the shading detection. So this is actually something you can try at our booth in our software as well. And it's quite a funny exercise or interesting exercise because we look at this plot on the bottom right, and we actually look at the sun azimuth and elevation throughout the whole year. So what you're seeing here is the whole data set, which can be 1 or more years long. And it's mapped on this plane by projecting day by day the data points. So actually one day creates like a line that goes from the left and circles over to the right. So azimuth 180 would be south. So this is actually a station in SAV, so the Slovak Academy of Sciences that we have set up. And by doing this, and measuring the amount of light you're getting, you actually get this nice image of the horizon. And you can spot where your objects and horizon are obscuring your light source. So yeah, you can actually try. This is part of our competition actually at the booth, so you can get involved and win some prizes, but we'll mention that later as well. So the way we actually formalize this into an automatic tool, we use an algorithm called kernel density estimation to connect these blobs that we detect and flag our data set. So again, this has some limitations, and that's especially if you're using, if you have some temporary shading. So if you have some objects which are there for a short amount of time, and then maybe next year you don't have that object in there, then in this tool you would basically get that shadowy shape overwritten by the nicer year. And same thing goes for half-transparent objects. If you have things like trees which are not very thick or something like that, that can be quite difficult. Okay, so as I mentioned, we actually have a tool for almost every issue that I mentioned on that list, and we actually connected into our pipeline. And we designed this to be quite modular so that we can switch things on and off, add things as required. And that enables us to actually run all of them together in an automated way, but also to do things like batch analysis and model evaluation and more complex analytics for ourselves. And that also makes it deployable as a whole in other Solaris projects as well. So the way we actually deploy it or work with it, we actually wrap it up in a classic pip package and actually version it and manage it in a Nexus repository. And then we also, so we use it in our Analyst desktop application, which I mentioned a few times, but we are also on our way to integrating it into our cloud ecosystem. Yes, we use CI/CD pipelines to deploy our app and build it, test it on all the major operating systems. And yeah, so that's pretty much about it from my side. And I think Martin will now tell you a bit more about how we integrate this and other things into our cloud.
Yes. So hello, I'm Martin Mihal from Solaris, and I'm helping teams like Oliver's team and other clever team to integrate it into one Solaris Next platform. It should be fully deployed on cloud. We are in the half of the way, I would say. And so let's start why we are deploying into the cloud, actually. So let's talk about some motivation. So this is just super simple example how our computation graph could like, and that's just like really partial of that. As already Oliver mentioned, we are having like satellite image data, we have satellite processing data, we have customer data, we have a lot of algorithms which are processing them, which are adjusting them and doing some ETL stuff, and it's really hard to manage. So this is just like really simply example from our evaluate application, how complex our workflows are and why it's probably best way to do it in some microservice way, right? As I said, we are only in the halfway, I would say, from migration into the cloud. So we still have 2 data centers in Bratislava, altogether over 100 physical machines. We are also in the process of building of Kubernetes cluster. So it's still not really in production, but we are on the way with that. But the problem with, I mean, many of you probably work in some on-premise infrastructure, and it's not really like easy to work with that. You really need some whole department to scale that, to maintain that, and I just figure out some challenges here. I can just mention some of them. You know, like deployment into on-premise is not that easy as in the cloud. I mean, if you have Kubernetes, yeah, maybe that's kind of solution. So we'll see. But there are, you need to think really about every details. Like I can just mention energy power availability. You know, like okay, you can rent like your diesel generator in your data center, but is it sure it will work? Because we had experience that it could not work. Internal reliability, administration, updates of the machine, and so on. I mean, it's really not the thing you want to resolve. You want to resolve your business problem. In our case, algorithms and data, as Oliver mentioned. So basically, I created just some slides from a bit helicopter view, so not really only about what Oliver mentioned, but generally like 10 pillars of things I wish I knew before I started like migration to the cloud, different kind of projects, because it's consistence of many roles basically. So first rule, and like 4 years ago when I started like migrate myself from like data science guy to some kind of cloud guy, you know, I thought, okay, let's go to AWS. I will just start some EC2, that's like virtual machine on the on the AWS environment, and I just, you know, set up some cron jobs. We actually were solving some kind of SMED benchmarking in the previous company, and I was happy. Yeah, I am cloud developer, right? So after a while, we had more and more platform for benchmarking, more and more resources, and so on, and I end up with 500 gigabytes of RAM, right, of EC2, and it was like super expensive. Thousands of dollars, and I'm not talking about problems with maintenance, operation, deployment, and so on. So really, migration to the cloud is kind of shift of thinking how you design your solution. Not only like take your solution you would have on-premise or even locally and put it into cloud, some virtual machine. No, it's not. It's like you should really invest in your time and change some paradigm how you actually develop those solutions. Second pillar is actually not really like only cloud related, it's like really good practice related for Python, and that's, for example, how Oliver and his team deliver his code for us as a cloud integrator. So we are basically using Nexus repository, and we are pushing into that repository the code they are making as a normal Python library. So you don't really care if it's Pandas, NumPy, or AutoQR measurement, how they call their library, or any other model-based library from our company. For me, as a cloud integrator, I don't really care, because we are using this kind of repository. I can install those library. They are versioned properly, so I know 1.5 I can use in dev, 1.6 I can use on different environment, and I can manage it as you manage Pandas or any other scientific library available on the market. And this is just super quick example how thin could be then cloud layer on your, for example, Lambda. Really, you can just import your library from your colleagues, where it's like it's already predefined and you know it's working because they have their tests, they have their CI/CD, and really in 2 lines, if I will super oversimplify it, I can make AI or analytics, which Oliver mentioned. So this is how you can separate a layer of complexity between the teams. So then integration team can really just be user of the library. Another stuff, super important, I would say. I mean, anybody of us is already fight with different kind of version of libraries. Even with Pandas, they change their interface. They change even sometimes the functionality in some edge cases, functions, and so on. So really, you really need to Dockerize your data science code, data science jobs, because without that you will be lost. And plus, it's really helpful for deployment into AWS environment. So basically, this is flow we are doing with our data science job on the cloud. So we make container, we put it into Elastic Container Registry, and then based on how long it takes, you could put it into AWS Lambda or AWS Fargate. Those two services are basically ready for you to use, and they are serverless. I will talk about that later. Maybe this looks like, okay, it's pretty complicated, right? So who will do it? But actually, AWS provides CDK, and it also supports Python language. So it could be actually, if you would be not really good developer, you can put it into one line. This one line of code is doing all of this flow for you, for free, basically. So CDK is like infrastructure as a code tool where you can deploy your stack into AWS. And this is example, I actually also select the subpart of the code, and you can see which code is responsible for building and pushing Docker into ECR, which part of the code is responsible for setting up your Lambda settings, for example, memory size, timeout, environment variables, or some other advanced functionality. And altogether, it's putting into functional Docker Lambda, which could be up to 10 gigabytes big, and it's just ready for you. So basically, this is how you can deploy your first Docker-based data science application into the cloud via infrastructure as a code. And important stuff, I mean, probably for most of you it's clear, but for me 4 or 5 years ago it wasn't. You should really start your deployment from first, second, via CI/CD and with support for multiple environments. Again, CDK is a great tool. You can super easily deploy like 4, 5, even hundreds environments, and then you can operate them like separately. You can, use on demo or in the production different environments, and use for even for feature branches. You can use your own environment. So really think about that and use CDK for that. And bonus for us as a Python guy, everything is in Python, so you don't need to, read super long Terraform stuff. It's just normal Python where you can use for loops, if statements, dictionaries, whatsoever, which is really natural for us in comparison with Terraform. which is for maybe especially if you are transferring yourself from data science, is not really what you really want to work with. So I mentioned EC2 and like just migrate your server or scripts or cron jobs is not really how you should do your cloud migration in 2022. And how you should really do it is like using serverless. And here is just a quick example why actually Amazon built the AWS, or one of the reasons. If you would have everything on EC2 or other machine, you would need to have amount of servers which could handle Black Friday. So here on the chart you can see number of requests on AWS or other services, I'm not sure, during Black Friday. So it's 6 times more than usual traffic. So what would be the solution? Do you want to buy 6 times more servers you need just for 1 day in the year, or 1 week in the year? In our example of SolarGIS, we wouldn't have like 100 servers, but 600 servers, and that's pretty expensive. So we really don't want to do it, and that's why they create, or that's why they're an existing serverless approach. And how does it work for those who didn't hear about that? You design, implement solution. Let's say, for example, those Dockerize data science job. In testing first, you are running it only on one server, somewhere in the AWS and so on. After a while, it's in production or in dev, it's starting to be used more and more, and in the end, you can end up with like millions invocations per month, right? But you don't care. You just implement your solution, you design your solution, and you really don't care about this stuff. So you don't need to go to your department, which are handling data center, and it's just working, Okay, there are some limitations, like a number of invocation in one time and so on, but everything is customizable. And serverless is not only about scalability, that's like me. I would say serverless is also, as I already mentioned, the way how you should really operate, because you can really concentrate on your business logic, on the resolving the really cool stuff, as Oliver mentioned. That's the stuff you really want to resolve, and not like how many servers you should have, what kind of version of Ubuntu you have. Those kind of departments could be huge, expensive, and it's not really solving the business problem you want to solve. So with this framework, if you have really serverless Dockerized application, your decrease are concern over infrastructure, and really you can focus on your business logic. So that's it. And serverless is not about only computation, because right now, till now, I was talking only about AWS Lambda or Fargate for computation. But AWS is providing a huge number of serverless, so ready for you without any headache how to run it, maintain it. From messaging, through security, logging, databases, analytics, bucketing, and so on, monitoring. Basically any part of your application which you usually need, it's 99% is already ready for you on the AWS serverless solution. So really invest your time. If you will something deploy into AWS, maybe there is something for you. Really there is big chance. And this is also important stuff. We had also in SolarGIS quite discussion. For example, what kind of queue messaging we should use. There were some group which were like, okay, let's go for RabbitMQ. We will deploy it on our servers and so on, and after a while it will be there. Why we should do it? Like AWS has their service, for example, SQS SNS for queuing, and you would be amazed how great is integratable with any other AWS service. So, for example, you want to invoke automatic Lambda, no problem. You want to scale it up, no problem. You want to, as part of CDK infrastructure as a code, no problem. So don't really go even into those discussions. If there is AWS solution which is good enough for you, start with that, and I'm quite sure you will not be sad about this decision. And this is just one example we are using exactly in Oliver case for quality control, which we are computing on AWS. We are using for orchestration step function. Again, maybe Airflow could have a bit more functions. Actually, I can't compare those two because I didn't work with Airflow too much. but why we should use Airflow, where we could use step function, where you can really easily integrate, like some kind of flow where one step in the graph could be Docker Lambda, one could be simple Lambda, one could be Fargate, and one could be service to send a message into queue, and you don't need to have it in one monolith application. You can, separate them, and you can join them like you can see on the screen. And of course, everything you can deploy via CDK, and logs for everything are already included, and basically you will love it. So that's it. This is just example what kind of different service you can use in step function. So really nice tool. And the same thing for monitoring. I mean, there is like a huge number of the monitoring, dashboarding, alarming application, like Datadog, Grafana, whatsoever. But again, if you are already in AWS native service organization and all of your stack you are trying to deploy via AWS, all metrics you need are really already ready for you. Like number of failed invocation of Lambda, it's there. Number of items in DynamoDB or any other database, it's already there. So you can just need to create your logic, what do you want to monitor, and you don't need to build new solutions. So again, you can save like weeks or months of work, with integrating into, let's say, Datadog or I don't know, whatever. This is deep topic. I would not go really into that because we can talk about that for hours, but I still have feeling that many projects, especially in data science, are starting, okay, let's create some table in MySQL, PostgreSQL, put their data and so on, and we will have it as our base for our data science. I mean, really, especially in data science, but also in any other data engineering solution, you should really consider use data lake and not data warehousing approach. It has many advantages, also a few disadvantages, so that's why sometimes people are building data lake and data warehouse solution. But in data science, I mean, it's like super clear way, because you can not only have your table data, you can have also any images data, which are great for some kind of image processing, or you could have even raster data. That's what we are using in SolarGIS for covering the whole world. So really think about that. For those who have never heard about data lake, basically in AWS you have bucket system or storage system S3, what is basically S3 centric system, and you just put their data, you put it there into, let's say, some fashion format as a Parquet, and then it's really, you can use it from bench of application which are ready for use. Just in our example, we are putting this as a Parquet, those customer data. Then we can do some ETL, and they are basically ready to explore via Athena. That's basically SQL-like experience, but there is no database behind it. And then you can super easily visualize those data via QuickSight. So again, everything is ready for you. After a while, maybe you will realize it's not enough, but really, especially in the first iteration of the projects, feel free to use those. So that's one point. Again, one experience we had in SolarGIS, but also I remember back in the days in Piano, we were trying to connect our R code. We had a huge data science department, and we were doing great R code-based data science solution, but after a while, okay, how are we going to integrate it? Now, in the SolarGIS, we are basically solving it on quarterly basis. So this is example how you can do it. AWS provides great SNS SQS queue solution. I mean, most of you already heard about the queue, as a data type, but this is a really high scalable solution which can be again deployable via CDK. And this is just example of our TMY project, where all backend on web is in TypeScript, and our basically the core job is on-premise, and that's why, because we need to process over terabytes of data there. That's what we store on our on-premise architecture, and this is how you can actually join it. Like you just deploy some kind of workers in your core servers, and they are just listening to the queues. You can either prioritize them and so on. So really, if you are building any hybrid solution, so hybrid could be multi-language or cloud versus on-premise, just use SQS because it's easy, you know. So again, if we would use some kind of RabbitMQ or something, we would need to again deploy it, maintain more environments and so on. So really not a good way to go. And I have one last point, and that's not sure if I will be able to describe it properly right now, but this is example from, again, from this customer data processing. So main node is you should really try to learn all kind of AWS service and their nuances, because you can design your solution and architect your solution thanks of that easily. So let's just simplify it. So we have this kind of DynamoDB table, which are kind of meta catalog for our data sets. We have 3 data sets, raw data, standardize them, and then we apply quality control, which Oliver described. So in each state, we need to change, after successfully computation, we need to change state from processing to finish. That's easy. You can just do it via some, as I said, Docker-based Docker Lambda or Docker data science Docker-based Fargate. So probably that would also you do with your monolith application or your on-premise application or whatsoever. Where is the problem? As I said, this is like computation graph, which we defined. After updating the first data set in your meta catalog, you want to find all children's and change their state into processing. I mean, with some old-fashioned approach, I don't know, cron job or something, it would be really not easy because you need to have some trigger or some reactive system, but in AWS, DynamoDB is providing DynamoDB stream, and it's basically invoke your Lambda with any change in your DynamoDB table. So basically, you get your old state or your new state. And you can have super simple DynamoDB Lambda, DynamoDB stream Lambda, with just checking all your children's and change them state to processing. And third business requirements, well, after 3 months, we need to remove that kind of data because we have some regulatory requirements. Again, in old-fashioned technology, you would need probably some cron job who would run every day to check when you add those kind of data into DynamoDB and then remove it. I mean, here in DynamoDB, you can just put time to live attributes, and after 3 weeks or 3 months, I have typo actually here, it will just remove automatically. So you don't need to care about anything. It will just delete themselves, for free basically. So you don't need to support any cron job, anything. It will be just removed for itself. So that's just my point. So really invest your time when you are basically making architecture of any solution, because those features like time to live or DynamoDB stream, and there's like hundreds of them in AWS, could really simplify your solution. That's basically it, my 10 pillars of what I would like to know before I started to migrate into cloud. So this is just like a quick slide that we have competition. You can actually, on our booth, you can actually win the solar, what is this gadget? Solar gadget?
Portable solar panel.
So, portable solar panel. So feel free to join us. We have also some goodies as energy drink and so on. Actually, isotonic drink. And yeah, hiring. I mean, we are growing as a whole solar industry, so we really need some talents. Feel free to check our job offerings on solargist.com or other, job offering portals. But if you really like what we are doing, and you can talk about that on Solargist booth, we can always, create a role for you, because we are resolving many challenges on cloud, on data science, in software engineering. So feel free to contact us or talk with us today.
Thank you.
Thank you. Now we have a bunch of questions. Do I need to be a scientist to work on some project or with the data? Where to start? So that's actually a series of questions. So do I need to be a scientist? Where do I start? and then another any. I don't know what to pronounce that.
So depends
Anywhere
what
where you
kind of
messed up
project.
at your work. So okay.
I guess it depends what kind of project you're talking about. If you're talking about a PV project that you want to set up your solar panels at home, you can, for instance, use our software that's available as a web app. But if you want to play with the data, there are some publicly available sites. So, some of these instruments that I showed you on pictures, there are some meteorological stations that actually make them available publicly, so you can play with it if you want. Off the top of my head, I can't remember names, but you can talk to us at the booth and we can give you some. Okay.
The next one?
Yeah.
Can we go ahead? How do you watch and reduce AWS costs?
So regarding watching and monitoring, as I said, AWS provide great monitoring tools for that, even for billings. So that's one part. And of course, it's important to design your solution to keep in mind, the cost. That's like, of course, you are taking some kind decision what you should do. And a big advantage for SolarGIS is we are B2B. Our product is kind of expensive. So, data we are providing are not like 99 cents data. So we have great advantage with that we can afford, to move workload into cloud because, if the number of requests will increase, our revenue will increase like heavily. So it's just fair enough for us to compute it on the cloud.
Do you plan to move 100% of your workload to the cloud? Or do you plan to operate in a hybrid mode?
Yeah, one of the biggest advantage of SolarGIS is we have over 27 years of data from the satellites. So you can imagine those are raster data every 15 minutes for the whole world. So that's a huge number of data, especially in this Evaluate project where we are operating them. So that's why I also mentioned a hybrid solution. So in very next few years, we will not fully migrate. We will support in some application hybrid regime. Because of this kind of volume of data. So you can imagine over petabytes data to store in S3 and process them, it's not really cheap.
What are your thoughts on the vendor lock-in?
Yeah, we are there, basically. But, like, AWS is like, 60% of workload right now is working on AWS, of all companies. So, that's basically a solution. We are hearing from owners and so on, we should really not do it, but it's really hard to not do it, when you are trying to integrate yourself into AWS, especially those serverless things, you can just, have it in the mind. What we are doing is, for example, when you are building your Docker stuff, or for example, your old data science jobs in Docker, that's pretty easy to migrate into Google Cloud or even on-premise infrastructure. So that's one mechanism we are using, but of course, we are there. So hopefully it will be okay.
What about cloud outages? Do you have some backup running on-premise or a different cloud provider?
No. If AWS is down, there is 60% of internet is down, so basically it should be okay. in last months we didn't have any outages, and we have few outages on our on-premise, so I would say this is still a better ratio on the AWS. So no, we don't have any second cloud. Maybe when we will be in the phase that we will have like some kind of 99.90% availability, we would need to think about it, but right now we are happy what we have.
So that basically means AWS is too big to fail, so we need to, if it's down, everybody's down, so who cares? There you go.
And the thing is, our ingestion from satellites, that's our core business is still on-premise, so it will not affect our core data processing. It will affect just temporary providing of data for customers, and they could probably wait those 15 minutes, hopefully.
So in your case, Lambda plus Fargate totally replaced EC2 for computing, or is there EC2 still in place for some use cases?
I mean, basically, Fargate is just virtualization of EC2. So in the behind the scene, Fargate is starting on EC2, and then after finishing the job, is basically turning it off. So actually, Fargate is hidden EC2, but you don't need to think about things you need to think in EC2 using. So basically, yeah, with Fargate, you can work without any EC2.
Do you use CloudWatch for logs or some kind of interceptor? It's a pretty expensive service.
We are using CloudWatch, and from my experience, it doesn't look like super expensive. Again, we are in niche business, so our data are not 99 cents data, so maybe that's why we are like, we don't have that problem to invest few hundreds of bucks into monitoring. But maybe for others, our other business, it's too much. I don't know.
Your Solar Atlas looks really cool. Are you also validating your PV generation predictions with long-term data measurements from deployed PV plants?
Yes, actually, we have quite a few validation sites. So these are, I mean, most of the public ones, for example, that we actually have a team of operators who also use our software, but also validate it by hand. And then we use the process that I mentioned called site adaptation to calibrate our global models with these sites.
That was our last question. Thank you very much.
Thank you.
And now we have a break. We will not start at 11:05. We will start at 11:10, so that you have a little bit of time to stretch yourselves, get some water, get refreshed, and we'll be back in about 7 minutes. A to bolo volať v tomto pichnuté. Aha, počkaj, to bolo
Ja
také,
som
že...
išiel cez HDMI, neviem čo.
Takže to bola taká sranda, do ktorej to bolo pichnuté. Také, že HDMI na USB-C.
Ja som to mal v mojom tomto.
Taký tento adaptér.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomer. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabera. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
Okay, welcome back. Now we will have a very interesting talk by Maria Jose Molina Contreras about building an indoor air quality monitoring and predictive system. Welcome, Maria.
Now? Yeah, awesome. But before to start, I would like to know how many of you are you interested in do-it-yourself projects? Oh, 90% of the people. Nice. What about data science? A bit less, but yeah, awesome. Data analytics, sensors data. What about sensors? IoT. Okay, awesome. I think that we are going to cover all of these topics today, and I hope that you are going to enjoy about that. Well, who I am. My name is Maria Jose. As was mentioned before, I have a background in molecular biology. I work as a data scientist, and in my free time, I enjoy doing all these kind of projects, mixing all the topics that I love in tech using Python. And this is one of those projects. And how this started, right? It's like how one day I start asking myself or wondering why should do that. With the pandemic situation, my life, everyone's life changed. But at the beginning, I was working in an office, going every day, having an active life, and then suddenly I was working from home, no activity, and at some point, someday I start to feel kind of very sleepy, really tired, headache, and I could not understand what was going on. At the beginning, I thought, well, the stress, the situation, meetings, and these kind of things, until one day, in one of those moments, I opened my windows, and I stayed there for 15 minutes just thinking of, life, and suddenly, I started feeling better. And at the beginning, I thought, it was because I was complaining and relaxed and that. But no, I can tell you that was not that the reason, because once another day happened again, I opened again my window, and I start to feel better. And I start to think that something was not okay at my apartment. And I start doing some research. I started looking in publications, in different resources, what could contribute to the air quality in indoors. And then I found a lot of resources and a lot of information that I started to analyze. One of them was the number of occupants at home. It's not the same if you are 10 people at home than 2. And then this has some implications of how many windows you need to open or how much time you need to keep your ventilation on or long, etc. Also, have control of humidity and moisture are really important because some organisms like fungus love this high humidity and moisture, and this also has an impact in our health. The way that the ventilation design, in other words, how many windows do you open and how you open your windows? Did you thought at some point or at some moment, how do you open your windows at home? I just recommend that you start thinking about that, or maybe I will motivate you to do it after this talk. Also, the pollutant sources is not the same live in a small city that in a big city or close to a factory. It's not the same live close to volcanoes that in a desert. And also, there are others gases, right? Well, after all that, they say, oh, awesome, but I need to focus a bit because there are a long list of things that I can check and I cannot manage that. I went to the bibliography, the publications, and see that there was people working in the analysis of CO2 and indoors. and see how this could affect our health and our concentration. And I thought, wait, maybe this was my issue. Let's go for that. And if you take a look, just curiosity, the first publication is indicating that maybe, it's suggesting that maybe the levels of CO2 could have an implication of decision-making performance. This means that if you need to have an important meeting, open first your windows, because maybe this could have a better outcome for you. Well, what is about the CO2 ranges and health? I just wanted to share, to give you an overview, when we talk about air quality, what means. In the y-axis, we have the CO2 part per millions, and then we have the curve with the different evaluations of things that we can see. The thing is, under 1,000 parts per million, everything is okay. The quality of is considered that indoor, it's in a good condition. After that, it's starting to have it's considered not healthy. Of course, this is gonna depend on other factors. Depends also if you have previous conditions and lung, etc. Because, well, you know that it's not white and black. It's a more complex thing. And then I decided to start my project. We are going to go step by step. You are going to see how I build it, how I managed to put it all together, and what I got at the end. The main structure is I had some sensors. I was collecting data, and then built a monitoring system. With the monitoring system, what I was having is a track of the values. But even if it is really nice, I would love to know in advance when I need to open my window, because I want to have a healthy environment before to go to the meeting, for instance. For that reason, I thought that build a predictive system could solve or help to solve this thing. Well, let's start with sensors and how I collect the data. I use two sensors, really. On the right, here we have the CO2 sensor. And then on the left, we have the air pollutant. Even I mentioned that I was more focused in CO2. I wanted to have the system with both sensors to take as much data as possible to later make the decisions based on what I could see in the data. In the air pollutant, what we are collecting is data for particles. As smaller is the particles, more probability to have damage in our lungs, for instance, just to give an idea why it's that. Well, you're going to see that this project was not done by once. It's not only that you arrive and build it and everything is super okay. It's a real project. Then I did try. I kind of failed. Now that we're in confidence, I can tell you that I failed for some things. But I learned a lot in the process. And this is what I want to share with you. One of the projects that I decided to implement as first was using this sensor of particles with a Qt-Py microcontroller, because it was really small, and this would allow me to have a lot of mobility, let's say in that way. I ran it with CircuitPython, if you're not familiar with. It's a fork of MicroPython. It's a version of simplified Python. The challenge of this system, of this approach, is that I wanted to collect the data because I wanted to use the data. And with this microcontroller, I could not do it. In parallel, what I was doing is using the CO2 sensor with ESP32 microcontroller using MicroPython. Was working really good. The challenge that I had with this system is that then, once it was working, I decided to have 20 features more, because I am the worst stakeholder of myself. I decided that I wanted to have a screen that has interactivity, and then long, etc. And I had to move on to another approach. Then I jumped into Raspberry Pi, in that case with wireless, and I connect the two sensors to the Raspberry Pi. And as I mentioned, I wanted also to have this interactivity for the dashboard, because I wanted to have the dashboard, but in my desk, close to me. And also I wanted to have it kind of touchable. For that reason, I use a Raspberry Pi 4. And maybe someone is wondering, yeah, but this could be simplified, or this version another way. Yeah, it's true. But I had at home the Raspberry Pi 4, and I thought, why don't use it? Let's do it for that. And that was the full system. Then, what we had in the system was the two sensors where we were collecting the data. We have the connection for the two Raspberry Pis, and then we had this monitoring system in the Raspberry Pi 4 that we are going to see a bit later. But let's go to see how the data was looking for, right? In here, what we have is CO2, humidity, and temperatures in temperature in Celsius degree. And you can see some oscillations. What is completely normal, because you open the door, now is winter, then is summer, well, these kind of things. But what is interesting, and is something that we're gonna see later, is that we have some peaks around this value that it's very high. If you remember the first plot, I was telling you that a good air indoor quality, it was around 1,000. You're gonna see that something was not super okay. Then what I did is analyze how many times I was having those values. In the x-axis, we have the CO2 ppm with 3 different phases and colors. And in the y-axis, the frequency. Green means that it's considered okay. The orange is like meh, and in purple is no, this is not going okay. Especially the ones that we have here an arrow. At some point of this time, I was close to almost 2,000 parts per million of CO2, and this is very high. What brings me to the point to say, wow, it's really important to have control and monitoring of these values. Then, on the other side, we have the predictive system to kind of take in advance decisions before these arrive. In this case, if you're not familiar with, is more a time series forecasting. What we have, this is another example, just to show you how it works. In the x-axis, we have the time. In the y-axis, we have the census value. And in here, as you can see, something in time happened. And this is what I wanted to see in my system. Well, this is my plot. Sorry for that. I just wanted to show you in a big drama situation. And just to point you a couple of things, because I think that this plot, of course, it's not the best plot ever, but has really interesting things that we can kind of mention, right? In the x-axis, we have the index. In this this means that we have the time, but we convert it to an index. But this is how we manage the time series. But let's say that index is related to time, and y-axis we have the CO2 change. Well, let's start with the first arrow. Can you imagine what happened in the first arrow? Any idea why I have this oscillation and suddenly drop out, decrease so dramatically? Yes, I was not at home. I was not at home, which is really nice because I realized that the system was working okay. It was like, oh, okay, if I am not at home, I have that. Yes, that was that. And what about the second arrow? Because the second arrow, we have a decrease, but not at the same level. Any other idea? Really good answer, but no. The thing is that I changed the way that I was opening the windows. I changed, I start playing to open the windows in a different way, in a way that I could change the flux of air and the ventilation was different at home. And this has an impact on time. And then I forgot it, as you can see. I continue doing it randomly. And of course, in here, we have a huge peak that came because I had visit at home. And then as more people you have at home, more the CO2 level is higher. Then you need to kind of change the habit of how you are opening the windows. And what about this decrease? You can see the tendency is decreasing on time. Some idea? Yes, summer arrived and I open the window more frequently because I live in Germany, it's very cool, and so it's like, okay, it's open, yeah, it's closed. But then the good weather arrived, and then it was like, oh yeah, now. Yes, this has an important role. Well, then for the predictive system, after analyzing all the data, learn from my own mistakes of how I was opening and closing the window, I started doing research of how to implement the predictive system, right? And there are a lot of ways, and there are a lot of solutions. In that case, I also went again to the bibliography, and I found this really interesting publication that was collecting different approaches. And I decided to implement one of those. In this case, was this one, because I was having I was having the data from temperature, humidity, and CO2. But to be honest, I did my own version of that. Because at the end, what we need is doing work for us. And what I monitor and I collect this was the CO2, the humidity, the temperature, the particle, but also the activity level, because my sensors were located in my office, because it's where I need to have this information, this tracking. Then let's go very focused, because if not, we are not going to have time. But one of the most important things is that I create a Windows system where I had a period of time, and then I predict in 1 hour. And then have this moving window and prediction once and once and once. I use CNN. I'm not sure if you are familiar with this kind of architecture. We are not going to have time to go deep on that. But just to show you just a schema how looks like this architecture. In here, I usually love to see that in the presentations. For that reason, I add it. But if you are not familiar with neural network or you don't work in data science, no worries. I just try to also summarize different information here. But the most important is that to know that, well, I was using a convolutional 1D, where I was analyzing and extracting the features along the time. I have these window size that I was mentioning you, and also I was adding these features. That was temperature, humidity, CO2. And then I predict the CO2 value in 1 hour on time. Let's go just really briefly. For me, the metrics was more focused in root mean square error to performance. And for hyperparameters, it's tricky, let's be honest. And as it's a data science project, it needs to be iterated. For performance perspective, the windows, I pick some random days, and then I predict the values. But how good it is depends a lot about the window. Just to show you as a result, what we have is in here we have 3 plots that are normalized. In green we have the labels, and in orange we have the prediction that are these. And as you can see, at some points the predictions are quite good, and at some points are not super accurate. And even at some point we have some drift on time. Yeah. Then let's start to finish. In here, I didn't mention before that for displaying the monitoring system, I use a Flask application. Very simple, you're gonna see. And let's see how looks everything together. Well, this is a longer story, but I didn't know how to manage the sensors and the things in a really aesthetic way. And I had this frame with a picture of my sister. And I thought, OK, why don't put the sensors there? Yeah, and I removed my sister's picture. Don't tell her, don't share this information with her. But yeah, it's really easy to handle, and also it's kind of more aesthetic, in case that you don't want to have everything there. But yeah, this is how looks the Flask application in the Raspberry Pi 4, and you can kind of interact with it. It's very simple, of course, and also you can do it. And here is a very short demo that you can see that change the prediction, and when change the prediction, also change the color. What is work in progress? I want to implement the same system, but using microcontrollers. That was my first idea. I am doing this version using TensorFlow Lite for microcontrollers. I could not integrate the particles information in the model. This is a longer story, but it's something that I think that I needed, or I am interested. And of course, needs optimization. This is not the final version that I can deploy tomorrow. Well, for home, yes, but not for other things. And yeah, I just would, if you want to be in touch or want to be more, I will be happy to share more info. And at some point, I'm going to also share all the code in the GitHub, and also you can also implement your system with, as I did it. Thank you so much.
Thank you, Maria Jose. We have several questions, so let's get into them. The first one, what is the approximate budget for a project like this? I was looking into CO2 sensors, and they are not exactly among the cheapest.
Yes, the most expensive, I think that is the CO2 sensor. Let me remember, I think, but it's not super expensive, but I can share later on the specific price, but it was around 40 euros. Yeah, but if you compare with other sensors, like moisture sensors that you can take, you can have them for very low price, 40 start to be high. But I can give you more info later on. I will be happy.
Is the concentration of CO2 the same in all places in the room? Do you have some fan to make the air mix and change around the sensor?
Oh, really good question. Honestly, I have all my sensors only in one room, and I didn't move my sensors around home. And I don't have an active ventilation system, what means that I only know how is the air quality in my office, to be fair with you.
Sounds like an experiment for Pycon 2023.
Yeah!
What do you recommend for people who want to start with microcontrollers? MicroPython or CircuitPython?
This is really good question, and it's I have several discussions about that. I think that both of them have pros and cons, as everything in life. For instance, CircuitPython, one of the things is, as Adafruit is behind this fork, they have a lot of tutorials, beginner-friendly. And then it's really easy to start, because you can follow a tutorial, you know which cable you can connect, and then can provide you more easy start point. But at the end, I think that depends, because for instance, here in this conference, there is a workshop about MicroPython. What I was super excited, a bit sad because I could not be there because I was in my talk. But it's, I think that depends. I'm pretty sure that if you go to this workshop, you can start really easy program microcontrollers with MicroPython without any problem at all.
Did you try to measure and mitigate factors other than CO2 in your room, such as humidity or other pollutants?
Yeah, there was included in the system the humidity and the humidity and the temperature were in the system too. The thing is that what was not considered was the pollutants. But yeah, it's a future work.
How much time did it take you to put it all together? And maybe I'll extend that a little bit. Now, with all the knowledge that you have now,
yeah.
How long would it take for someone else to start from scratch?
This is a really good question. I think that it depends, because depends how it's your knowledge of Raspberry Pi, for instance, right? If you are new on that, or if you are not confident programming, or depends. Right now, if I had everything at home, and let's consider that you know everything, for setting up the microcontroller sensor and that, it could be weekend project. The thing is that for the data science part is longer and more time consuming, because you are going to need to check your data, check that everything goes okay, and then decide which is the best machine learning approach, because I show you a neural network, a deep learning approach, but maybe you don't need to go that. Maybe in your system you can use just for time series forecasting machine learning or other approaches, because I saw that other people was developing other solutions. For the data science part, you need a bit more time.
Now that you have gone through the trouble of putting it all together, your data and your code, is it available somewhere? Are you planning to publish that?
Sorry?
The data and the code that you have written, data you have collected and code you have written, are you planning to publish that somewhere, or is it already available?
I'm going to share it in GitHub. But I need to organize it a bit. Let's be honest. I need to organize the project a bit before sharing. But my idea is, yes, have it open, and then people can go there, use it, and improve it. Because we need to improve the system, and maybe people can even contribute to improve the system.
Very nice. So we'll look for your name on GitHub and look for the repository. Excellent. For predictive purposes, how much do you think that placing a sensor on the outside would help? I mean, as a small in- and outdoor network of sensors.
The thing with outdoors, for instance, the sensor that I show you, it's for indoors. Because at the beginning I thought, oh, maybe I can put it indoor, outdoor, and play with that. And this specifically is for indoors. Then I don't have, to be honest, I don't have a lot of knowledge about versions or models of a sensor for outdoors. But I can point to you some manufacturers that are working on and the expertise. Yeah.
Another one is not a question, but a comment. There are IKEA sensors, and they can talk to the C report.
Awesome.
What tools do you use for interpolation of missing data, such as when there's a communication error?
Oh, really good. Well, I directly use my own knowledge in data science. And the good thing is that I didn't have a lot of errors or null values or discalibrations. Then I didn't have to do so much. But what I did is just take a look to the data, analyze it, and make decisions based on that. And yeah. But we can discuss later if someone has this issue, what specifically approaches you can use it.
And you already commented that you did not move around the sensor, but can you move the CO2 sensor around to different rooms? Or is it better to keep it in one place close to you? So it's kind of like, what do you think?
You can do it. You can move it. The thing is that this sensor, if you're going to move it, they recommend that you, once you take the values of the CO2, take it in some distance that you have enough time to go from one room to another. Because once you move the sensor, what is happening is that you are affecting to the measurement. Then it's not, I think that this kind of sensor is designed to have it more fixed, probably to have more than one at home or wherever you have it, and then collect this data, pull it, manage this data from the different devices. I think that the best is that. The thing is that for this project, I wanted to have it only in one location. Also, to be honest, also price-related topic, because as more sensors that you have, more expensive, and also my apartment is really small. And then it's quite easy to have kind of control of the environment. But yeah.
Thank you so much, Maria Jose.
Thank you.
Okay, and as Petar Dolák prepares for his talk, which is going to follow now, one announcement to make. There is a sign-up sheet for the Lightning Talks. How many of you went to the Lightning Talks yesterday? Out of those who went, keep your hand up. Out of those who went, how many of you loved them? Oh my goodness, even more hands up. So it looks like they were quite popular, and they're a very popular part of Pycons. So if you would like to give your own lightning talk, as you saw yesterday, it could be anything. It could be making music. It could be how do you properly tie, how do you wind up the cables, or it could be anything really. So you can sign up. The sign up sheet is outside of the Titans room, and yeah. That's something that might be worth checking out. Number two, as you saw here, this was the start of a discussion. So you can go ahead and hack on this project. Now we have some basic ideas how to start with measuring indoor air quality. There are questions about adding an outside sensor. There are questions about moving the sensor around. There were questions about adding other sensors for humidity and other pollutants. So this could be absolutely worth checking out. So This is a great place to get started. You can talk to the speakers, you can talk to each other, brainstorm about ideas, and keep improving on what has been discussed here.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomer. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
Hej, ten je.
Už sú zapnuté?
Hej, teraz som ich zapol a idem povedať zase, kedy.
Next up, we have Peter Dolák. He's going to be talking about data modeling and data validation. If you'd like to ask questions, as you know, you can use Slido, and we're really looking forward to this talk. Welcome, Peter.
Hi, so I'm Peter from Bloomreach. And which of you guys are familiar with a subreddit called Programmer Humor? Hands up. Yeah, quite a lot of you. It is quite popular, and occasionally it's even quite funny, and not always. So maybe you have seen this stuff on there. Basically, it tries to give you some true description of programming languages. You don't have to squint your eyes. I'll go through them in a minute. So what does it say about our beloved Python? What if everything was a dict? Well, that's not nice to say. Maybe others. Java, what if everything was an object? JavaScript, what if everything was a dict and an object? C, what if everything was a pointer? C++, what if we added everything to the language? C++11, what if we forgot to stop adding stuff? Perl, what if shell, set, and awk were one language? Perl 6, what if we took the joke too far? And PHP, what if we wanted to make SQL injection easier? Yeah, okay, so some of these are quite funny. Unfortunately, even more of these are true. So is it true that we tend to overuse dictionaries in Python? Well, sometimes, maybe. An alternate name for my talk could be, what if everything wasn't a dict? So this is an example of some code that I wrote just for this talk. Don't worry, it's not actually in our production, and it's done on purpose. And maybe you yourself once find yourself writing code like this after an especially bad night. Why is it bad? Well, it's basically a Flask view which deserializes some data from JSON, and then basically when it tries to process this data, it will just use dictionary lookup to see these items. So what is so wrong with it? Well, for example, the structure of this data is very mysterious. I put this example of some data that might come to it here. If you didn't have that, you would have no idea what the data actually looks like. Also, it doesn't have any typing, so you have no type safety, and for example, you have no idea if what you're putting here, which should be a string, is actually a string. And then there is some attempt to validate this data, but as you can see, it's very basic, and it is missing a lot of issues that the data may have. So for example, these items might be missing here, or maybe this is not a string, it's an integer. Maybe, so you could also have a key error, you could have a type error, for example, when trying to iterate this. Maybe there's some attribute error in there, I don't know. So generally, code like this is quite clumsy, and you shouldn't write it like this. So what better options do we have in the standard library? Well, aside from this, which I named why it's so bad, you could, which tries to model this data, basically a class for every dictionary within the data. And this is fine. You can write some types in there and have at least that, but you will have to write a lot of boilerplate code in order to initialize these classes, in order to validate them. You can encapsulate the validation in there, but it will be still a lot of code and it's easy to just forget to validate something like that. And plus, programmers, we are lazy, and we are right to be so. We just don't want to write boilerplate code that can be avoided. So one of the things that can help you with this is data classes. Data classes will basically write some of these methods for you, like init. An issue with data classes is that, for example, if we have some data like this, which has a dictionary or a model within another field, it won't be initialized by itself, by data classes. You have to do all this stuff yourself. And then data classes, of course, have no support for validation. They, in fact, don't even validate whether the data you have supplied in those fields have the right types. So is there anything better we can do? Well, you can use some library. And I don't actually know what these libraries are called. I'm going to call them data models, but it's probably wrong. I've heard people refer to them as input data structures, data validation libraries, advanced data classes, so, yeah, something like that. So when these are not appropriate, mainly if you are already using something like Django or SQL Alchemy, which models your data with these libraries because it's actually mapping to some relational database. So in that case, you're good. But maybe you are writing some code that works with a database like MongoDB or Bigtable, which maybe don't have the best libraries for that, and that's ideal for this. So you can initialize the data that's coming from a database into these advanced data classes, let's say. You can also work with some complex definitions that either come from a user or from the database or configuration structures. Maybe you're trying to actually validate user inputs as well as possible. And maybe you just want to write classes and avoid some boilerplate code like data classes do. So in my company, Bloomreach, we were previously known as Exponia. Over 9 years ago, before I even joined the company, a year before, we chose to use a library called schematics. Is there anyone familiar with this library, schematics? Not a lot of you. That's surprising, and I think it's good because it sucks. And you can see how it is being used. So basically, here you can see some classes that you might have written yourself, giving them some typings. And then you are defining some kind of a descriptor for each field, which will say what type it is, whether the field is required, what defaults does it have, maybe even some basic validation. And the way schematics works, you can actually initialize them with the data like this. So you just take the JSON, which is some dict with some lists and stuff like that, and you just initialize it, and you get a nice instance or a structure of instances of these classes. So that's all good. Then you can also validate this data. This may raise some validation error, which you can handle. Schematics will also actually give you multiple validation error from one request, so you can just report them all, or maybe just the first one if you so desire. And you can just access the items using, as an attribute, so which is nicer. And if you actually supply types here, in schematics they're optional, or rather schematics doesn't care about them, then your code actually will be type safe, or you can use the type checker. So that's relatively good. And if anyone here is considering using a library like this, please don't use schematics because it's just not very good. So what are problems with it? First and foremost, it's performance. We recently found out that in Bloomreach's Python services, schematics is often taking 10 to 30% of CPU cycles, which is horrible. That's like truly awful. Like, I don't want a third-party library to take up all of that CPU time. I want my suboptimal application code to take up that useless CPU time. And it also isn't great for memory. It actually will take up to 3 times more memory than if you were just using raw dicts and lists and stuff like that. Then, as I said, there is no native support for typing, so you can add them, but schematics is not able to benefit from them at all. And you also, if you have a lot of these classes, like in Bloomreach we have actually over 1,000 of these schematics models, then, and you actually are importing all of them when your applications, for example, a Flask web server is starting up, this will take quite a lot of time. It can even take 2+ seconds, which is nasty. For example, if you're just wanting to run one test. And I just think that schematics doesn't have the best user experience for many of the reasons I mentioned, and some I didn't. So I decided maybe a year ago that I wanted to find a replacement, or maybe not find one, because the schematics was just too slow considering the stuff it was doing. It wasn't actually that difficult, and we needed a better library. So I just said, how hard can it be to just not search one, to write on my own? Because yeah, why would you spend some 3 boring minutes searching for a better library, existing library, when you can spend 3 exciting weekends writing your own, right? Right? Okay. Well, I don't know if it actually took 3 weeks to write Stereotype, which is the name of my library, but I know I spent at least a quarter of that time just thinking up a good name. Naming is indeed the most difficult problem in programming. So let's see it. You can find it here on GitHub. I'll post a QR code later. And basically, just like in schematics, you will also be defining some fields and some models. Basically, the models are modeling dictionaries within your data, at least the ones that have a rigid structure. And the fields are defined modeling their keys. And then, when you want to define a field which is of type string, you just do type string just like in data classes. And this will be a required field that has no default. And it cannot be none, because obviously there is no none in the typing. If you want to give it a default, just like equals default, just like in data classes. And if you want to specify some advanced options, then you can use a class like a field class like inField, and then specify some minimum value, maximum value, stuff like that. You can also use, of course, models recursively. So I can have a list of these models. And you can even specify a default like an empty list because the library is smart enough to realize that you probably don't want the same list shared across all your instances that have a default. And you can also pass some custom validators, and you can have optional fields that can be none and all that good stuff. So yeah, the basic usage is very similar to schematics. So basically this code, if you were using a stereotype model, would work almost the same, just a different exception, maybe a nicer one. Okay, so let's talk about some features that I added. You can see these on the GitHub, but I'll just go through them quickly. Currently, it has all the field types that are supported in JSON. I didn't bother adding much more, but I probably will later. So like you can have bools, lists, dicts, anything. Then you can also use other models, even recursively. So one model can use itself as a field as many times as you wish, probably not infinite times. Then you can have dynamic model fields. So it can be a union that will, and stereotype will determine which of the classes in the union you actually wanted to use based on some key called type in the field, which is just some string that discriminates it. I even included a schematics model adapter because the library was basically written for us to replace schematics with it, and you probably don't want to do it in like one huge commit. And you can also define your custom fields. And for validation, there are some basic validation options like you saw, for example, like min, max value, length, choices for string, regex, and stuff like that. You can even define custom validation with some field-bound callbacks or some instance-bound validator methods. And aside from that, you can also validate stuff without, convert stuff without validating it. So you would have a separate validation call, and if you, for example, are receiving your data from a database and you know it's safe, you don't need to validate it, you can skip all that. And it will also report all the validation errors with their paths. So for example, you can write some front end that will localize all the errors that are received from backend to the actual fields where the error was. It also has some like calculated serializable fields. You can adjust the names, both in input and output, hide zero values, and blacklist some fields based on roles. Okay, what are the alternatives? Because I'm not claiming that my library is the best. So who here is familiar with Pydantic? Yeah, more of you than for schematics. The answer is probably depends which one of these is better. I'm just convinced that stereotype is better for our use case. So Pydantic is very feature-rich. It has built-in types for probably just about any type you can encounter in Python. And it has some very nice features, stuff that you can do with models. For example, you can generate documentation. Pydantic is the base for Fast API, which someone will talk about later today. It also has some amazing support for type checking, even better than stereotype, I must admit. It has even plugins that you can use in your favorite type checker or IDE that will allow you to check types even more thoroughly than Python could do by itself with just using the typing library. Some disadvantages is that if you have some data that is already trusted and you don't need to validate it, you cannot skip validation in Pydantic. I've been looking for that. I only found this construct class method, but that's not recursive, so it will only initialize one model. If you have some other model as a field, that will remain a dict. So it's not really useful for much, except for really simple models. And also, I think the way Pydantic will offer you to do validation is somewhat clumsy. You basically just have to use some weird class method, which I think will just easily break during any refactoring, and you don't have these like easy options to validate some common stuff, like minimum value for some number. Although it has a lot of types which have some basic validation, but I don't think it's that great. Attributes, or actually, which one of you is using this library? Okay, so do you know what it's actually pronounced, how it's pronounced? Because I have no idea. Maybe it's ATTRs, maybe it's attrs, I don't know. But this is a library with a simple premise. It basically says that it will only add some double under or dunder methods, like init and stuff like that, and won't mess up your namespace in your class with some other methods. And you have some like helper functions, for example, to serialize the data and stuff like that. It has insanely good performance, but conversion of fields is very hands-on. You basically have to write the conversion. If you want the field to convert, or basically just ensure a field is an integer, you have to include like a specific call to the int call. So it's not that great. It's kind of hands-on, and it also cannot really disable the validation. It can only do so globally, but if you need to disable validation only for like one call, then you're out of luck. Okay, so let's see some benchmarks. I just included a quick slide regarding the setup. So if you're interested, here's what the data looks like. This is a function that generates them with depth4. And it has some short string, bools, lengths, stuff like that. And it will convert the data, try to validate it if validation isn't even supported, and then convert it back to the raw dicts. So let's see some benchmarks. As you can see, I use data classes as some baseline for the benchmarks. Whoa, that's slow. Yeah. Schematics is slow. How slow is it? That I managed to write my entire library just while this benchmark was running. Yeah, not really, but it is slow enough to make all the other libraries basically be these bars are just too tiny to tell you anything meaningful. So I'll just hide schematics and let change the maximum on this. Yes, infinity. So as you can see, schematics is super slow. Pydantic is a lot better. It is actually only just about twice as slow as data classes, even though it is doing a lot more than data classes do, including the validation. I'm not including some data from conversion because it cannot do that. Then ATTRs, as I said, are crazy good in performance. They do have like this global field, global stuff that you can disable the validation everywhere. It won't even help much unless your validation is super expensive. And so what about my library stereotype? Well, maybe. It's a little bit faster, especially if you're not doing validation, then you can squeeze more performance out of it than attributes. But as you can see, if you are doing validation, it is a little bit slower. But we'll come back to the CPU benchmarks. I still have one trick up my sleeve. As for memory, this benchmark kind of over-exaggerates this because the data has like really small strings, which are not just really realistic for real-world data. So here we have like 11 kilobytes of JSON that take maybe, I don't know, 60 kilobytes when converted to dicts and lists when deserialized. Data classes will actually even do a little bit better, funny. Then schematics is, of course, the worst. And then Pydantic is a little bit better, just about 2 times as big as if you had just the raw data. And then attributes and stereotype are so much better than even the raw data. How is this possible that it is able to use less memory than if you just stored it as dicts and lists? Some of you might know it's because of slots. Are you familiar with slots? I don't think I'm going to preach to the choir here too much, but actually not many of you. So slots are something that can help you save some memory and even some CPU by defining what attributes your class is allowed to have. And when Python has this information, it can use an internal tuple to store the attribute values in your class instance instead of using an internal dict. And obviously, a hash map, a dictionary, is just not the most memory efficient, even though it's great in Python. And it will also speed up the initialization time because it is much easier to initialize a tuple, and it requires fewer allocations than to initialize a Python dict. And also, it has slightly faster attributes access, so you will even save some CPU there. But it is kind of cumbersome to include this slots declaration in your classes when just the compiler knows which fields you are using if you're doing a model like I showed you previously. So stereotype and even a bunch of other libraries, for example, attributes or attrs will do that too. And you even have some libraries that just do this one thing. It will auto-slot the class for you. And basically, you just in stereotype, You just write your class, and it's automatically auto-slotted. You can disable this if you don't want it, because it has some issues with multiple inheritance in some cases. But it will give you this nice benefit. I actually did some benchmarks and found out that thanks to slots, the classes were taking only a half of memory, and even CPU increased a bit. OK. Another thing that stereotype does, which I wouldn't say it pushes Python to the limits, that's just clickbait to get you in here, but it's kind of interesting, is that it parses the type annotations at runtime in order to know what fields your classes should have. And it uses a couple of functions within the typing module. Get type hints will actually, will take a class and give you what type hints you have defined. Then you can use get origin to parse some complex typing, like for example for the list, and get args to get the things that are the arguments to the list and dictionary typing hints. So this is cool, and it allows you to say writing some code. You don't have to specify the type, with some field class in stereotype. If you only are using the basic options, basically, if you're satisfied that the field has no default and is required, cannot be none. OK, so maybe some general tips before we dive in more into performance. Avoid deep copy. It's the main reason why schematics is so slow, because deep copy is just way too complex to be efficient. Simpler is often better, so avoid trying adding many features that you don't know if you will need if you want to keep your code performant. Then just this simple, stupid thing, this is faster than this. And try to delay allocations of, for example, an empty list unless you are actually sure that you need to use the list. Don't create objects that should just to throw them away. And another thing you can do is try to avoid some repetitive work. So for example, in this case, we have a list comprehension, which is trying to convert some items with some convert function that is the method that includes 2 attribute accesses. But these attribute accesses are same for every iteration. So yeah, just extract them outside. And this will actually make this code 2 times faster, which is really a big deal, if convert has no overhead, if it's just an OOP. So this is simple. Let's take it a bit further. This is an example of code that does the initialization. It's very simplified. But basically, in every instantiation of a model, it will try to do a lot of these attributes accesses to extract some metadata about the fields, right? And all of these will cost you some CPU performance, these attribute accesses. So, you are only running this code once when initializing a class. So there is no, you cannot extract it to a local variable. That won't help you. But you can only do this attribute access during the initialization of the model class, which is done only once in your program's lifetime. And basically, what I did was do this attribute accesses just once and then store them in a tuple. And tuple unpacking in Python into some local variables like this is super fast. So that's great. And then you just have to use these local variables, and this also improved the performance drastically. There is still one more thing you can do, because, for example, here I'm asking about something that is some meta information about a specific field. But I don't want Python to, every time when it's initializing this field, to check this attribute, which it should just know that it's like it doesn't allow a primitive name, so it shouldn't serialize and stuff like that. How can you force Python to do this? Well, it turns out, and I hold to your seats, Python is an interpreted language. OK, guess you know that. But that means you can actually compile code during runtime. And you can generate some stuff that will make your basically, at runtime, you will generate code that knows exactly how to run or do the things you need in the fastest way possible. And then just you use a trick like this to extract this generated function, which is just then a normal Python function, and run this instead of some code that would be more complex. So how about the benchmark? Yes, it's finally faster than attributes. Nice. OK, that's what I have. Time for your questions. If you guys want to use this library or just check it out, maybe just scan this QR code or go to the link and maybe give it a star so that you don't forget. And now I have time for your questions.
Thank you. So I already closed a couple of questions because you already addressed them, so comparison to Pydentic and others. What about daytime support?
Yeah, that's something that we even actually did in our closed source repository, which is using Stereotype right now. I will probably put it into Stereotype, and even a lot more types. Just time is short. I only have so many weekends.
What about the benchmark methodology?
Yeah, so for these benchmarks, I show you what data I was using. That's so far down there. Yep. And I was basically running it thousands, maybe 10,000s of times to just fill up some time. And I don't know, maybe you could specify what exactly you're talking about, because I don't want to be, talking about too simple stuff in benchmarking.
Maybe that's something to take to the hallway track, right? And discuss. Maybe that's something to discuss after the talk. Sure. Whoever asked the question, feel free to approach Peter. And nice talk. Have you considered implementing the core of the library in another language, such as C or Rust, for performance?
This is actually something that I think the attributes library can do. It has some C extension called C attributes or C atters. And no, I haven't considered it because I just wanted a library that you can just plug in and use without having to even download a wheel. But it is possible. Not sure if it's worth it because it's already quite fast. And my goal was just writing something that's faster than schematics. And it's like 10 times faster for conversion and without the generation hack. And up to 40 times faster with validation. So good enough for me.
That was our last question. Big thanks to Peter Dolak.
Hej. Dúfal som, že to nebude.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomér. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
Dobre, chceme tvoj. If you would please find your seats. Our afternoon session is about to start. Thank you. We are about to hear a talk that I'm personally very excited to listen to. I'm so happy that this was made possible. We're going to spend the next half an hour with Tom Dyson, who started a project called Wagtail. Do you know what Wagtail is? The content management system. And I'm very excited about welcoming Tom here. Not only because he was so gracious and so generous. The email thread, I just checked it. It was more than 50 emails to make this happen. And Tom agreed to come to Pycon 2020, and which did not happen for the reasons we discussed yesterday. And that just kept being postponed. And Tom was just so gracious and so patient with being willing to come to us. So I'm so happy that it finally happened. And he will introduce himself in more detail, and we'll talk about happiness with Python.
Thank you, Jan. And thank you, everyone, for the warm welcome. I'm very happy to be here. As Jan said, I was first asked to give this talk in November 2019. And then as COVID spread in early 2020, the first feelings of doubt crept in. And it's funny looking back on the emails from Jan who said, well, we might just have to delay it 6 months, but everything will be okay by then. Anyway, here we all are in this beautiful city, 2.5 years later, 2.5 years older and wiser. And I'm going to give the talk pretty much that I was planning to give then. So the idea of the talk is roughly the same, but I think in the last 2.5 years, maybe it's taken on even more relevance. I hope so. It's not a very technical talk, but I hope it might be relevant to some of you. And thank you for giving me half an hour of your attention. So I'm starting with this idea, which feels very clear to me. Learning to program is like gaining a magical power. In particular, I think Python, with its deceptive simplicity but huge ecosystem of tools and libraries, gives you the ability to automate, accelerate, analyze, combine, create, and as every part of our lives becomes digitized and connected, developers like you gain influence and power and fortune. And the purpose of this talk is to suggest ways that you might use that power and influence. First, I'm going to talk briefly about my life, not because it's an unusual story or the best model, but because I'm older than most of you, and most of my career is behind me, and it's easier for me to learn lessons from the past than to make guesses about the future. And then I'm going to share some assumptions about you, and afterwards you can all tell me that I got it wrong. And then I'm going to talk about the type of work you could do with your special powers, and maybe some of the kind of work you could avoid doing. Finally, I'm going to talk about the way that you work, and suggest some ways that might bring you even more joy than you feel already. So first up, this is my story. I was born in the UK, which was basically a safe and prosperous country in the 1970s, and still is now, even if it feels like we're locked into a steady decline. My father was a doctor, and I was brought up in a comfortable environment with a good education. When I was 18, I spent a year teaching in Zimbabwe, and I went there with a classic white savior complex, but I grew up quickly. I studied philosophy at university in the early 90s. I was idealistic but naive, and I had no idea about what I was going to do for a job. When I finished my degree, I was surprised that many of my friends started jobs in banking or advertising. I got a job with a tiny book publisher, just one guy in a small office in Oxford. He asked me to make him a website in 1996. So I taught myself the basics of HTML, and I launched his site, I think around the same time that Internet Explorer first came out. And then suddenly everybody wanted websites, and there weren't many people who knew how to make them. In 2000, I started an agency called Torchbox with my business partner, Ollie. We were both clear that we wanted to work on ethical projects for clients who wanted to make the world a better place. We grew slowly but steadily. In the early days, we worked with Perl and Cold Fusion and Java, but in 2005, we adopted Python, which was fairly niche at the time, and that's become our focus ever since. In 2013, we started to work on a new content management system for a famous arts university in London. Soon after the launch of the site, we open sourced the CMS, which we called Wagtail. Wagtail quickly grew in popularity, and it became the most popular Python CMS. It's now used by Google, NASA, Apple, Mozilla, the UK National Health Service, hopefully some of you, and thousands of other organizations who you've never heard of. Wagtail helped Torchbox grow. There are now over 100 staff, mainly in the UK, but increasingly around the world. There's people in the team from 5 continents. In 2019, my co-founder and I sold the company to the employees. So now everybody who works there is an equal owner of the business. It's quite an unusual and interesting arrangement, and I don't have time to go into it now, but if any of you are interested, I'd love to talk about it afterwards. I now just spend 1 day a week at Torchbox, but they seem to be doing very well without me telling them what to do. As a result of the sale, I'm financially comfortable, not like Silicon Valley money, but I've enough that I can choose projects that interest me, even if they don't pay so well. And I'm not saying this to boast, because the truth is that I was never a brilliant programmer or a natural entrepreneur, and I found managing people hard. The point of telling this story is really to highlight how much of it was down to luck. And this is something I've only kind of beginning to realize recently. I was lucky to be born in peacetime in a safe country with good education and healthcare, to middle-class parents who loved me and supported me. I was lucky my boss told me to learn HTML just at the time that the web exploded. I was lucky to choose Python, which was quite obscure in 2005, but has since become one of the world's favorite programming languages and looks to continue growing, thanks to its role with data science and machine learning. I was lucky to hire some brilliant employees who could have earned much more money in the commercial sector but wanted to work on meaningful projects. But there were 3 things I think that weren't lucky, which I've highlighted here: our commitment to work with ethical clients, the investment we made in open source, particularly in Wagtail, and the way that we passed on our business to the employees, rather than selling it to a bigger company. And I guess the lesson from this part of the talk is that these are also the things that I feel most proud about and which have brought me happiness. So now I want to talk about you. I only arrived in Bratislava last night, and I've hardly met any of you, but looking across the room, I'm going to make some assumptions. So on the whole, you're young, you're almost certainly clever, you're probably the citizen of a high-income country with strong economy and excellent infrastructure for health and education. The fact that you're here on a Saturday suggests that you're motivated. If you're clever and you're motivated and you're into Python, your skills are in demand, and hopefully it feels like that already. This puts you in a strong position. You can do interesting, challenging work, and you can make money. I want us to spend a moment on the interesting, challenging part. Something I've learned from hiring lots of clever people is that while salary and seniority and nice colleagues and work-life balance and supportive environments all matter to a certain point, the fundamental joy of work for a lot of people, particularly developers, I think, comes from accomplishment, from solving problems that at first seemed impossible. And if you don't have some of that in your work, you go stale. I have a theory, which probably isn't original, that's why web development's become so complicated in the last 10 years. All the build tools and the maintaining client state and learning a new JavaScript framework every 6 months came about because web development got too easy and clever developers needed new challenges. So, of course, there's nothing wrong with doing interesting work and making money. Those are things to be cherished and applauded. But I'd like to suggest that you direct your magic powers in ways that also make the world a better place and ultimately bring you joy. So what kind of work might this be? There's a quote from a few years ago, which some of you might have read or heard. The best minds of my generation are thinking about how to make people click ads. Have you heard this? Have you seen that? I don't know much about Jeff Hammerbacher, except I think he was at Facebook when he wrote it. And I'm sure it's an exaggeration, but there's also some truth in it. Somehow these tech giants managed to create a vision of a work environment based on ideals like connecting the world or organizing the world's information. And lots of very smart, creative people went there to work on hard technical problems. where they made big strides and came up with things like TensorFlow and React and Kubernetes. But eventually all in the service of making people click more ads and buy more stuff. I'm not anti-capitalist. I don't think I'm even anti-ads, and I definitely don't want to upset any of the lovely sponsors who are supporting this. But I do think there's some more important work that you could use your magic Python skills on. And I'm interested, what do you think are the big problems facing the world today? If anyone's brave enough to shout out a one-word answer on like the biggest problem in the world today.
Climate change.
It's definitely on my list. Any others?
Hunger.
Hunger, yeah. So this is a depressing conversation, and writing out this list is scary. These are my top 4. They're all big, scary subjects. They're all related, of course. And I think it's easy to feel helpless in the face of mad nationalistic dictators or unexpected pandemics or rising sea levels. And I'm not suggesting that publishing a new library to PyPy is going to stop China from invading Taiwan. But there still are meaningful ways that we can chip away at these problems with the tools available to us. So I'm not going to cover all 4, but let's take disease, for example. I heard something really interesting about bespoke drugs recently. Maybe this isn't a new concept to you, but it was to me. It turns out that when doctors prescribe drugs, they don't really know how well they're going to work on you or exactly how many you should take, because everyone responds to drugs differently. But the way that we respond to drugs are pretty clearly expressed in our genetic profiles. So there are some labs in Europe who are building databases which match genetic profiles to drug responses. At the same time, DNA sampling is getting cheaper and easier. It's almost like a commoditized service now. But the DNA sampling people don't have the tools to map their results to the drug response data. That sounds like a job for Python. Imagine if you were the person who wrote the Python script that connect the off-the-shelf DNA sampling kits to the drug effectiveness labs and then created reports that help doctors prescribe exactly the right drugs and dosage. That data's already there. Just need someone to come there and connect it. You could have a huge impact on the history of medicine. And it doesn't have to be as grand as that. I don't know what it's like where you go and see the doctor, but where I live, in my experience in the UK, when I see the doctor, I get 15 minutes. 5 of those, the doctor is trying to find my details on the screen, and then recording it on another one, and then he prints it out and gives it to the receptionist, and it gets lost. And all over the world, medics are struggling with inefficient systems, which are wasting their time when they could be making people better. I think if any of you spent a day watching a doctor work, you could find a way to automate some of their unproductive work using Python. Maybe you'd maybe you'd save them 20 seconds for each patient. Or you could create a business around that and end up saving more lives than if you'd studied medicine yourself. Or if your Python skills are focused on data science, I think wearables are another huge opportunity that could tackle disease and save lives. Lots of people wear basic sports watches like mine that record GPS position and motion and heart rate, or more sophisticated ones like the new Apple Watch that came out last week that records temperature every 5 seconds. This can help users track and understand their menstrual cycle, which is, I think, a really important development at a time when we're just starting to understand more about the role of the menstrual cycle in women's responses to drugs and diet and exercise. But you don't have to be Garmin or Apple to use this data, and perhaps it's better if it's not Garmin and Apple using all this data. A friend of mine had a very small startup which analyzed data from sports watches and then used machine learning to suggest completely bespoke training programs, a bit like Strava, but with machine learning. This data is available to you through APIs, and Python's a perfect tool to help you identify patterns which might help people understand their sleep or diet or exercise and change their behaviors to reduce the risk of disease. And I'm afraid I only caught the end of Maria's talk on building an air quality monitoring system, but that to me sounds like a perfect example of using Python in a creative way where it could have a real impact on public health. And I'm looking forward to seeing her code when she open sources it. What about climate change? You probably can't persuade the US or Saudi Arabia to stop pumping oil or China to stop burning coal, but I think you do have the tools to make an impact. And again, unfortunately, I missed this morning's session about solar energy analysis because I was in my hotel room practicing this talk. But it sounds like a fascinating example of this point, and I'm looking forward to watching the recording later. An area maybe a bit related that I've been interested in a while is something called dynamic demand. So there's an electricity grid which supplies the whole country, and the people who run that grid are working the whole time to avoid blackouts without burning fuels unnecessarily. Ideally, we'd use renewables like solar or wind as much as possible, but the problem with the sun and the wind is that they're not reliable, and we can't turn them on quickly when there's a spike in demand, like when everyone gets home from work and plugs in their electric car. Or in the UK, the classic example is everyone turning on the kettle to make a cup of tea at half term, or maybe turning on the TV to see the news when the Queen dies. In order to cope with these spikes, electricity grids need access to generators which can be turned on quickly. And the kind of generators that can do that are generally the ones that use the dirtiest fuel. So to reduce the reliance on dirty electricity, we could smooth out the spikes. And it turns out that there's a very easy way to detect load on the grid, because the frequency of the supply reduces slightly when the grid is under load. You can detect this with very cheap off-the-shelf electronics. So one angle is you could hook up a multimeter to a Raspberry Pi and write a Python web service which exposes the current frequency to the internet. And then you set up smart plugs which check your frequency API and only turn on your fridge or your car charger if the grid isn't under load. And then you make it available as an open public service, and you start working directly with fridge manufacturers and car charger companies. Maybe the government would start offering subsidies on products which only turn on when the grid isn't under load. If your product gets wide adoption, then the proportion of renewable energy on the grid could increase by a few %, removing millions of tons of carbon dioxide. Or if you're into DevOps, another area you can use your skills is to reduce the carbon footprint of your hosted apps. In general, there's a nice correlation between performance improvement and energy reduction, at least where hardware is fixed. You could set yourself up as a Python environmental performance consultant, reducing CPU cycles through caching or index optimization, or by switching from schematic to Peter's stereotype. Identifying green cloud alternatives, using serverless platforms like Google Cloud Run and AWS Lambda and the new Fly.io machines, which only run when people are requesting them. If you're interested in this area, I strongly recommend getting in touch with Chris Adams from the Green Web Foundation, who has loads of ideas and energy and is very well connected in the Python and Django communities. And as well as those big problems to work on, I also want to talk about opportunities, and this one in particular. I don't think evil robots are going to take over the world, but I do think that machine learning will have a profound impact on the way that we all live, and that it will come in ways that are really hard to estimate, to anticipate. For example, we thought that we would have driverless cars by now, but it turns out that that's a harder problem than people expected. On the other hand, we didn't expect that GitHub's Copilot would be writing half our code for us in 2022. And we definitely didn't anticipate tools like stable diffusion, creating images that look like photos or expert paintings from natural language input. I don't know if you're following that project at the moment, but the rate of progress is absolutely staggering. And each week, it seems like the community around it is making new breakthroughs. And if you want to use Python for social good, I strongly recommend that you familiarize yourself with the state of machine learning tools. A couple of years ago, I gave a talk about how you don't need a doctorate in computer science or maths to start applying machine learning. And I think that's even more true now. One of the interesting developments around stable diffusion is this kind of emerging skill around prompts. Learning how to give this tool effective prompts is an art in itself. I think you could think of it like a piano. There's one group of people who have the skills to create this complex, beautiful instrument, and another who had the set of skills to play it. I think you can also get involved in the ethical concerns thrown up by machine learning. The classic problem is that machine learning models are all based on historical data, which usually includes all the biases which humans have. And you don't want to create this ultra-efficient, speedy decision-making tool if it's just going to repeat all the prejudices of the humans who came before us. And then another area is around these new generational tools like Copilot and Stable Diffusion And that there are complex questions there about ownership and licensing and even the nature of art. I think machine learning can be a huge force for good, and maybe on the scale of the Industrial Revolution or the internet, but I think it needs people like you to understand and guide its usage, not just venture capitalists or Silicon Valley tech giants who are trying to sell more stuff. And finally, I want to talk about how you do your work. Apart from the obvious things like being nice to each other, I think there are real opportunities within your work as Python developers to make a positive impact on the world around you. I'm going to pick out 3 areas. The first is diversity. So looking around this room, like me, most people here are white men. It's a common problem in the tech world. Although I think Python and Django have made some progress in recent years. It probably doesn't need saying here that diverse environments are always stronger than homogeneous ones. The standard response to this problem is it's a pipeline problem. We put out a job ad and only white men applied. But you have to go deeper than that. You have to ask, why are only white men applying? What can we do to change that? Could be getting involved in programs like Django Girls, or paying a consultant to review your recruitment process. And it's not just your workplace, it's probably your open source community. Most of Wagtail's core team look a bit like me, but we're slowly improving. Our involvement in Google Summer of Code has been really exciting this year. I guess most of you would know about this project. We've run it for 2 years now, and we've had a flood of applicants this year, 90% of them this year, and in fact all 4 successful ones came from the Indian subcontinent. And similarly, the growth of the Python community in Africa has been very rapid. And I wouldn't be surprised if there are bigger conferences in Africa in 5 years' time than there are in Europe. Connecting with people in the open source community around the world has been one of the biggest joys of my career, and if you're not doing it already, I strongly recommend it. The second is mentoring. Imposter syndrome means that a lot of people feel like they're not qualified to mentor others. But I know that everyone in this room, and maybe watching online, has valuable skills that you could teach to someone else. And every time you do it, you get a little dopamine rush. Another thing that gets easier as you get older and meet more people is making connections. I think this is another magic power. Through my involvement in the Wagtail community, I've found people jobs, helped people move across the world, connected developers with projects that need their skills. And that sounds impressive, but it costs nothing. And it takes me minutes, and it gives me a happy buzz. And I'm sure, again, that all of you could connect 2 people you know. And finally, open source. I know there are lots of problems around open source, like finding enough time to do documentation, or dealing with entitled time wasters, or stopping your project from being eaten up by Amazon. But I still feel that open source is a force for good, and that ultimately it leads to better software, and more importantly, that it can create a more equitable society. And as I said before, it brings pleasure by connecting you to people around the world. If you're working in Python now and you're not involved in open source, I strongly encourage you that you make the first steps. Explain the benefits to your employer. Ask if you can spend half a day a week contributing to an open source Python project that your organization relies on. Write a good README for your personal project and push it to PyPy. Making things feels good, especially if strangers around the world find them useful. That's it from me. I suppose the message I want to leave you with is that these are scary times: Ukraine, Taiwan, pandemics, climate change, economic instability, but that with Python, you all have a magic power that you can use to chip away at these problems, and that doing that will make you happy. Thank you.
Thank you so much, Tom. Really loved how you talked about having superpowers, being able to do things that, if you can basically imagine it, you can often make it, and that's something that was just impossible for centuries and centuries. So we have a few questions. One of them is, why do you think homogeneous communities do not create strong communities when most of communities are homogeneous and are formatively?
I'm not a biologist, but I think if I were, I would have a more expert answer to this. But it's certainly true that, in my experience, when you build tools with a wider range of people as possible, then you unlock things that you wouldn't have done otherwise. So, I mean, a really obvious example is having someone who has visual impairment help build your software. And that if you don't have someone like that on your team, then you're never going to understand the needs of that important part of the population who you want to use it. That's an example. I'd be interested to hear counterpoints, but yeah, it's certainly my very strong experience that diversity leads to stronger outputs.
I love that example, and also pointing to biodiversity. Biodiverse communities are stronger, and yeah. Another one. How can we approach people who make decisions to purchase those clunky systems for hospitals? Building the software seems like the easy part.
I thought of this as I was writing that point, and you're right. And I think actually at Torchbox we've been working with the National Health Service, which used to be the largest employer in the world. I think it's now 4th or the 5th. And there's some really incredibly smart, motivated people in that organization. But it's a struggle to make things happen because they're so huge and it touches so many different lives. And I'm sure that is one of the reasons why doctors have to use crappy software. But I think you can start from the ground up. And something that I've noticed increasingly is that whereas 15 years ago at Torchbox when we were pitching to build new products for people, we would be talking to I don't know, heads of IT or heads of, I don't know, marketing or something, or communications. Increasingly, we're finding it's the developers in the organization who have influence. And that if you can convince the developers that something's right, then it bubbles up to the top. And I think that's a way to go. That's one route. Not to try to kind of sell it into the CIO who's probably going to buy, you know, something that they've heard of that everybody else is using, but to persuade developers further down the organization.
And you made a really good point with regards to, okay, you do your small part somewhere, and it fits into a bigger puzzle, right? Somebody else will do their part, and things will be moving. Since you positioned yourself in a position of the wise elder in the beginning, and we are here at in the premises of the University of Technology, and a number of you are in the at the start of your careers. Are there any takeaways or recommendations, something you would say to a young person, saying like, Tom, what are like top 3 things that you think I should do or should not do, or how should I think about my career going forward?
I wish you prepared me for that question, Jan. But I think my answer is probably a bit related to the last point I made around connecting to people, and that's something that can feel scary when you're starting out, that you feel like you don't have things to offer, that there's no point writing a blog post because probably everybody already knows the answer to that already, or that if you try and connect to someone on social media, they won't be interested because you're too junior. And my experience is that most of the time that's not the case, and that people always welcome connections, and certainly as someone who recruits and who evaluates applicants, I feel like people who are writing about their work they're doing, even if it's describing the struggles they're having and way they're unlocking problems, is something that's kind of very attractive to me. So I think that kind of uncomfortable feeling of putting yourself out there and making connections and publishing is my top tip.
Put yourself out there. Love it. Thank you so much, Tom.
I just use these.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomér. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabého.
Okay, good. Thanks.
Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládať tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Okay. Will you also look at Postgres and MySQL as well as the other options?
Well, yes, but not so much. So it's going to be mostly about other things.
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
I always wait for a cue. Black or white, chicken or pasta, Postgres or MySQL. There's often a universe of other options and a really good tool for a job. And Marc-André will now talk about choosing the right database for your project.
Oh, hello. Thank you for the introduction, and thank you very much to Tom for this very inspirational talk. It's going to be very, very hard to match that one. So this is going to be more like a technical talk. It's going to give you some advice about what you can do to choose a database and also some options that you have. So a bit about myself. I'm Marc-André Lemberg. I have been with Python for a very, very long time, since 1994. I'm one of the core developers, not doing anything much nowadays, just commenting on things. But if you know Unicode, then that was me. I'm also very busy in the Python community, so I have been on the board of the Python Software Foundation. I'm a fellow. I've been on the board and also chair of the EuroPython Society running EuroPython, and I'm based in Düsseldorf. So, to head on into the talk. So let's assume you're thinking of building the next big thing, right? Like Eiffel was at the time. And you need a database. Why do you need a database? Databases are usually boring stuff, right?
but you need a foundation for whatever project you want to run. You need a foundation that helps you scale later on when your startup is growing very fast. And so you need to make a good choice right from the start. Now, choosing a database nowadays is a bit harder than it was something like 30 years ago. And the reason is because 30 years ago, you had maybe 20 or so databases to choose from, realistically. Nowadays, you have over 800. So what do you do if you want to choose a database? Of course, you go to the database of databases. And this is actually a very good site. You can get information about lots and lots of different databases. You can do searches and queries. And I'm going to give you a few inputs of what you can do to drive this website and make a decision. So why do we have 800 databases now? Well, the reason is that in the last 30 years, lots and lots of startups have developed, and lots of startups found that the existing options that they had were not sufficient to actually make their service or their offering work. And so pretty much all the big companies that you know, Google, Facebook, LinkedIn, Uber, lots of other companies, they basically took what was available or created completely new databases specific for their needs. And they typically needed something very, very scalable, very fast, some with very fast intake, some with very fast analytics. They even went to GPUs, for example, to make their database logic work at the scale and at the performance that they needed. And so that's why we have so many different databases now. Of course, you can always use the safe kind of approach. In open source, you'd always choose MySQL or maybe MariaDB, or you choose PostgreSQL, which is probably the most advanced open source database that we have nowadays in the space. And you're pretty much, it'll work. And you'll find lots and lots of people who know these databases. But of course, if you're a startup, if you have a great new idea, then you want to be competitive. So you might lose a competitive edge if you just go with one of these systems. So what can you do to select a database in a let's say, proper way, in an objective way, in a very hands-on kind of approach? Go down a list of things that you need, go down the list of features that databases have, and then make a match and then pick one of those. So I'm going to talk about some of these things that you have to know. So one thing is that you need to know about the data load, so what kind of data you're going to have in the database. There are quite a few intended use cases that you will probably have, and you need to match those to features that the databases have. There's some additional decision factors which don't really fit into this kind of approach that I'm taking here. And you have to go out to the market and do some research. And of course then, pick one, run with it. If you have a larger project, and I will always recommend running a POC, basically a proof of concept, that the database that you're likely to choose is actually going to work out for you. So let's head on into this list. So the first thing that you have to do is you have to decide which kind of data load you're going to have. How many of you know OLTP and OLAP? Next to none, which is amazing. So these two are the basic models that you have in database technology. So OLTP basically means that you want to use the database for operational work. So data changes often. For example, you have a CRUD interface, so you want to make changes to the database very often. You have a user database, let's say, and the user wants to go in and make some changes. That would be an OLTP data load. Now, there's a second one, which is called the OLAP data load. OLAP means online analytical processing, and this is basically for taking the data that's in the database and extracting and creating reports from the database. Of course, you can say, well, ideally I would like both, but reality has it that implementing a database that actually performs well at both of these data loads is almost impossible. You can get there by using certain workarounds, you can get there by using certain tricks. For example, you can have two databases, one for OLTP, and then you extract the data and put it into an OLAP database. Those are options that you have, but you need to make this decision very early on in your process. So let's have a look at some use cases. I'm going to present you a longer list of use cases. Some of these use cases that you need to look into are known, so you know that you need these features. The more problematic one, especially when you're a startup, is things that you don't know yet. So very often you have to plan for changes. You have to plan for new designs that you want to make, let's say 5 years into your startup. So you have to plan for both. And that's very important to do right from the start. So you have to choose for a database that's flexible and can adapt to your needs. So what I did here is I basically broke down things in various complexity dimensions, and I'm going to go through all of these one by one. There may be more. This is not necessarily the complete list. And they're just suggestions on how to approach this. So first thing that you have to look into is schema complexity. How many of you know what a schema is? Okay, a few. For the others, it's basically a way of how you design your database. So how you design your tables in the database, how you assign the data types, the data structures, how you connect the different tables with each other. You can do that in various different ways. So simple schemas, for example, are schemas that are used in, let's say, a web server, a logging service, if you want to maintain messages, event storage maybe. Another case would be complex schemas. Complex schemas you typically have if you have very complex systems like accounting systems, or maybe you want to merge different backends into one new database. And then what you typically get is you get very complex setups. Now, databases can typically handle both of these very easily. Where it gets more difficult is migrations. Migrations means you want to change the schema from one schema version to the next, and managing that is hard. So that's something to watch out for. Next is the cardinal complexity. So cardinal complexity basically means that how much data are you going to put into your database? Are you going to have tables with lots of rows, lots of columns, or you have something that has both? You need to also look into growth of your data, so you need to have an estimate for how quickly the data in your database is going to grow. Another complexity is temporal complexity, so you have to look into how often does your data change in the database, or are you in the situation that you have a need to restore data to a certain point in time. Some databases can do this, others cannot. If you choose one that cannot, and later on you find you need this, it's very hard to add in retrospect. Of course, very basic is the query complexity. So you have to look into the performance of your database. How fast can the database do certain operations, like, for example, joins, when you want to get data out of multiple tables. Or you have certain performance requirements, so you don't want the users to wait a long time for their reports to show up. You can address these things. You can improve performance, for example, by doing normalization or denormalization. Normalization means that you basically try to split everything out into tables, into different tables, so you basically use the dry principle. Denormalization is the exact reverse of this. So you basically duplicate data in multiple tables, and the reason you do that is in order to avoid having to do joins at runtime. And if you are into data science and data engineering, you often have to have views on the data. View is basically something that dynamically gets created by the database. It's essentially just a more complex select statement that you have there. But modern databases have a feature called materialized views. So you can actually tell the database, okay, please take the data out of this query and then turn it into a real table and manage that for me. So that's also a feature to look into. Next is deployment complexity. So how do you want to deploy your database? Are you going to deploy it on let's say, bare metal? Are you going to put it onto VMs? Are you going to have containers? Are you going to have Kubernetes for scaling, for example? Are you going to put it into the cloud? Those are things that you have to be aware of right from the start. You also have to look at where you store the data that you actually want to manage. So there are systems that can store the data directly in memory, and obviously they're very fast. You can store data next to the compute engine, so let's say using NFS, for example, or you can put it on like a cloud storage, like S3, for example. There are many different things to look into, all very important. And of course, if your database goes down, then your startup will probably go down very quickly as well, so you have to be aware of how to make your your database set up very resilient, and also plan for disaster recovery, because things happen. So databases go down, data gets lost, sometimes you need to recover. And finally, operational complexity. So how are you going to manage the installation that you have? Are you going to do everything yourself? Are you going to run it on your own hardware? Are you going to have a cloud service, let's say Amazon or GCS or Azure, handle the management of the database for you? For a startup, I would always recommend doing the latter, because it's just you have other things to worry about. But if you grow up, if you scale up, then this might be too costly for you, so you might want to look at other options. You also want to automate the whole setup, the integration. Let's say a database goes down, then you need to quickly basically reinitialize it, reset it up. If you want to scale up, you want to add more workers, then you need automation for that as well. There are various options for this. You have to look into that. And of course, upgrades are a big issue. If you go from one database version to the next, very often databases require that you take down the database, and typically you don't want that. And there are various ways of working around that. Databases have zero-time upgrade options that you can use, so you have to look into that as well. Sometimes you can afford going down with the database, sometimes you can't. Like Amazon, for example, wouldn't be able to go down with the database in a Black Friday week, right? So that's something to be aware of. And then finally, you have additional decision factors which basically don't fit into these categories, but they're, of course, very important for you as a Python programmer, because you have to be sure that you can use Python to actually talk to the database, and the interfaces, they should be mature and should be well developed. And that's very important, because sometimes if you find that you have bugs in your interfaces, then this can hurt really badly. Something that's probably not for you to decide, but more for the investors to decide, is the cost implications of your choice, right? So if you have a very expensive service, if you, for example, use AWS to run in your database and you have lots of data in your database, then AWS will be very, very expensive. And that's something to consider. Might be worth it, may not be worth it, depends on how you look at it. And because databases get developed very quickly nowadays, it's always very important to look at the maturity of the database. Right, that was the first part. I'm good at time, so let's do some database testing. So I chose a couple of different areas of databases that you can look into. We will have a look at general purpose databases, more specific databases, databases that have various different use different technologies, use different ways of storing data. So let's head on into this one. Let's first start with the general purpose OLTP client server databases. These are the Postgres, the MySQLs, the Maria databases, the Oracles, the SQL servers, and the DB2s. How many of you know DB2? Yeah, that's what I thought. So this, choice of databases changes very quickly, and some databases are more popular at certain times than others. For example, DB2 was very popular in the 80s and 90s of the last decade. Everyone used Oracle. SQL Server got more and more popular in recent decades and is being used in, for example, the finance industry a lot. But nowadays, many people use Postgres and MySQL or MariaDB for basically as a general purpose OLTP database. And of course, you get cloud versions of everything. So if you don't want to manage the database yourself, you can just go to one of the cloud vendors and get a service there. And it's a very good way to start. Next is in-memory databases or embedded databases. How many of you know SQLite? Okay, quite a few. So SQLite does come with Python, so there's nothing to install, not even the pip install. You can just import the SQLite module and you have a database. So that's a very easy way to get into database programming. DuckDB is a very interesting new database. Whereas SQLite is more an operational database, DuckDB has emphasis on analysis and reporting. So if you have an application that needs a lot of reporting, or you want to do reporting on data that you get, then having a look at DuckDB is a very good thing. How many of you know DuckDB? No one. Ah, one. So definitely try it out. It's brand new. It's kind of young, but they're using all kinds of very clever academic research in there, and it's a great database. It's very fast, and it's definitely something to try out. It's just a pip install away, and it's just like SQLite. If you do the pip install, you get the database together with the Python interface. So there's nothing more to install. How many of you know Exasol? One? Okay. Exasol is also a very interesting option. I just put it on this page. It doesn't really fit into SQLite and DuckDB kind of setups, but it's an in-memory database, and only runs on in-memory. It does store data on disk as well, but for performance reasons, it loads the whole database into memory. And if you have a database that is too big to fit into memory, it uses a cluster for this. And of course, it's focusing on OLAP, so basically quick analysis, because that's what it was developed for. This is a commercial database, but it's extremely fast if you're looking for something like that. Next is data warehouses. How many of you know what a data warehouse is? Okay, quite a few actually. So just for the others, data warehouses are basically setups where you have multiple databases, often for different systems, and you want to put them all into a single kind of database system. I mean, those databases, and then hopefully also interact with these different databases that you have in there. The ideal form would be that you basically integrate all your data into a single database, but realistically, this rarely happens. It's just a way to have an organized way of storing your data for the company. Now, there are various options for this. One is, for example, Snowflake. That's a very popular one. Google has BigQuery. Azure has Synapse Analytics. With Amazon, you can use Redshift. Those are all very nice, very scalable, very big, sometimes very costly. You can also use a Postgres-compatible one, which is called Greenplum. How many of you have heard of Greenplum? Yeah, 2 maybe? So that's a very interesting project. They're basically taking Postgres, the Postgres core, and they forked it and added clustering and added scalability. So you can very, very easily turn it into a very, very capable database for lots and lots of data, terabytes of data. How many of you know Teradata? Sorry. Also a few. So Teradata was basically, I would guess it was the database that basically created this whole data warehouse thing. So it's not used that much anymore. It used to be run on-prem. You actually bought the appliances, so you put the appliance into your data center and you ran it. Nowadays, it's just a cloud platform. I'm not hearing a lot about Teradata anymore, but it's definitely a very, very good database. So next is data lake. How many of you know what a data lake is? We just had a talk earlier on this morning about data lakes and data warehouses. There was one slide there. Essentially, the difference between a data lake and a data warehouse is in a data lake, you just throw in everything that you have, and you don't really care about what it is, what you're going to use it for. It's essentially the Google approach to maintaining data. Google has always stored everything that you ever gave them, and they also never delete anything. So that's how Google works, because they always thought that, maybe in 10 years' time, there will be some use case for that particular piece of data, and so why not just store it? And they had the capabilities for doing that, and so they did it. Nowadays, it's also possible for you to do this. For example, a typical approach is that you store things on S3. You just throw everything on S3, and then you use Amazon Athena to query the data that you have on S3. So you don't really need to put an extra database on top. Athena will basically do this for you. And Athena works in a very similar way to Apache Presto. Apache Presto is, whereas Athena is a service, Apache Presto is actually software that you can install under the Apache license. Presto and Trino are actually basically two systems that they unfortunately forked. I don't exactly know why, but it's essentially more or less the same system, with Trino being the more popular one nowadays. It's a very interesting system because it only provides the compute for you. So it's basically a database without the storage. Very much like Athena. Athena uses S3 as storage, and Apache Presto and Trina can use S3 as backend as well. But they can also use other systems. Data Lake is another system that you can use. It's also open source, but there's also a commercial offering for that. It has some extra features like asset compliance. You can use it as storage layer and then integrate it with these other systems. Unlike many of the other systems that I've shown, these systems are column-oriented. So it's very good for storing large tables that have more or less always the same kind of data. Because if you store everything in columns, then the query engine can very much optimize the access to this data. Right, next is distributed databases. So instead of using just one system, you put everything on a cluster, and if you need more capabilities, more performance, you just scale up. You add more workers, and you get more performance. There's some very interesting ones. So for example, JugabyteDB is a very interesting one. It's Postgres compatible. It's also Cassandra compatible. I'm going to get to Cassandra in one of the next slides. Postgres, of course, is basically a standard SQL database. Cassandra is a document database, so you have best of both worlds essentially in one database. It's open source. You can install it on a cluster, on Kubernetes, for example, or on one of the cloud service providers. Cockroach is another approach. They also try to be Postgres compatible. The opinions are, go in different directions on whether and how much Postgres compatibility it has or not. Jugabyte is a little better in this respect because they actually expose the wire protocol of Postgres, so you can use just the standard Postgres database driver for that. Single store is for those of you who prefer MySQL. ClickHouse is a performance-oriented database, so it's extremely fast. It's used for log analysis. Exasol already mentioned. And if this timer is right, then I'm running out of time. So let's zip through these a bit more quickly. So you have document databases as the next one. So if you want to store, let's say, JSON in a database, then you can use one of these, Elasticsearch, OpenSearch. OpenSearch is a fork of Elasticsearch under the Apache license. Apache Cassandra is a Apache licensed system, very high performance for storing documents in the database, and provides a SQL compatible query language. MongoDB, I guess most of you will know. It's a very popular document database. And you have Apache CouchDB, which I wanted to mention because if you're developing something that needs to synchronize across different devices, then Apache CouchDB basically provides all the logic for that for you. Right, time series databases. I'm just going to skim through this. InfluxDB, many of you probably know. Apache Druid is an alternative, a very good one, a very fast one to InfluxDB. You also have CrateDB, which combines Elasticsearch documents with Presto and Trino, as I've shown on the previous slide, to give you the SQL access. And then there's a Postgres extension called TimescaleDB, which is open source. You can just add it to your Postgres, and then you have a time series database. If you want immutability, which sometimes is interesting, for example, for auditing purposes, so immutability basically means that you cannot change the database content without logging the changes. There's ImmoDB. Apache Pinot is another one, which is great for time series because it's append only, and it's very fast. How many of you do machine learning with databases? Okay, just a few. So this is very interesting because you can actually run the machine learning inside the database. So you don't have to transfer the data out of the database to the machine learning and then put it back into the database. You can just use, for example, Matlib to directly run it inside the database kernel, which is, of course, much more performant that way. If you have a database that doesn't support this, you can use a proxy for this called MindsDB, and you can put MindsDB in between your application and the database, and it will then provide this kind of functionality for you. And of course, there are lots of other different databases, like, for example, key value storages I haven't even covered in here. You can run databases on GPUs. You can have them specific for geodata, for GIS data. You have graph databases, vector databases. If you do machine learning, you can store your vectors directly in the database. Today we had a talk about TypeDB, which is a strongly typed database, and there are many other different databases for specific needs. So I've given you lots and lots of options. I hope this was helpful in some way. I'm going to upload the slides because there's so much information on the slide that might be useful for you. So you can then have a look and feel free to ask me any questions. So the main takeaway from the talk is basically you should never stop to learn and always try out new things, because so much is happening in IT and so many new developments are coming. It's always very, very good to stay on top of everything and look into these things. So with that, thank you very much for your attention. And I think I have some time for questions, maybe.
Thank you very much, Marc-André. So the first one, what databases have you used yourself in the last 10 years? What were the most unusual or interesting ones that you have encountered?
Well, of course, I used MySQL and Postgres, mostly Postgres, actually, because I like Postgres a lot, and I think the community is just fantastic. But I've also used other databases, like key-value storages. Some of them I wrote myself because I didn't have any at the time. But basically, I moved away from doing things myself and just try to use whatever is out there on the market, because other people can implement these things so much better than I can. I had some great experience with one of these databases that I wrote, the key-value storage. I had to deploy that system at a customer site on an old IBM AIX system, and it kept crashing. So I very quickly had to basically rebuild the database layer I had in the application to use a Postgres database.
Is there any engine that would support relational, graph, and time series at the same time? One that you could recommend?
The only one I know is probably Postgres with lots of extensions. So the nice thing about Postgres is that you can add new functionality to it by adding extensions. What's not so nice is that if you want to go to the cloud with this, you have to basically run and manage the Postgres installation yourself, because the typical cloud vendors, they don't allow you to install extensions to the database. So that's something to consider. But if you want to have, one of these databases that basically kind of does everything for you, then Postgres is probably a very good bet.
Since you mentioned the cloud, when would you recommend to use a cloud-based or third-party hosted database? When would you advise against it?
So I think I've already given the advice for why to use cloud services. It's always very good if you're just starting up with whatever idea you have, you want to implement it. It's much better to focus on implementing your idea rather than implementing the infrastructure that goes around it. So you can very easily start with a cloud provider that give you everything, they manage everything for you, and then later on, when the costs explode, you can then reconsider and then move to other technology, other hosters, maybe host it yourself. And what was the second part?
Just archived it. There was when would you advise against it?
Well, if things get too expensive, then, for example, with Amazon, if you start using Amazon and you put lots and lots of data in it, it's very easy to get to like a 5-figure dollar amount that you have to pay to Amazon every single month. I've been there, I've worked in the company and was CTO of that company, and I had to pay these charges, and it's just enormous. And at some point, maybe, like if you're in the tens of thousands of dollars per month, depends on your business model, it may be worthwhile still doing that. But if you are scaling above that and you start to pay like 5-digit numbers, then it becomes something that's, moving out of the cloud and into your own data centers becomes more viable and something that you should consider. There are lots of cloud companies that have done this. So. I don't remember which one it was now, but I think it was something like Uber or LinkedIn. They moved out of the AWS cloud and then into their own data centers.
What is your opinion on Citus as an alternative to GreenPalm DB?
Yeah, Citrus is another alternative to Greenplum. Citrus, but Greenplum is I don't know. I mean, it's like those are two systems that you can use for Postgres, two extensions that you can use for Postgres to move to a data warehouse kind of setup. I would recommend Greenplum because it has a better support. There's a company behind it. You can buy support from them if you like. I believe with Citrus you can do the same, but I don't have a lot of experience with Citrus.
BigQuery allows to query data stored in an object storage, S3 included. Doesn't it make BigQuery a data lake?
Yes, to a certain extent it does. Of course, if you have a data warehouse, then what you typically do is you combine the data that you put into the database with other metadata, and then you create ties between the data inside the database. With a data lake, you basically do that sometimes afterwards. So first you put in all the data, and then you think about ways of interconnecting the data with other logic.
What are the reasons to run databases on the GPU?
Well, some vendors need very, very fast analytics. For example, if you do things like if you're serving out ads and there's an auction going on, right at the time when the user clicks on a certain link, and then the page has to decide which ad to display to the user. You only have a few milliseconds to run everything. And if you want to do that at scale, then having a GPU help you with that is crucial. GPUs are also very good for data exploration. So if you're a data scientist, for example, and you have a data set that, let's say, has a few hundred gigabytes, you want to move around in that data set and do queries on the data set, maybe even interactively, then you need a GPU as well, because normal databases cannot handle that anymore.
And the last two questions, they are both about document databases. So what are the advantages of document databases compared to something like JSON type in Postgres?
Well, that is a good question. I mean, the JSON support in Postgres is actually is excellent by now. It wasn't some years ago, so people are just starting to put the data into Postgres using the JSON field. What document databases have as a better approach to storing documents is that you don't necessarily have to have some kind of idea about what kind of schema these documents have, and you can make changes to those schemas very easily without disrupting your service. I would always recommend, if you have lots of data that is like text structured, for example, I would always recommend using an OpenSearch for that, putting data in OpenSearch, because it's very much geared towards text analysis. Actually uses Lucene internally, and so that's definitely a plus. Postgres does have some features in terms of text queries, but not as advanced as OpenSearch does.
And the last one, do you think that document databases are overused or underused?
I think they were overused for a number of years when all this, the NoSQL kind of movement came out, and everyone thought that, okay, we don't need SQL anymore, we don't even need to learn SQL anymore. I think those days are over by now. I do think that document databases have a very good reason for existence, so there are definitely workloads that need document databases, and where document databases are much more, a much more usable approach. For example, if you have log data you want to put into that into a document database because queries are run much faster, it's much more geared towards that kind of data load. If you put log data into, let's say, a Postgres, then it's probably going to run slower than on, let's say, an OpenSearch.
Thank you so much, Marc-André.
Okay, thank you.
Now we have a break, and we'll be back in 6 minutes. It's a pretty good claim to say. I wrote Unicode for Python.
Yeah, and nowadays it's
Millennium, right?
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomer. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôt kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
Our next talk is going to be delivered by Wojciech Kusi and Maciej Bartosz. It will be about processing satellite imagery with Python.
Awesome. So good afternoon, and thank you for those kind words. I would like to welcome you on our presentation of satellite imagery on processing with Python. And together with me, I have Wojciech Kusi, who is a software engineer at SpaceNow, and myself, a head of engineering there. And without further ado, I would jump right in. And what we have in here is what we do, basically. And that is that we have built a platform which ingests, searches, and downloads and analyzes petabytes of satellite imagery. And what we usually do is that we analyze these imagery via in-house trained neural networks. And when we detect some of these objects, then we would like to extract an information from that. We are the series of imagery, for example, to have a economic activity of logistics centers in China, because economic activity in China is not very transparent nowadays. To brief you on the presentation, we would like to go through several topics, and that is, what is the satellite imagery? How does it look and how it works, and some typical applications. And finally, a demonstration by Wojta. So what is satellite imagery? It's imagery captured by satellites of our planet. And what is remote sensing? Well, sensing is gathering information. Remote is from distant. So in this case, remote is satellites and sensing is our planet. So remote sensing, and it's the same as satellite imagery. And how could you picture satellite imagery? It's, well, a picture or an image with a camera or your phone put up in an orbit and with some additional bands, and even possibly with some geolocation data and with some resolution possibly, which means how large is the pixel in the image, and some azimuth and geolocation. Well, not very helpful so far, right? And in a perfect world, we could have possibly see the image in the middle, which I'll just pinpoint in there. It's this one. And that means that for each pixel, we would get a spectra described in the left picture, and that's this one. That means that for each wavelength, we would get a value. However, real world kicks in, and we have to sample our data. So we'll get several images. That's this one. And these images are just samples of our wavelengths. So what does it mean is it's practically seen in this slide. And it's that we have a sample of a blue band in this part of spectra, green band in this part of spectra, and red band is this part of spectra. This is bands or sampling on Landsat 7 in the lower part and Landsat 8 in the upper part. And what is this, or what is special about this is that there's a special bands, and it's this Cirrus band and the aerosol band, which are not exactly in the visible spectra and are there just for scientific purposes to find out clouds, to find out aerosol in the coastal areas. And well, how does it work? It's basically that sun is shining and it's electromagnetic energy. And if we could follow a single particle ray to our planet, then it would absorb the imagery or absorb the energy on some spot on Earth and reflect some of that energy back to the atmosphere, where it would be reflected to a satellite, which would acquire the energy. And as you've probably noticed in this image, it travels to the atmosphere twice. And this is, in result, makes the image hazy or cloudy, and it could be compensated for. However, I think it's outside of this presentation currently because it requires some mathematical operations which are not that trivial. When the satellite sensor was exposed enough and it stores the imagery in a buffer, then it starts to collect a new image. And as you can see, it's a classical camera, and thus it has some vignetting problems. It has problems with oversaturation, and therefore there'll be some invalid pixels. It will be skewed and hard to describe. And when it is near ground station, which is in the image in here, it starts to transmit the data. Hopefully it will transmit all the data without any failure, which is not always the truth. And after that, we acquire the data and need to process it, georeference it, and of course, provide it. And well, so far I've talked about the processes, definitions, and other stuff, but can you show me some images? Well, I can. However, what would come to your mind as a typical example is usually a Google Maps. And that's not always the truth, because Google Maps is not just satellite data. They create a mosaic of satellite data and aerial photography. And if you zoom in, for example, in Europe, they'll show usually aerial photography. And if you zoom in Middle East or Asia, then you'll probably have a satellite imagery. So without further ado, here it is. It's Landsat 7, and if you see anything, just wave, please. It's located over Bratislava Castle. Fine. It was launched in 1999, so pretty old by now, and it's planned to be decommissioned. It's free to use for academic purposes, and as you've probably noticed, there are these diagonal patterns, which I've not added. They are there. And it's because there was a failure of this Landsat 7 scanline corrector in 2003, and nearly a fifth of the data has this pattern which obscures the imagery. Well, space is hard. However, NASA wasn't discouraged, and they launched another satellite. And currently, you all probably couldn't see it, but this is Bratislava Castle still. They've improved it, added some bands, and still non-commercial, free for academic purposes. And what about some other European space agency? Didn't leave the thread dry and launched their own satellites a few years after. And now we can see something, probably, because what they did is they lowered the resolution now that each pixel has 10 meters. And now we finally can see at least some buildings, some urbanization, probably, and finally the Bratislava Castle. And wow, what is this, right? It's still Bratislava Castle in here. But as I said, the part regarding the optical imagery and that the sun is shining, well, for SAR, which is synthetic aperture radar, we could omit that. And the satellite, instead of waiting for the reflection, could beam our planet Earth with its energy and wait for the response. And the response would be changes in the phase. And so far, well, you could picture it as a bat waiting for the echo signal and just having this in mind. Well, positive of this imagery is that you don't need sun, so you can monitor stuff at night, and you could penetrate clouds. And unless you have a very good eye, or you're a bat, or a snake, then you see stuff like me, which is some sort of postmodern art. And well, now we go to the territory of commercial imagery, and we get down to the resolution of 3 meters. And well, now we can see at least the buildings, and probably we could extract some footprints and stuff like that. However, it still could be better. And we get to the Planet SkySat, which is a company in US, and they provided us with a sub-meter resolution. And now we can probably count even cars in here, count trees or single trees, and extract the footprints of the buildings. And what about some specialties and characteristics of the satellite imagery? Well, it's defined by the position of sun. And sun does this nasty thing, which is that it throws shade. And well, it's hard to detect black cars in a shade. And what about the other stuff, which is location of satellite? Well, it does another nasty thing, which, if I jump 2 slides back, is that the image is slightly tilted. It could be seen in this Bratislava castle again. And for example, if we do a change analysis, so if we take 2 optical imagery and we try to find differences in there, well, it could be unhelpful to have images which are just tilted buildings. And this would ruin our change detection potentially. And without having a lot of that issues, there's also as well a cloud coverage. And that is usually everywhere. And it's basically, or I'll just tell you that this is allegedly 50% of cloud coverage, and this one is 10% of cloud coverage. Well, providers usually lie, and they provide this percentage over the whole area. And it could ruin probably your searching of the catalog, because you would just pick a scene which has this way 50% of cloud coverage, and you would get this. So not very good. And what about the state of the remote sensing API? Well, providers allows you to search by bounding box and search by some time range parameters. But it's really hard to grab a fixed menu price, because it's not very mature industry, and you have to, for example, pay for searching, pay for kilometers squared for the imagery, pay for megapixels. It's a mess. And what about the API? Well, quality of API is faltering, because usual target is a customer with a Python notebook or a researcher which does the time series data, but it's not really stable on if we just want to scale it up. And last thing, or fancy thing, that providers now allow you is a position satellite over area you want to capture. And it's a pretty amazing idea that you would just send a satellite over area you want, and it will take a picture, and you'll have it just in time you want. So what about typical applications? Well, here we have a city of Amman in Jordan, and what we usually do at our company is this: is that we try to analyze everything, basically roads, urbanization, trees, rooftops, cars, and trucks. Well, basically whatever the resolution allows us. What about other stuff? Well, we have did a analysis over Novozerno, which is near the, or which is in Crimea, And we have detected early changes in the unused motor pool or airports, and said that the amount of land equipment or amount of technique is rising, and there should be, or it's rising, which was lately approved by high resolution image, which showed that it's really true, and there's been more and more technique arriving at the site. And without further ado, again, I would like to give the floor to Vojta, who will show you a demonstration of satellite imagery in Python. So thank you.
Jo, dobře. Okay. So hello, this is the practical part of this of our talk, and I've prepared this notebook, which I encourage you to copy the URL or capture the QR code, and it's basically the introduction to satellite imagery processing with the help of the basic Python libraries. And in the beginning, we'll use the Earth engine to get the satellite imagery. Unfortunately, our platform is not publicly available for this kind of purposes. So we'll use the Earth engine, and we will not use the usual way how the Earth engine API or how Earth engine is used, because they develop some kind of their custom framework to work with the imagery data. But we'll use the REST API, which allows us to switch to the Python libraries and essentially to the way we are actually doing the processing in our company to do the essential stuff with this imagery data. So there are some hidden instructions how to set up and how to authenticate to Earth engine. That's up to you. I won't go into this. And let's start with the REST API. So there is just some public address. And in the authentication part, we get the authentication object through which we will send a request through the rest of this notebook. As Matti mentioned, when you are searching through the catalog of the imagery, you usually need some boundary. In this case, I call it the area of interest with the abbreviation of AOI. And in this case, it's some building around there. I wanted to point to this building, but actually Google was lying when I was preparing this. So it's actually, I guess, the building the next to this one. Anyway, I'm displaying the point which is defined in GeoJSON in a volume. There was a nice talk about volume yesterday. I won't go deeper in the volume. This is out of scope of this world of this talk. I'm just using it as a display widget. So let's move on to the first step when we are starting with the processing of some satellite imagery, and this is the search, of course. So as we said, you need usually some geometry
So there is some intersection with this GeoJSON. Then usually want some period of time. So in this case, we are searching for all the images from the July 1st to September the 1st. And of course, you don't want the images which are too much, where there's too much cloud cover. So we are searching for the cloud coverage which is less than 30%. And in this part, we are just sending the request with this filter. And in this part, we are just listing what we found in the catalog. And here are the results. So with this filter, we have found those images. In the first column is the ID of the image. The second column is when the image was captured. And the third column is the cloud coverage. Here we can see that at the July 21st, there was actually the net zero coverage. It's pretty rare. But let's use this image. At least we don't need to care about clouds in the further processing. So once we have this ID, we can explore further what we get, and we can ask the API for some metadata about this image. So again, let's hit the REST API with the asset ID, and let's parse the response, and let's dive in what's there. And one of the most important part is the description of the bands, what the image contains. As Matej shown you, the bands are basically the samples which are captured from the spectrum. It's basically the data from the particular sensors. And we can see that this dataset, it's actually the Copernicus dataset from the European Space Agency, has these 13 bands, and then some free computed bands. If we print the B2 band, the metadata for this B2 band, it's the blue. It's actually the blue spectrum. Then we see that there is some data type information. So you can all the data is basically integers with this potential maximum value. And in the grid, you can see some georeferencing information. The important part is the CRS code that tell you in which coordinate reference system the image will be returned. And so we are asking the API with the GPS compatible coordinate reference system, but we will get the results back in a completely different system. And the affine transform, actually, that's basically parameters for the affine transform metrics. And it basically defines how each pixel from this raster data is transformed to be a georeference. So in this case, this band has 10 meters resolution. So basically the scale X and scale Y tell you that each pixel has 10 meters. So each pixel will be basically extended to 10 meters. And the translate X and translate Y tells you how all the thing will be shifted in this coordinate reference system. So that's basically the top left corner of the image. And another important part of the metadata is the geometry. It's basically the data which you are intersecting with if you are sending some geometry, some bounding box. And in this case, we are just in the middle, but that's just an accident. If we are asking for some point around Vienna, for example, then we get the same square. And the geometry is defined as a GeoJSON with these coordinates. And you can probably see already from this preview that it's pretty large image. if we can calculate the size from the dimensions. So it is present in the metadata. So the size of the image is 120 megapixels, and it covers the area of 110 kilometers times 110 kilometers. Of course, we usually don't work with such big areas, or if we do, we usually split them to small tiles. So, but before we will clip this image, we ask the API again to just get the finally the RGB preview of the image. So we ask the API for the B2 band, B3 band, and B4 band, which are the blue, green, and red spectrum. And the Earth Engine API is clever enough to compose a PNG from it, so we don't need to do it ourselves in this case. You can see that we are sending the whole geometry as the region we want to select from the image. So we are saying that we want the whole image, and we are also saying that we want to downscale it to just to picture of 400 pixels to 400 pixels. So that's the result. Voila. So there's the Bratislava in the middle. There is Vienna on the left side. And on the top left corner, there's some boundary. It's actually a border between the Czech Republic and Austria. And so, how to select the region from the image? Actually, first I try to calculate it precisely by using some conversion between the coordinate systems, but it will be too much for this talk. So we can simply use a tool such as GeoJSON-DB, where you can draw basically anything you want, and it will translate to GeoJSON. So let's say we just selected the region manually. If you want, of course, you can try to dive into how to calculate some precise region. And again, we just preview the region in the widget to see whether it is correct. It seems so. So let's get the RGB preview. So it's basically the same request as before. We just changed the region to this smaller one. So voila, we are close. And now finally we are going to load the GeoTIFF, which is georeferenced TIFF with all the bands, and we can try to do some stuff with it. For working with the raster data, we usually use the library called Rasterio, which uses the GDAL C library under the hood, and some other libraries. And so we are going to ask the API again. It's almost the same query as before, but instead of PNG, we are asking for GeoTIFF. And we are adding one more layer here. It's the B8, and it is actually a near-infrared spectrum. And once we get the result, we just get the content from the response, and we wrap it in the bytes and in a memory file. When we are saving, if you save the GeoTIFF, it will be a bit more easier. There is just method raster open. So if you have some stored GeoTIFF, it's much easier. So if we have this in-memory data, it needs a bit more massaging, but the result is same. You have loaded GeoTIFF in a memory. So as we did before, let's dive into some metadata first. So we look what the size of the image is, what is the number of bands. So we see the size is what we asked for. And it has the number of bands. Number of bands is 4, as we asked for, And the order of the bands is important in this geotiff because we need to access them through those indexes. So we need to know which that, for example, the B2 is the first one. And you can see that in the geotiff contains also the georeferencing information, such as the coordinate reference system and the affine transformation, which is now a bit shifted because the region we are displaying is different from the big image. So this translate X and translate Y coordinates are a bit different. But the scale X and scale Y is still the 10, it's still 10. So now we can look how the band, particular band looks. So first we load those pixels with those indexes 1, 2, 3, 4, and we just print some what's inside. And as you can see, the band, every particular band data is just 2D metrics with integers, and it's basically just the strength of the signal at this particular pixel. And we can display it. It's 2D data, so we can just put it to matplotlib and plot it. So I have added some color schema to each band to differentiate between them, but actually it will, in reality, it's just grayscale data. It's just values, and you can see that the red, green, and blue bands are somewhat similar. That the saturation over the image are same, even though I've added this color to them. But the near infrared image is quite different. That's, for example, in the red, the red band on the left, there are some vegetation parts which are pretty dark, but on the near infrared, it's the opposite. And we use, if you have those spectral differences, you can use it for various calculations. And we'll use it to land use detection using two indexes. One is called NDVI, which means normalized difference vegetation index. And the second one is called normalized difference water index, which is NDWI. And they are known for a long time, I think from the 70s or 80s. And they have pretty simple formula. You are basically just subtracting and dividing the layers, the bands. And so let's do this. So as you remember, we loaded all the bands into the pixels dictionary. So we just transfer those formulas to this real computation, which looks almost the same as the symbolic formula with the help of NumPy, which does all the hard work under the hood. And we can display the results with the good choice of some colorization. You can color maps. You can see that we have some results. That on the left we can see some vegetation, which is represented by the dark green areas, and on the right we can see some like water areas, which are represented by the blue, dark blue colors. Of course, it's just with the choice of the color map. So, and with the threshold. So, of course, now you can see that there are some blue areas which are definitely not water areas. But we will solve that with some threshold, just 1 or 2 cell later. So for NDVI, it's usually used threshold 0.3, which is considered to be vegetation, and for NDWI 0, which is considered to be a water. So when we apply those two thresholds, we can get a binary mask. So and categorize the image. Where is the forest? Where is the water? And where is something other? Maybe some urban area. So we prepare some shapes, and we store one for each pixel which has the NDVI value greater than 0.4. It's a bit more than the recommended value, but it gave better results for this example. And we do the same for the water mask. And when we plot the mask, hooray, we have detected where is the forest and where is the water. Of course, there are some small glitches which we might need to clean up, or maybe we not if the analysis doesn't need to be precise enough. And since we know that every pixel has a resolution of 10 times 10 meters, we can actually calculate the areas for each category of the land use. So let's load those data into pandas. So we can calculate the total pixels, and then we can just sum, because we said that when there is a forest on the pixel, we put 1. We can just simply sum the masks, and we get the number of the pixels. Where is the forest and where is the water? So with these two simple operations, we get the table, the data frame, and we can chart it. So we can see that at this area we have like 22% or almost 23% forest, 10% water, and 67% of other area, probably the urban area. So that's it. That's it for this part. And we can do also. I have a bit more time, so maybe I didn't plan for it, but I can show the next part. What you can do with it. Maybe you want to transfer those masks to vectors, and with the help of Rasterio, you can also do that. So you can create a shape generator, and you fill the mask in. You also put the geotiff transform affine matrix there, so the results will be georeferenced, and then you can just simply iterate over the shape generator, and it will return all the shapes it finds in the mask. And now you have the same result as before, but now vectorized in a shapefile format. And now, since we can do some cleanup of those small glitches, so we can do some classic buffer operations like adding, subtracting, adding buffers, which is typical trick to clean up some geometries, and then also simplify. So and because this the geometry of the image is in meters, that what we do is actually means that we are subtracting margin of 5 meters from all the geometries, and then adding the margin of 5 meters back. And this basically do that all the smaller, for example, all the smaller polygons which are there are deleted, because when we subtract the margin from them, they got like the 0 area, and they vanished from the geometry. And then we simplify all the coordinates with the tolerance of half meter. So if there is possibility that there's some optimization or algorithm which can reduce the number of coordinates and simplify the geometry. So here we have the river with some small glitches around, but we leave it there. And now we want to display it in a volume as well. But unfortunately, we cannot do it right just like that, because this is different coordinate system. So we need to convert it from the coordinate system of the image to the coordinate system of the volume, which is the GPS compatible coordinate system APSG 3326. And for that we use the PyProach library, which is wrapped around the PROJC library, which do all this hard work. And again, we just define the transformation, and then we use shapeplay to transform the geometry, and then finally we transfer this geometry, which is in shapefile format, to GeoJSON, and as a GeoJSON we can display it finally in a volume. So voila, we have this river in a vector format now, displayed in the volume widget. So this is something which you are doing very often when working in imagery, that you need to pay attention for the coordinate system still, and you often doing several round trips between these coordinate system when you are working on your tasks. And you are taking advantage of each particular coordinate system, because, for example, the GPS compatible coordinate system is in degrees, while the coordinate system which is used in this image is defined in meters. And so basically that's it. I aimed with this notebook, or with this practical part, to give you an idea that you have basically satellite imagery at your fingertips. You just need to subscribe to Earth Engine, which is free for non-commercial purposes. You just need to create a Google Cloud Platform project, create service account, through which you are connecting from this node, for example, from this notebook, and that's it. And you have basically the almost same access as we do as a company to these data. And we built a lot of products on these data. In this notebook there are also some ideas for further exploration, if you find it interesting. And of course we are hiring. So if you find this topic interesting, if you want to do something like this full time, please look at our careers page. There are plenty of jobs, not only programming but also some research or data analyst and such kind of stuff. So thank you for your attention, and that's it. Thank you.
The first question is, do you have any funny stories or any F3 stars ups? Any F ups?
I guess that's the question for Matěj, because he's much longer in the company, especially from the early days.
Well, I have a list of stories, but I don't think they're permitted to be told. However, I can tell you one, which is that we had a delivery for a customer, and we wanted to download imagery from a provider, and we started to download the data, and after a while, we've completely wrecked the provider, and they had to call the emergency, and the guy had to just travel there and turn on all these servers that we just shut down completely. So it was small DDoS attack by trying to do a delivery.
Thank you for that. And also, there's going to be a meeting, there's going to be a dinner tonight for stories that are under either NDA or just not not good to be shared publicly. That is the right venue for sharing those. And check your emails for details about that. Okay, another one. When someone, for example, a new developer joins your team, how long is he or she catching up when they have no prior experience in that area?
Okay, so maybe that's for me because I joined just a year ago, and I think like there are various things you can do at the platform. So for some parts you don't even know the knowledge about this satellite imagery, but I'm still, after a year I still learning, and I'm maybe even forgetting some stuff I learned at the beginning because the platform is huge. And but I think I start to be productive like within a month or two. So like I think it was not so big challenge.
Thank you. And the final one, do you have any data from ultraviolet or higher frequency EM spectra?
Well, unfortunately, I don't think we have. I think the closest one was the coastal aerosol that I've shown on the Landsat 7, which is slightly lower than spectra of blue. So I think that is the closest. Well, if the satellites had the sensor, then I'll go for it. It's an interesting topic.
Yeah, but maybe if you look through the imagery what is available at the F engine, I believe there are plenty of research datasets. Sorry, I think it's not loading. But if you go to the F engine catalog of already datasets, I think there are plenty of those datasets like this kind of aerosols, and I think ultraviolet light was there as well.
Thank you to Vojta and Maciej.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomer. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
But I work for a fintech, different kind of story.
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
Okay, if you would please take your seats. We are ready to continue. And Martin is going to tell us the things he has learned about building large-scale fast APIs.
Okay, good afternoon, everybody. It's been a while that I've been in a university. I'm 39 years old, so that's been a while. My name is Maarten. I come from Belgium, and I work for a Belgium-based fintech. As a Python developer, I work on several internal microservices. In a short nutshell, I'm not here to promote the company, but let me quickly explain and give a little bit of context so that you understand a little bit more what I'm going to talk about. So it's a fintech company based in Belgium. Our flagship product is that we automatically invest savings of people in stocks and things like that. It's not a quick rich scheme, it's decent investment. It's developed jointly with the University of Leuven. If you want to get rich quickly, buy crypto or try. So what I'm going to talk about is about Fast API. In case you haven't heard about Fast API, it's a relatively new Python framework, but it gained a lot of momentum in the recent years as one of the new Python frameworks. We started with it like 2 years ago. I didn't know it 2 years ago, so for me it was new. I'm the type of developer that doesn't read documentation, so I just jump into it, so you also run into trouble. It's mainly built on top of Starlet and also Pydantic. Pydantic is like Python data classes, but in my opinion a bit better. It adds a lot of more extra features to validate data. As you can see, I read last week that it overtook the number of GitHub stars of the Spring framework in Java, for example, so that says something about the framework. It's created by Sebastian Ramirez. I've never met him in person, but on social media he's very approachable. I often email or ask him things if I'm stuck, and he pretty helps me fast. And the documentation is excellent. If you don't know the framework, if you even don't know Python, go to the getting started and you will be up and running in 5 minutes or maybe 10 minutes if you're using Conda. So what I assume is that you know a little bit of the basics of Fast API, web development in general, Pydantic and Python, of course. So in the next 25 minutes by now, I'm going to run you through 5 learnings we had, mistakes we made, what we learned out of that. It's not necessarily about Fast API, it's also about programming problems. That's what we do, we make mistakes. So the first thing that I wanted to talk about is in your web application or in your Fast API application, you have to try to minimize the global state. And Fast API has a mechanism for that to avoid that. So short recap, what is global state? App, as Fast Fast API application in the global state. That's it. What you then do is you want to connect to a database, in this case MongoDB. You create your connection there, or your client, and then in your endpoint, as you see at the bottom, you connect to your database. That's fine. That will work. That's easy. But in general, not only in Python, global state is a bad practice. You easily end up there because Fast API itself is defined in the global state. Why is the bad practice? It's pretty hard to patch in unit tests, for example. Or if you want to have access to the global state, you have to import it from another file. You easily end up in circular dependencies or inline import statements. And the moment you start doing that, you should know that you're doing things wrong, like I did. So I had to read a little bit of documentation and change some code. So what is the most easy solution for avoiding a little bit of global state is make that connection in your endpoint. This is also okay, but the downside of this is that when you're connecting to a database, these clients usually have connection pools. So if you do this, what you see here, you don't really use the connection pools because you're always setting up the database connection when there is an incoming request. So this is not super efficient either. So the thing is, Fast API has a mechanism called dependency injection. If you know a little bit of Spring in Java, you are familiar with the dependency injection mechanism. In Python, it's not really common, but Fast API adopted a lightweight version of dependency injection. What it does, it injects a function in another function coming from somewhere. In this case, Fast API itself. If you see at the bottom, the last function, you see that there is called depends, and then you add the function as a parameter. What will result when there is an incoming request, Fast API will inject that function in there, and you can have access to that connection pool of MongoDB. How is that different from the previous example? It is that Fast API will cache the get connection function, so it gets reused across your application and other endpoints. Small remark here, if you're familiar with MyPy, MyPy will complain about that line because MyPy doesn't like you to add as a default function that gets code that gets executed. So you have to exclude that rule in MyPy, otherwise you will cry. So this is what we started to do to structure your application. This is also advised on the documentation of Fast API. We added all our dependencies like connections to MongoDB, Redis, Kafka in a dependencies file, nothing more than that, and also the configuration of that. We have split up our entire code base in different routers per concern, and we stitch everything. So the routers, they import from the dependencies. The dependencies file itself doesn't have a dependency on any other parts of the Fast API application. So it keeps your application or your logic decoupled from each other, and everything gets stitched together in the app.py file. That's about dependency injection. If you go to the documentation of Fast API, in my opinion, it's a bit undervalued, that part, but it's a very powerful part, because if you avoid global state, you will be happy. So how can you, we also struggled with our test suite, and basically the learning of making your test suite maintainable or easy to set up is just avoid global state. You will be happy. What you usually do when you want to test an API, you start overwriting configs, environment variables. If you're using, probably you're using Docker, everything gets configured with environment variables. You start mocking or patching data. Sometimes you have functions with a lot of mocks and patches, which is bad because then what are you actually testing? And then you're also setting up a test client to actually do HTTP calls to your application. We're using PyTest. There are probably a number of other good frameworks. I'm not very opinionated about that. So what did we do and what is powerful about, in this case, not really Fast API, but Fast API builds on top of Pydantic. There is a thing called base settings, which is a class that you can define, and it automatically, when you instantiate it, it automatically maps all the environment variables to this class. So if you see Pycon config, when you instantiate it, it will automatically map an environment variable log level to this property. The same goes for MongoDB, for the MongoDB connection, things like that. What is nice about it, since all your configurations are mapped on this object, you can easily instantiate that object and use that in your testing. You don't need to go dive into the internals of your functions and patch environment variables, which is not always easy, because if you have to patch environment variables or global state, you have to do it before your code base is loaded, otherwise it will fail, since environment variables won't be available. And Fast API provides a basic mechanism specifically intended for that, is you can override dependencies. So if you inject your config of your application everywhere in your endpoints, you can easily override that config. So you have a class, you instantiate it, you assign it to Fast API, and that overridden config will become available in every endpoint during your test run. The same goes for any other dependency. So this will also force you to, or this will easily force you to just stick with pure Python functions or pure Python classes. This is nothing new, but a pure Python function, when it doesn't have any side effect, you don't need to patch anything. You can just pass in the parameters, test it, test the output, and you can validate that your function is working properly. And I think this is clean code. So what we started to do is Fast API is only the top layer of our application, and all the downstream business logic doesn't have anything to do with Fast API. It's just pure Python. That's it. Now, the third part that I want to talk about is the pitfalls of asynchronous Python. It's my favorite part. It's also the part I struggled the most with. And that I learned the hard way. It's not necessarily an issue of Fast API. It's more of the way Python is and works. But Fast API is written in Python, and it also advocates asynchronous Python, but it's not as easy. So asynchronous Python is not as easy as it looks like. I don't know if anybody, yeah, probably. But if you already worked with asynchronous Python, I don't know if you really have struggled with it. Another thing with, well, it's not necessarily related to asynchronous Python, but it gets in the way anyway. It's the global interpreter lock. I used, before a few years, I never worked with machine learning or data science. And then you're not really blocked, or you don't really stumble upon the GIL. I knew it existed, but I didn't know what it actually was. I was working with Django applications that go to a database, fetch data, store data. You usually don't run into troubles with that. But if you have CPU-intensive code, which machine learning and pandas are behind the scenes, it blocks your CPU. What it basically does is, if there is a piece of code that is CPU-intensive, the Python interpreter will block, and all the other threads are blocked. Whether it's asynchronous or multi-threaded, it hangs until that one request, until that one piece of code finished. It gets in the way anyway if you're doing asynchronous Python, because the way asynchronous Python works, it's an event loop. It's a single thread in a single process. So combined with what I just told about the global interpreter lock, if it blocks, you can fire 1,000 asynchronous requests, they will all block. And I'll try to demonstrate. So the last thing I want to explain there as well is, besides the global interpreter lock, a lot of Python libraries are still synchronous. So they don't implement the async await construct, which is also troublesome if you want to build asynchronous applications. So here's a small piece of code which will make your application hang. If you invoke the last function, time2, there is a sleep statement, which is a synchronous statement. That endpoint will block for 10 seconds. If you at the same time invoke hello, it will also block for 10 seconds, because the thread will be blocked because time.sleep is a synchronous statement. So as you can see, this will I mean, you can write, and nobody will complain about it. There's no linters that's going to complain about it, as far as I know. MyPy doesn't complain, Flake, Black, nothing complains about it. So if you put this in production, it's not always easy to track this down. The second, or the time one function, if you invoke that first, that will also sleep for 10 seconds. If you at the same time invoke hello again, that will respond immediately. The reason why this works that way is that the way FastAPI deals with it is if a function is defined as an asynchronous function, it will pass on the execution to the event loop. If it's not defined with asynchronous, it will pass it on to a thread pool. And that is the way Django and FastAPI, Flask have been working for years. That model, that execution model works. What can you do with the sleep statement is there is an alternative on the right side. You can use asyncio.sleep, and then if you invoke time 2 first, and then at the same time hello, they both will, no, time 2 will wait for 10 seconds, and hello will respond immediately. But not all libraries have a counterpart for, let's say, time, which is a very simple example. But not all libraries have a counterpart. If you're connecting to a database, it means that you have to entirely rewrite your database layer to an asynchronous library in order to get this working. There are ways in FastAPI to make asynchronous code work with synchronous code, but I don't really like doing that because then you could easily argue to just write synchronous code. Okay. As I explained a little bit before, the global interpreter lock, imagine some machine learning code here or pandas, NumPy. It will block the CPU. So as long as count doesn't finish, hello won't respond, although it's asynchronous. That's just because how the GIL in Python works. It has been debated heavily for years, but Guido always says no. So this is how I feel about asynchronous Python. It looks shiny to start to work with, but I think Node.js is doing a better job, although I like Python more than JavaScript. So lessons learned here, a lot of Python libraries are not compatible with asynchronous, and you just easily end up because you never know how your downstream code base looks like because you call a function, another function, and another function. Which line of code is actually blocking? You don't know. So what we actually did is we removed all async prefixes of our code base, which makes our application basically multi-threaded. And then what you do is, apart from FastAPI as well, we started to move all CPU-bound execution to other parts of the code base or to other systems. So you can use a process pool executor, which means that it spawns a separate process, it offloads, it doesn't block the main FastAPI process, it's run somewhere else in another process. The downside is that it has some ramp-up time to spawn that process, which is in an API world not always desirable. We deploy a lot of our microservices on Lambda. Lambda is by default actually multi-process because it scales out automatically. You don't have to do anything for that. And like a lot of heavy computations are offloaded to other systems by putting things on a queue. So second lesson learned for me here as well, read this part of FastAPI. If you don't understand it from the first run, read it again, because I think it's really important that you understand the way Python deals with asynchronous execution model. A fourth thing I wanted to talk about is how we can support multiple authentication schemes. We had a use case where we wanted to support JWT tokens and API keys. Basically, a customer asked for that. They paid a lot, so we had to do it. And then we run actually into troubles with FastAPI a little bit. FastAPI has a lot of utilities to deal with that. And all of these utilities, they integrate very nicely with the documentation. So if you haven't worked with FastAPI, one of the strong things of FastAPI is that it automatically generates an OpenAPI spec. So you don't have to maintain a Swagger file or an OpenAPI file to define your API. It automatically generates it based on your code base. So it's also nice then with the utilities for authentication, because the Swagger becomes interactive, you add your API keys and you can start testing your API. To define this, there's a lot of documentations, and there are a lot of examples to implement API keys or basic auth and OAuth 2. But it doesn't really come with batteries included. So a lot of the implementations of these things you have to do yourself, especially OAuth, you have to implement it yourself. And FastAPI is built on top of Starlet. Starlet is an asynchronous framework. FastAPI is a layer that makes it more convenient to work with. So Starlet also has authentication mechanisms, but FastAPI is different. The way FastAPI approaches it is different than from Starlet. If you're coming from Django, you will be familiar with middlewares. So Starlet solves it with a middleware. So you define a middleware, you define your Starlet application, and you say, okay, these are the middlewares which makes basically all of the endpoints authenticated. And then you define your endpoint where you fetch a user, and it becomes authenticated. The way your middleware works is a request comes in, the middleware does something, passes on the request to a function, it returns, and then it goes back to the middleware. The way FastAPI solves it, it's like FastAPI solves a lot of things with dependency injection. This is the part that I struggled a bit with, because in the last function you see, okay, we want a user, so we inject that user, and then on, above that function you see we inject the auth scheme, and then the auth scheme tries to fetch the fake decode token tries to fetch a user from the database. The big downside I see here, or that I experience here, is that you have to do that on every endpoint that you write, so it's a lot of duplication of code. That's the first thing I dislike a bit. And the second thing I struggled with is if you want to support two authentication schemes, you have to basically write it like this. You try to fetch a JWT token or an API key. But the problem is that if there is no JWT token present, the first statement will already fail. So it basically becomes an AND operation. So they both have to be present. You can solve this in an easy way by making both of them make them both fail silently, like setting auto error to false. But then you're actually switching off your authentication. Whether it's authenticated or not, it just passes on. So you have to write it a little bit yourself. You have to write a function like getUser. If there are credentials, then we do something. If there is an API key, we do something else. Otherwise, we raise an exception. So I personally like a middleware approach more because it decouples the authentication from your endpoints. The user becomes available on the request. You just assume that it's there. If a request arrives in your endpoint, you can assume that the user is there or that it's at least authenticated. And it gives also flexibility to put the authentication at router level, because in FastAPI, if you put the authentication at router level, the user is not available in the endpoint itself. I still have 2 minutes left. The last part I wanted to discuss is a big mistake that we really made. Since we were a startup, or now growing towards a scale-up, we wanted to be fast and we didn't want to duplicate code. So what we did is we defined our database models. They were exactly the same as our API models. We didn't want to define a database model and API models and map API requests onto a database model. The way we did it, back in the days we thought, it's pretty clever, is we implemented it as an inheritance. I'm going to skip this to buy some time. So we implemented it as inheritance, and let me go first to this slide. So the first thing we did is we defined a patch model. Then we inherited from that the patch model, and we called it the portfolio response. And then we inherited from that, and we called it portfolio. The portfolio is actually the model that goes to the database. But as you already can see, it's not very readable, because can you say which fields are on the portfolio? In this example, it's pretty easy, but it's obviously a much larger object. And then the response is something you don't want the database ID to be patchable in an API request. The way we did it this way is that Fast API generates documentation based on Pydantic models. So if I go back to this example, on the right side, you see that the documentation automatically generates an example, which is beautiful because you don't have to care about it because it's defined in code. But what were the issues we had with this is that, DB models become hard to read. If you want to change the API contract, we couldn't unless we did a database migration. And the other way around, if we want to change a model, a field in the database, which then automatically reflects into a breaking change in the API contract. And our APIs are exposed to our customers or to our clients, and you cannot easily break your contract. So the next steps that we are currently doing is, okay, we are going to decouple that. That's a very big lesson learned here. And there is a new thing in Python in one of the recent versions. It's included in the typing library. It's called annotated. What it allows you to do is to annotate a certain type. As you can see in the portfolio fields, I annotate a string type, and I add metadata to it. There I can add there we can add Pydantic metadata, and we can reuse those fields into our portfolio patch and into our portfolio response to allow Fast API to generate still beautiful documentation without repeating ourselves too much. I'm done.
Thank you, Martin. Okay, here are the questions. Is it really that connection? Is the connection really going to be cached in dependency injection? Dependency caches live through that request or the whole app?
You can define that, you can scope that. By default, it's cached throughout the entire app, but when you define a dependency on a function, you can say not to use the cache. So by default, it's cached throughout the app.
Do you think it makes sense to switch from Flask to Fast API for the sake of asynchronous quote-unquote support?
If I have to write an application that works on top of a lot of relational data and doesn't have to do anything with machine learning or data science, I would choose Django. In other cases, I would choose Fast API.
And the last one, you mentioned you used Django before. When does it make sense, if ever, to rewrite a Django REST framework app to Fast API, and when does it not make sense?
I would never rewrite an entire application because there's simply no time for it. And there's a lot of hidden requirements in a code base that lives on for years. So a rewrite is, I think, definitely going to fail.
Thank you so much, Martin. Now we have a break, and we will continue in 14 minutes at 4:05.
Teď to nebudem odporúčať chlopák.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomer. Mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED páse. Ja som na ňom naprogramovala dúzu. Teraz programujeme podľa nôt kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mi mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
Raz, raz, raz.
teraz.
Odovzdáš jej slovo, tak iba podržaním vypneš a až potom na otázky sú zase podržaním zapni. Dobre, ďakujem, ale ja si budem sedieť. OK, tak počkaj na kameramana, on ti dá signál, kedy môžeš. OK. We'll start in about a second. One more minute. All right. Welcome everyone in the, I believe, final talk of today, at least in this room. And I thank you all for coming, because it seems that the program we have is very, very interesting. Most of all, we have Chuck here, who has been a data scientist at the various companies, as I read, who organizes a ton of events all around, from EuroPython down to PyData, Global, and stuff like that, right? And is even a Python fellow, Python Software Foundation fellow, as I read of 2021. But on top of all that, she's in developer relations at Anaconda now, and she'll talk to us about how to use what we can do with PyScript and how that can do a revolution with regards to our visualizations. So please join me in welcoming Chuck.
Hello. Thank you for coming to this talk. I'm Chuck, and this is my first time in this country. It's beautiful, beautiful city and beautiful country. Thank you so much for having me. So let's talk about PyScript. So first of all, before I jump into the talk, so this is my social things. You can find me on Twitter, whatever, and I love people take picture of me and tag me on Twitter, so please do if you can. And also the slides is available online, so you can even get it now live, see it together with me. So so that's it, and let's get started. And before I tell you more, so how many of you already heard about PyScript before coming to this talk? Yeah, most of you, which is good. Some of you doesn't put up your hand, so you're at the right place. I'm going to tell you about PyScript. So I'm Chuck. I now work for Anaconda. I was involved in different open source projects in the past. I love open source projects. And I organize events because I love the community. Python community is great, so that's why I love going around the world, seeing all of you beautiful people, and organize some of them as well, so people can gather. Also, I did a little bit of streaming during the pandemic because I'm not allowed to travel, so which makes me sad, so that's why I moved online for this. But now I can travel again, so yay. So what is PyScript? PyScript, first of all, so people will be like, oh, is it JavaScript, a new thing, well, it's a framework. So what does it mean? I can show you later how we use it, but basically, to put it simply, we can now run Python applications in the browser. So you may think that, well, we already run Python application in the browser, right? We already have some kind of things that we could do that, we can use Python, for example, some of you heard about Django. We can already use Python to build web things. Why do we need that? So basically, what makes it different is that in the past, Python, you need to have a back end to be able to run the application, because Python is not a language that will run purely on the browser, which is, to put it more technically, is not a front-end language. So usually the front-end language that it will be JavaScript. So PyScript is kind of like, you can make Python run in the front end. So that's why the name Python script, PyScript. So that's how that came from. But it's not going to replace JavaScript. It's just not the idea that I'm trying to tell you here, that like stop using JavaScript and use PyScript. But rather, like if you are already using JavaScript, it may actually empower you to make your journey to learn PyScript much easier. Sometimes, we work, to build an application. Sometimes we'll use both Python and JavaScript. And now you may think of some of the application can be moved to the front end to like use PyScript instead of like running. But still, if you want to use JavaScript, you can still use together with it. So it's not something that we're trying to stop you doing. So someone is very happy. So how does it work? Like it sounds very crazy, right? Like I think all thanks to first of all, like a WebAssembly is now a thing that make like all the front-end languages more powerful than before. And also we have a very wonderful project that's called PyDI that basically allow all these Python and Python libraries that can be interpreted or interpret into WebAssembly. So for those of you, like I know some of you know, but like for those of you who don't know, like Python is a language that if you, for example, download the standard Python, the C Python, it's actually interpret Python in C language, so it can run on your computer. But now because we want to run it on the browser, we need to run it in a language that the browser understands, which is WebAssembly. So PyDI basically acts as this almost like a C Python thing that interprets Python to WebAssembly. So now you can run Python on your web browser. So that's really good. And also PyDI, the team put a lot of effort in making a lot of these Python library available. So a lot of us love Python because there's so many libraries that we love. We use it every day to make our work much easier. You may worry that, can I still use it? Because like if I can't use it, I won't use PyScript, right? No, like a lot of them are still available because PyDI like make them available to be able to use. For those of you who are data scientists, like I was, we use a lot of things like pandas, NumPy, all these tools that we manage data with. Now they're available in PyScript, and you can do this data kind of manipulation, not at the back end, but at the front end. So yeah, well, it's a very new concept, right? How to use it, right? Like, okay, I want to try. So how? I'm going to show you an example. So this is the basic, I would say, 101 of PyScript. So how to install PyScript, right? How to install it? Well, you don't install it. You just, for those of you who know JavaScript, this is looking a little bit familiar. You just import a script. And actually, this is like, you can see the extension is .js. So actually, this is a script that's written, I do believe, I may be wrong, but I think it's a TypeScript script. So you put that in your HTML. So this is an HTML file. So you put that script tag, and then so you kind of basically call in this script. That's the PyScript script, right? So you call that in, and it allows you to write PyScript. So how to write PyScript? So this is the Python part. This is looking very, very familiar for lots of you. This is basically Python. It's not JavaScript. As you can see, there's no like curly brackets or whatsoever. So this is how it looks like when it runs. All of these are computed by Python. Well, it's computed by this Python script that is in the HTML file. So, I can't show you the thing without the highlight. Sorry about that. But basically, you would have a PyScript tag. I will show you later in the other examples because I forgot to like show you the whole thing. So, how does it relevant? I'm now like assuming that you're here because you need to do data visualization. Either you're a data scientist or someone who will build an application that have certain type of like you have to manage the data, do something with the data, and then present it. How can these be relevant to you? What makes the difference? What can change your basic, what you did in the past? So if you visualize data, then with PyScript, you now have more options to do more stuff. For example, you can run some like dynamic visualization. I know that as I'm speaking as someone who was a data scientist who was doing this in the past. That usually what I do when I have to present some findings to the other parts of the business, I will have to run my lovely like Python program to handle the data and like get some findings and stuff, and then I would do the visualization. Either I would do it in a Jupyter notebook, and then I would export it as HTML file, because like the visualization tool that I use, for example, Matplotlib, you can generate an image, and then you can put that in your report, or something like Bokeh, you can export that into an HTML file and things like that. But now, instead of every time you have to export the thing again, you can just have it automatically updated because it is embedded in your presentation or web. For those of you who have seen my lightning talk yesterday, I have embedded the visualization in my slide deck, so it will be automatically updated if I update the data source. So you skip a step. Also, I'm saying like, for example, Matplotlib, you generate the image, it's nice, it's fine, but it's not interactive, right? Like now you can make use of the interactiveness of the browser and make it just live update the presentation according to maybe the user input. So this is something that I was struggling to find a good tool for in Python ecosystem. There are multiple tools, but none of them really fulfill every use case as flexible enough for me to fully customize it. Now you can, as long as you don't mind writing some code for the front end, then you can make whatever you want. Also, you can share it without installation. Like, for example, in the past, if I want to share my Jupyter Notebook with people, if they don't have Jupyter Notebook, then or they don't even have Python, then, well, it doesn't work on their computer. You have to find a way to host it or maybe bind it or something. Then it's not ideal, but now, because everything is in the front end, so basically all they need is a browser that already run. Well, of course, if you want it to work offline, you need to have the script together with it as well, but assuming that they have internet connection, now people normally will have a browser and have internet connection. So even though that person is not someone who code in Python, doesn't have Python installed, it will still work on their computer. You can still show them the visualization. And also, it can be very easily embedded on a web page. Like I said before, you can do all this stuff by setting up a full stack application with the backend, doing all this data manipulation in the front end, which is like JavaScript and stuff, doing this. Now it's like let people who are not web developers just like put stuff, boom, in the HTML file, and it works. Well, it may not be that easy. You still have to learn a little bit of tricks and stuff, but it's make it easier for people who may not want to learn web development and to build an application properly, because they may just want a one-page presentation. So this is something that could change the game. So I'm going to show you examples of these things, right? So the plan is I have 3 examples. So each one of them will show you a different use case or different way you can use PyScript. By the way, PyScript is still in alpha, so I'm building more and more examples and stuff. But sometimes I stumble across some issues, either like any part of the whole thing, right? Like we use also PyScript, PyAuda, all this stuff. I'm trying to like now building one more example, but because it's still very new. And then if you try it out, I really encourage you to try it out yourself. If you try it out, if you have any new ideas or stumble upon any questions, feel free to reach out to me or reach out to the team, and we are very, very happy to hear your opinion. So, okay, let's look at the first one. First one is like this. So I'll make it a little bit bigger. So this is, can you recognize what this I'm using here? This looks, because I used the default template, so maybe people look like, oh, this looks familiar. What's this? This is, yes? Don't know? Yes? Matplotlib? Yes, that's Matplotlib. So yeah, so this is Matplotlib, right? So very simple, but not the best looking one. It's just like this. So what is this doing here is basically a list of ice creams, because I love ice cream. So this is all the Ben & Jerry's flavor that I found in a CSV file that is on Cargo. So they have this Ben & Jerry data set, I don't know, of ice creams. So they have all these different flavors of ice cream. So what I want to do is that I have the CSV. I want to be able to filter it by the ingredients, so I can categorize the flavor, and then every time I click on it, it would give me a new presentation. So for example, I already showed a little bit similar thing yesterday, but I would click on, let's say I really feel like something with peanuts in it, right? So I click on it, and then you can see it changes. It's not able to do it in the past because like this is actually a picture. You can save images. So this is actually a picture that Matplotlib generated. But now with PyScript, because Matplotlib is run in the front end, it could be dynamically changed. So let's have a look at the source code here. You can see that this is how we write PyScript. We would, of course, have this wonderful script that I've shown you before. So this is just CSS file to make it look nicer, but you can have your own. And then we have some custom tag that is defined in the browser here by the PyScript. So this is like py-end. So this is how you do the import, like you do normally, like you import your library in your Python code. So this is how we do it, because we're using, oh, sorry, this is not import. This is supposed to be pip install. So you have to have this in your environment. So this is like installing pandas and Matplotlib in your environment. So this is py-end tag. And then you will need the interactive part. So this part is more like you have to have a little bit of knowledge of like, you know, how HTML code work, but you can easily find this online. There's lots of tutorial and stuff. So just like these are radio buttons, and I use emoji to make it look nicer. And then I need to have a place to display the output. So this is the part. I just give it an ID so I can call it later. So here's the heart of the whole thing. This is the PyScript tag. So so yeah, someone asked like, oh, why we just don't use script? But I'll explain that later in the Q&A section. But yeah, so we need to use the PyScript tag to write Python. So inside this tag, so this again is a pair of tags, just like this. So we will close the PyScript somewhere down at the bottom. But so this is Python. So you just import pandas as PD. This is something that some of us are very familiar with. Just, you know, all the data scientists just like import pandas as PD. Kind of, they can do it blindfolded. So this is how we do it. And then in Python, a little bit of new things that someone want to try using PyScript may have to learn is sometimes we need to use some functionality from PyODI just to make the, so because this is just how the browser work is different from how the Python work in our computer. So that's why, for example, if I want to open a file, I need to use the OpenURL thing from PyODI. Also, sometimes we want the interactiveness, so we need to create a proxy, which is a JavaScript proxy. Like, because, for example, JavaScript, you have event, listen, learn, all this stuff, but we don't have the equivalent in Python. Well, of course, someone can define it with async or whatever, but since we are working now on the browser, we can just create a proxy with PyODI, and that would act as an event listener, and then you can just like, you know, put that in, and it will work. So you can find this script if you look at this. If you follow the link of the slides and get the slides, then all the links there, you can look at it afterwards. So this is the first example. The second example is that for those of you who have to do a lot of map visualization, then this is something that you can see, oh, this looks familiar. This is actually Folium. And because there are tools that we all love, right? We want to still be able to use those tools. Folium is one of them that you may want to keep using. So this is Folium. And if you look at the source code, This is not so much difference from how you use volume in Python, right? Again, you have import and then, pandas, again, pandas. And then this is exactly like how you use it in Python. It's just the only difference is that you have to put it in the HTML file. You have to use PyScript to do all this stuff to dress it up, and then it works. It just works. So it's just a short example to show you that you can still use the libraries that you love to do your geographical, visualization. So this is a second example. So the last example is an upgrade of this. So this is nice, but like, this image, everything fell out of the box and stuff. And also when I click on it, it's just, it just gives me a new picture, and it's quite dry. So I kind of like stuff to look nice, so this is not the best. Well, you can still kind of make it, the color change it and the size change it, if you're very good at Matplotlib. I'm not, so I'm going to make another example of this. I think because I make it big, so okay, I'll make it a little bit smaller. So this is using D3. So now you can import D3 in your Python code. Wow, it was a dream, right? Because a lot of us do data visualization. We see how much stuff D3 can do, and it's so nice, interactive. All the animation are so cool. We wish to have that in Python. I know some Python library actually are using D3 as their backbone, but I want to be fully able to customize and build my own D3 application, and now you can do it. So this one, if you click on things, it will just be more dynamic, and I can size it up a little bit better and stuff. So this is nice. So now I can show you how to import D3. So here, again, everything is more or less the same. The only difference is that now I can import the D3 library, which is a JavaScript library, into Python. Yes. So any JavaScript library, in theory, you can just import it in Python. Of course, sometimes we stumble across some bugs because it's new again. So sometimes you find the edge case by importing some libraries that we haven't tested yet. But feel free to try. So now you can import D3, yay. And then all the APIs of D3 are more or less the same. So if you look at any tutorial about D3, I just learned like this, not so long ago, because I love D3, but I don't use it enough to be a very efficient user, so I still look up things. But you can look up the tutorial and stuff, you can still find that you can just use it in Python. Some of the syntax may change, right? Because Python, we have dictionary like this, and then you can't just call the items in the dictionary just like JavaScript does. But it's more or less the same. You select D3, so you have the visualization thing, you add different, they call it G, which is, I think is axis or something, you add it there. And then you can also have the transition, which is the animation, so you can still do that. Duration is how long the transition take, I think in seconds or milliseconds or something like that. And then, there it is. It's just more or less the same thing. Like, if you are familiar with D3, this is exactly the same. But why do I care, right? What's the difference? Is that because now I can use it together with pandas. I can still have my pandas read CSV, and they're together with the D3 code. In the past, you may have to run pandas separately and then generate a different CSV ready for visualization, or generate it as a JSON file and then put it for D3 to use. So now, again, skip a step. You can just use a data frame, a pandas data frame, together with D3, all in the front end, all in one go. So these will all execute it in one go. As soon as someone click the button, then the event listener will kick in and then just change it. So that's how you do it with the D3. So this is the presentation for today. Like I said, I'm trying to build more. So, or if you have new ideas, or if you have, any, you can try it yourself. I've seen a lot of nice creation with PyScript up in the internet. Make sure you tag the PyScript_dev if you have something you want to, let us know. Then please let us know. So now there's some Q&A, because this is actually not the first time I gave this talk. So last time there's very good questions. So it may be your question, so that's why I go through this. And then if you have more questions, feel free to ask me. So the first question is someone asked, like, can you pull in a Python script? And the answer is yes. I have done that before, so you can see my examples of what I did. I won't open it right now, but I can just quickly say that, like, you can actually import something here in the same directory in the PyM. So you can actually import another script if you want to. So the second question is, what is the Python version that we are using? Well, this is because, like I said, PyScript is using PyRDI. So, and I do believe it's the most recent version of PyRDI. So if you want to know, okay, which Python version is using, you have to check what is the latest version of PyRDI and what are they using. So yeah, like I said, it's different from CPython. So CPython, we know that, oh, now it's like in 3.10 is the latest and then 3.11 is coming out. So for PyRDI, again, it's a different thing. It's not CPython. It's not interpreting Python in C. It's interpreting Python in WebAssembly. So you have to check what they're using if you want to make sure that you're aligned with your Python version code. So this is the question that maybe you have. Is like, why I can't just use the script tag? Because, like, well, for JavaScript, I just do it like this, right? But why I can't use it with Python, then it becomes PyScript? Because this script tag is a default tag that is defined in the browser. And right now, none of the browser that we are using are commonly using supporting PyScript, because PyScript was just born this year in May. So it's a baby, it's very young, so no one is supporting it yet. So that's why the workaround now is to make a custom tag. So it's going to be Py-script instead of this, someone suggested. So I hope that answers some of you that have the same question. And then, so why don't you just use PyRDI? Because, like I said, PyScript is basically having PyRDI as the backbone, so we're standing on top of the shoulder of the giant. But I would make an analogy with, like, for those of you who are data scientists and know machine learning and stuff. There's a tool for doing deep learning called TensorFlow. But when I was learning TensorFlow years ago, I discovered something called Keras, which is using TensorFlow as the backbone. And, but it provides a very much simpler API to use and build a neural network with much easier. So you don't have to understand that much of the knowledge of how tensor work to be able to build a neural network. So it's more or less the same thing. Like with using PyRDI, you still have to understand a lot of like how the front end like browser, the script work, and how JavaScript, you need to create different things to communicate between the Python and the JavaScript and all this stuff. So PyScript just make it easier for anybody who doesn't understand too much about web application to be able to use it and run Python on the browser. So one of the idea that the PyScript team, that the goal of the PyScript team is to bring Python to people that they may not be programmers, but they like bring it to the 99%. That's quote exactly what our CEO Peter said. Is like to bring it to people. So because like it's kind of skip the step of like installing Python and then you can start using Python. You can just run it on the browser. So the idea is to make it as simple as possible. So that's why PyScript is. You can still use PyRDI if you want to. It may benefit if your use case needed. But PyScript has still got the space. That's why we need it. So this is all the questions that I've collected last time. So if you have more questions, feel free to ask me after when they come to this Q&A session. So the last thing I want to tell you is that PyJamasCon, the CFP is open. So for those of you who would like to try giving a talk, I mean, standing here actually is quite scary. I still feel a little bit scary, even though I've done it many times, but standing here in the new stage. But the PyJamasCon is going to be online, so online is a little bit easier. You can do it at your comfort of your home, so you don't have to stand in front of so many people in a new place that you haven't been before. So yeah, CFP is open. Feel free to submit something. If you want to know how to write CFP, again, I'm reachable. Feel free to talk to me. I can give you a few tips if you want. So that's it for me. So again, this is how you can find me, and all slides are available. And now I think we have quite a lot of time for Q&A, but I would love to hear your questions, and I hope I can answer your question.
Thank you very much for the very nice talk. So let's start right with the first one, or the most avoided one. How does PyScript behave in different browsers? It must be a favorite.
Yeah, that's a very, very good question. So right now, I think for the, I personally use Chrome, and so far everything is fine. Then the thing is that it will work in Firefox as well. But so it kind of works in like generally it works. But there was like something that we found actually last time. I was sitting in the sprints with the maintainer of PyIodine, and then I found a bug when I'm trying to build something. I was like, I found a bug, and then talk with him. He used Firefox, and I used Chrome. And the thing is that even though both of us got the same bug, and how the error was reported is different. So very interesting stuff. The sole answer is that I'm not so sure, but generally things kind of work in all kind of different browsers. But the error message is there's a minor thing that's like still difference, but I haven't found lots of discrepancy just yet. So yeah.
Awesome, thank you very much. There's another question which says the PyScript.net URL that you put in the HTML file, that probably includes the running of the script. That looks quite generic. So is there a way to refer to specific PyScript versions?
This one. Yes, actually, that's a very good question. I think we are now trying to think of different versions and stuff. But right now, there's only one available, and it's the alpha version. You can see it's under the alpha there. So yeah, right now is not. But I think the team has some idea of like whether we could have different versions of PyScript. So if people kind of want to stay in the same version, they could stay in the same version. But because it's still in alpha, so I think it's not. The system is not there yet. But I think what it will happen, I'm just saying, my guess is that it will be like, different script that you can call in. They will be different version. That's generally the practice with JavaScript as well. So I guess it will be like that, but right now it's in alpha. It's just like this. So yeah, but feel free to play with it. I mean, like, take it with a grain of salt because it's in alpha. So things are still changing very quickly. But if you want to know more, follow the social, the PyScript social. I think his Twitter is like PyScript_dev, something like that. Yeah, and also talk to me, talk to the team if you know anybody who's in the team. So yeah.
Awesome, thank you very much. And I want to remind everyone that we are answering questions from Slido. So if you want to ask anything or like upload a question you like specifically, feel free to go to slido.com. The event code is Python SK. So the next question is it's probably also something that you get asked fairly often. What are the limits of PyScript? So is it inbox, or does it have access to host system? I guess the question is at least what I understand is whether there is some sort of something being executed on some host machine, and that's probably not the case because it's all executed in the browser, right?
So do you mean that you can host your own script, or?
The question basically asks, is it sandboxed, or does it have access to the host system? And so I assume the host system access is not there, right?
Yeah, it doesn't exist. It all runs in the browser. It all runs in the front end. So all you're calling is like this script, which you can download and put it locally. It will work offline. If you download this script and put it, you can put it, for example, in the same directory, and then you call it from your same directory, and yeah, I think. So it can work offline. You can set up your own, so because all run in the front end, so there's no host. Yeah.
Thank you very much.
You can ask another question if it's not your question. So sorry about that. Yeah.
Sure, we still have time, so feel free to send them in. Okay, so Aside from pandas and matplotlib, what are the other like larger libraries that are supported, or is everything supported? Like even like crazy big stuff, like for instance Torch or something?
There is a lot of things. So if you go to, let's say, I can't remember, but because if you go to the GitHub of PyIodine, then they have a list of projects they have already available, make it available to use. So if we go to GitHub and make it bigger, I think they have a list somewhere here. And then people are still like always like requesting new libraries as well. So and yeah, they do have getting started no build and then document image, yeah. Do they have a? Yeah, maybe I'm just imagining things, but like they do have a list somewhere. Maybe it's not on the README. So yeah. I can. If you like, I don't know whether there's like many questions. So if you really want to find the list, I can find it for you later. Just grab me or ask me on Twitter. Yeah, but there's a.
It's a good idea. We don't have to go.
You can find the list, but it's quite an extensive list. There's a lot available, and also if you look at the issues, there's actually people requesting new libraries every day. So you see like new package requests and stuff. So if it's not available, just request it. Yeah.
Thank you very much. Let's go to the next question, which asks like, how have you used transcript, and do you have any opinion on it?
What script?
It seems to be called transcript. Feel free to take a look up there.
Oh, I genuinely don't know, so I can't answer this question. I'm so sorry. What is transcript? Can you tell me?
I don't know either. But
Yeah.
It seems to be something similar.
Yeah.
All right, nice. Then the next question asks, what batteries are loaded? Like, what else can one import other than standard library stuff? So I guess that's similar to the previous question we had. There seems to be a lot of packages, right?
Yeah. So what batteries are loaded? I can maybe briefly explain because so you see this PyN thing, right? So this is if it is an external library that you have to pip install, you have to do this. So the only catch is that if it's not supported by PyIodine, you can't put it here and it won't, even if you put it here, it won't work. But because, again, PyIodine support a lot of things, so most of the time you put it here and it will work, just like a pip install. For things that you don't have to pip install, you can just import it. I think I have somewhere that I just import JSON or something. So if it's something in the standard library, you don't have to put it in the PyEnv and then just like import it. So yeah.
And then we just got another question that's sort of similar. So like versions of packages is in the PyEnv tag. I guess the versioning is not happening in here. It's happening on the on some other level.
Yeah, again, like there's no, at least I can't think of a way of pinning the version of these environment just yet. I think if you really have to be picky about a specific version you're using, what you can do is to download the wheel. So because PyIodine is using the micropip for the packages, so you can basically get the wheel and something to pin it specifically. But but I think if you want to know what version you're using on default, you have to check with PyIodine and what they are using. Yeah.
Cool. Thank you very much. Then I guess we can get back to your very first example where you show the interactive histogram. So where did that CSV file come from?
Oh, the CSV file. Very good question. I think that's a very good observation as well. So this CSV file, I just host it on GitHub. The thing is, because a lot of question we got from the internet is that people will be like, oh, I want to load in a local file just like I do with Python. But the thing is, in browser, you can't load in a local file because if you imagine that is actually quite dangerous because if you just open a random website on your on the internet, and it will access your local file, and that's actually dangerous. That's why browser doesn't allow you to do it, except that you kind of manually upload a file or something like that. That's something extra. But normally, you can't just like load in a local file. So what I do here is to put that hosted on the internet. It's kind of, yeah, it's like, oh, why do I have to? But yeah, that's why, because the browser don't allow you to do that. So I load it on the internet, and then I call it in with this OpenURL tool from PyODI. So what if like, oh, I don't want to host it on GitHub. I want to, because it's, for example, it's a very sensitive file. I can't put it anywhere on the internet. But I still want to try out my app. So what you can do is to run a local server, and then with that, you can kind of make your local file act as if it's hosted somewhere, but it's hosted on your local server. So it's still in your computer, and then you can do the same thing. Yeah.
Cool. I guess the slides have been shown around, so hopefully there won't be finding those won't be a problem. Another question. Can you sort of like include Python files in PyScript? I guess the question is, can you do an import, local import perhaps, or something like that? And the other one is like, are there any issues with HTML characters escaping?
Character escaping. Ooh. So yeah, HTML character. That's actually a. Yeah, I think I would treat this as two separate questions, because, for example, the loading in another like Python script. Actually, I think I skipped the example, but now since we have time, I would try to show you the example, what I did with loading a local script. So it's something, yeah. So this is another thing that I've done, is another tutorial thing, but I have. All these are local. So this is how you load in a local script. In PyScript. So you just add the paths, and then you add this in. Again, if you just, like, for example, if you download this repo and then run this HTML, just double click it and run it, it won't work, because again, the browser doesn't allow you to do this, because you're loading in a local file. But how you can do this is to get the repo and then start a local server, then it will work. But yeah, if you hosted another Python script together with your HTML file, you can basically do this. So by doing this, actually, you don't have to put all your Python script in one place. You see, this is so much simpler, even though I'm doing some machine learning thing, because I put them in the Py file. So yeah, so you can do that. So the second question is there any like HTML escaping problem? There is actually something, I think, in the encoding that is fun. If you look at the PyScript repo, there's one issue talk about the HTML encoding thing. There is some escape, just like normal. For example, your URL, there's some escape for the space and all those stuff. So there are some escaping issue, but generally we just do the same escape thing, but we're still polishing it. Okay.
Cool. Thank you very much. I guess we have a sort of an interesting question here. So what would this version say in PyScript?
That's something that I want you to try. So someone please try it and tweet it and tag me on it. And what can I give you? With some stickers? I don't know. Maybe a swag. So yeah, maybe if you can catch me in a conference, yes. Yeah.
All right. Awesome. How does PyScript sort of make JS code out of Python? Is there any translation going on, or if that's the case, is that why PyScript seems to be slow?
Yeah, that's a very good question. So yeah, it's still a bit slow. It's actually not. So again, like PyScript, so PyScript or PyIODA actually is interpreting Python in WebAssembly, so it's not JavaScript, even though there's API to kind of convert some JavaScript object into Python object and those kind of things. The reason, I think most of the reason why it's slow, because loading in all this library actually takes time. For example, this one will be quite slow because you see a lot of things. So yeah, again, this is a new technology. So well, let's say Python has been here for a long time, right, for decades, and we are still making Python faster. So this is a baby. It's still very, very slow, kind of. So you can still do some simple visualization with it, but like if you do like heavy lifting things, then it's if you want it to be fast, it won't be very fast at the moment. But like you can deploy a machine learning model with not too much problem. This is actually a machine learning model. That's why there's some Pycon here, and then it got deployed, and then you have to wait a little bit. You see the loading screen a little bit, but it's not awfully slow. That you can make a cup of tea and come back low, and it's not that slow. So, yeah. So again, it's in alpha. So take it with a grain of salt and have fun and try it. You mean something are faster than the other. If you load a lot of things, of course, it won't be fast. Yeah.
Awesome. When we also got the answer to the sys version question, so it seems to be 3.10.2 of some comments using the and even Clang compiled. So that's pretty nice. Thank you very much, the audience.
Yeah.
It's very easy to be a moderator for something like that. And with that, thank you very much, Chuck, for your talk.
Come look for me for stickers, especially for who answered that question.
Awesome. And so the next point on the agenda should be the quiz, which should be starting in about 4 minutes. It was real nice, and I might reach out. This is something that we wanted to try out. That Slido. I really like doing visualizations this way.
Yeah, that's really cool.
Nice. Thanks.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom. Mikrobit má v sebe aj super vychytávky, ako sú tlačidlá, senzor pohybu, kompas a teplomér. K mikrobitu ale môžeš pripojiť množstvo ďalších vecí. Tu programujeme, aká animácia sa nám má ukázať na LED pásiku. Ja som na ňom naprogramovala dúhu. Teraz programujeme podľa nôd kohútika Jarabého. Najlepšie na mikrobite je, že si viem vytvoriť napríklad blikajúceho robota alebo gitaru, ktorú ovládam tak, že ňou zatraciem, alebo futbalovú bránku, kde mikrobit počíta, koľko gólov som dala, alebo kúlové svietiace topánky a 1000 ďalších vecí, ktoré ešte len vymyslím. Mikrobit je hračka, ktorú schováš do dlane a vytvoríš z nej čokoľvek. Tak čo s ňou spravíš ty?
Každých 60 sekúnd si 28 000 ľudí predplatí službu Netflix. Odošle sa 197 miliónov e-mailov, stiahne sa 414 000 aplikácií a ukradne niekoľko tisíc hesiel. Na internete sa toho deje veľa. A všetko najdôležitejšie sa dozviete na Živé.sk. Živé.sk. Technológie ľudskou rečou.
kameraman ti kývne, kedy môžeš začať.
Okay, so hello. Sorry for the slight delay. Once again, we had slight technical difficulties. We weren't able to connect to the Wi-Fi, but it's somehow managed to work now. And don't worry, you'll have an awesome ability to win prizes. So I hope that your waiting will be worth it. But before that, before the quiz, I'd really like to have a special announcement, and I'd really like to thank all of the awesome volunteers, most of which are now currently on your left side, which helped this Pycon happen. Without them, this Pycon wouldn't be able to be organized, to function as well as it functioned, and without them, you couldn't be sitting here without larger problems. And because there's quite a lot of them, not only those which are here, but also a few which already had to go home or will return tomorrow or will come tomorrow to help us pack hold of the conference, I won't be going through each one's name, but most of them are here on this photo. Some of them are here and some of them will be here tomorrow or were here yesterday. The core team were 4 people, 2 of which, Euka and Nika, organized the educational summit, which was happening in the spy room and in the workshop room across the Titans room. And me and Richard were responsible for the conference as a whole, for the rest, everything rest from the educational summit. And there are also a few special people which we would really like to thank. First of all, it's our lovely photograph, which came to us. And as he's a photograph, unfortunately, we don't have any photos of him from the conference, but you can find his photos all around this place, either on the conference website in a few days or on our Facebook already and other social media. And we have also sent some of the photos to our partners already, so maybe on their websites as well. Another special group which I'd really like to thank is our HV group sitting in that room there and here in front of or behind the camera, and also the ones who were sitting in the next room. They had to fix a lot of problems which happened, and the problems weren't their faults, and they somehow managed to solve them. So really a big thanks for them. So another round of applause, please. And a special thanks also to 2 people who aren't directly in the volunteers organizing group, but thanks to them, we have awesome designs. It's Marek Bruchaty, thanks to whom you have these lovely lanyards and the program and all the sponsors and the map and everything, which you can see is thanks to Marek Bruchaty's work, and Juraj, whose work you've seen before and after the talks with the lovely graphics which happened in between each talks. And there's also one special thanks which I personally would like to give. And it's to my wife, who has endured me organizing this conference and not being able to be with her in the evenings because I was sitting behind emails and organizing this after my usual work as a volunteering activity. So a big thanks for her, and I'm going to give this to her. And of course, it wasn't only me who was working, she was also working really hard as well. So don't confuse it that she was only somewhere on the sidelines. She was also helping me all the time, and you've seen her running around as the rest of the volunteers as well. And now to the interesting part for you, where you can win prizes. So here you don't have to enter any money, you can just earn really awesome prizes. After the quiz starts, we will put all of the prizes here on the front of the desk, and you'll be able to pick your prize. We don't have a special we don't have it dedicated, which is the first prize, which is the second prize. We will just put all of the prizes here on the front desk, and you can pick whichever you choose, whichever you want. And I'll just have now a brief recap of what everything is here to be offered. So first of all, there's going to be quite a lot of books from our two sponsors, Pact and O'Reilly. Then there'll be speakers from Bloomreach, a bunch of subscriptions from JetBrains. So if you are using PyCharm, definitely this is a really good thing because PyCharm is one of the best Python editors. Then we have from SwissRare a bunch of other things, including a power bank and a keep cup. Atacama has also provided a power bank and a speaker, Bluetooth speaker. Exeta has provided a few things, so those are also speakers, a wireless mouse, a wireless keyboard, and a few other things, a power bank, which you can't see on the photos because there's quite a bunch of it. And there's this one special thing. Can you guess which sponsor donated these prizes? Yeah, it's LMC/Professia, exactly. And now, to the contest itself, it's going to be via the app Kahoot. And in just a moment, we'll show you the exact link where you can connect. And my colleague will moderate the contest itself. Okay, so now please head to kahoot.it and enter the PIN, which you can see on the top. Or you can use a QR code. Okay.
There is also one special book from Miro Shedivi, yesterday donated, because nobody picked it after his talk. So yeah, let's don't forget about him and his generous gift as well. So I'm not sure if everyone is aware how Kahoot works. Let me briefly explain while we wait for everybody to log in. If you go to kahoot.it, you can enter a PIN. You can log in, enter your name, and afterwards, once I start the quiz, you will see the question on the screen, and you press on your mobile phone the correct answer. Whoever has the most points is the first one and can pick first prize, then the second, and so and so and so. Yep, that's basically it. So I see several people are still logging, so let's wait a couple of seconds more and then we start. Okay, so people are leaving, so I should start probably. So, when was the first Python release? You can select one of the answers. It's one of the colors. You have only 20 seconds, so then you can, okay, we have, all right, so the correct answer is 1991. In 1989, it was announced, but according to Wikipedia, you can verify if you don't trust me, the first release was in 1991. Okay, so Mira Hrončok. Okay, so let's go for the second question. When did the Guido van Rossum step down from the benevolent dictator for life position? So for those, BDFL means benevolent dictator for life, and Guido was the dictator, but he stepped down. So what was the year when he did that? Okay, it was 2018, so 22 people guessed it correctly. Ah, Miro Hrnčok. Yeah, so Pycon is leading the way. Okay, how many people are in the steering council, Python steering council? Python steering council is essentially successor of the benevolent dictator for life, and its core developers are in the Python steering council, and it's elected with I think every version. So yeah, there is 5 people in there. So almost most of you got it, but okay. So let's see the scoreboard. All right, so Pycon is still first. We'll see how it goes later. Where is the Python source code hosted? Since you know that the Python is open source, it has to be hosted somewhere that it's accessible for the people. And recently, I believe it has moved, and it has moved to the GitHub. So yeah, you can find the source on GitHub. Okay, so see, Cheuk is leading and Pycon is the second. So we will. Oh, sorry, sorry, my bad. So what is the latest Python 3 release? So yeah, most of you got it. It's 3.107. All right. So Pycon is returning to the lead. What signifies the end of the statement block or the suit in Python? Yeah, some of the questions will be technical, but some of them won't. So yeah. We will test all kind of skills. All right, so that seems to be easy one. Most of you got it correctly. All right, so let's continue. It's true or false question. In Python, variable must be declared before it's assigned a value. So is it true or is it false? Yeah. All right, so free prelats have a streak. All questions right. Yeah, we'll see. So which of the following styles does PEP 8 recommend for multi-word variables? So if you have a variable that contains multiple words, what is recommended according to PEP 8? Right, yeah, a snake case, obviously. Okay, so we still have one leader. Let's continue. Which of the following are valid Python variable names? Oh, by the way, I forgot to mention at the beginning, usually there is one correct answer, but there are probably 2 questions that they have multiple, so. Okay, so What Python built-in function returns the unique ID number assigned to an object? So what, let's say you have variable a, you assign 5 to it, and you assign variable a to b. What function will identify that it's the same thing? Okay, it was the ID, so yeah, most of you knew the answer. I think we have one person who is really good, and there is, okay. Which of the following are true of the Python dictionaries? So, yeah, this was the question that had multiple correct answers. So yeah, but most of you knew. So which of the following is not Python built-in function? So which of these you would have to implement by yourself if you want to call it? All right, so most of you. Okay, so which of the following are true for the objects of Python set type? Okay, so yeah, this was also multi-correct answer. So, okay, we see at least it's changing a little bit. How are lambda functions useful? Select all that apply. I gave 30 seconds for this question because there is a lot of reading. Okay, so yeah, most of you got it right. So it's true or false question. The Python interpreter takes the code you write and converts it to the language that your computer's hardware understands. Is it true or false? All right, so yeah. Okay, I thought this one would be easy, but I guess it wasn't. So the technical questions are over. Now let's go to more guessing one. When was the first Pycon SK? So this is the question for people who attend frequently have easier the answer, and those of you who are here for the first time, you have to guess. So yeah. Yes. Oh, okay. most of you knew or guessed correctly. So yeah. Yeah. So Miro is start leading, so it's gonna be interesting at the end. So what was the color of the attendee T-shirts at the Pycon 2016? So. Yeah, it was white. We have a lot of grays, but it was later on, so yeah. Okay. So how many speakers were at the first Pycon? Okay, so it was 26. Okay, the scoreboard is changing at least a little. So, how long is the lightning talk? We have them yesterday, and they will be, so that this is gonna be probably easy question. We should have probably 10 seconds on this one. Yeah, so, there is one person in the room who wasn't paying attention yesterday. Okay, so what is the name of the cable wrapping method we saw yesterday at the lightning talks? Yesterday there was a guy here throwing cables and he showed us cable wrapping method. So what's the name? Let's test if you were paying attention. Yeah, okay, over and under. Yeah, most of you were paying attention. So, which is the next planned Pycon in Europe? So, obviously, you know, there are a lot of Pycons around Europe, and there is the yeah, so it's Pycon. You can Pycon Estonia already was, and Pycon in España and PL will be later on in the future. UK should be next week if it's not gonna be cancelled, but okay. When was the first EduTrack at Pycon? As you might know, we have EduTrack focusing on teachers, and it is part of the Pycon SK. So when did we start with this good tradition? You have several choices, so you can guess. Okay, so yeah, 2017. It was one year later than the original Pycon. Okay, it's changing. So, how many teachers attend our teaching with hardware courses that we did last school year? So, during the school year, we have special courses for teachers, how to teach with hardware, with microbits, and I want you to guess how many of them attended. Okay, 440, so good guess. And last but not least, there will be last questions. How many 3D printed face shields have we donated to the homes for elderly people? You know, during the pandemic, everybody was helping as they could, and since we loved technology and we liked 3D printing, we did as most of the 3D printers did, and we donated them. So you can guess the number. So it was 1,000 shields. So all right. So FK is the third. You can go to the podium. Miro is the second. And Christian is the first. And Petr and Palajk are the next one. So please come downstairs and select from the prizes, whichever you like. I will find out the scoreboard, so the rest of the people could take whatever is left. We will go from the higher score down. And for those of you who have lightning talks, please come here downstairs so you can prepare and so we can start. Marek? Keď dám next, myslím, že mi to vyhodí ten scoreboard, lebo ja nepoznám ten Kahoot tak dobre, aby nám to nezmizlo.
Full report.
No, okay, view report. Skúsme to.
Okay. Stop.
Okay, so okay. So you can see the scoreboard. If you see your name, you can go downstairs and pick up the prizes. Oh, it's too small. Potom dáme ďalšiu stránku, keď si zoberú.
Okay.
Si ready. Dobre. Ríšo, si rozdáme ceny a ideme, že? To je, že speaker, že môžeme...
Ja už som mi povedal, že nech sa pripravia.
Dobre, prepáč. A ešte to chvíľku nechaj, prosím, že...
USBCčko potom potrebujeme.
Áno, tiež je tam USB-C.
Marek, ideme teraz chodniť? Kto bol prvý, nech si toto vidie, aby sme mohli dať ďalšiu stránku. Dobre, voláme ďalšiu stránku. Okay, so if you see your name in this page, please come here and pick the prizes. And yeah, so we will do the next page in a minute. Okay, so let's get more results. Okay, so if you see your name here, you can go downstairs and pick your prizes.
Na budúce možno po peťkách by to bolo trošku spravodlivejšie. Ale...
Okay. So if you see your name on the screen, you can go down and pick whatever is left. Come on, people, you don't like books or whatever? Pošlám ďalšiu. Či pošlám, alebo ešte počkáme? No, môžem už.
Dobre. Tak posledná asi, hej?
No, ešte knihy budú nejaké, podľa mňa.
A knihy, čo zostanú, zbalíme a inak rozdáme.
Okay, so this is the last page, and if you see your name, you can come downstairs and pick the prize. And for the people who have signed up for the lightning talks, please come downstairs and we can start with the lightning talks. Potrebuješ ty počítať? A tu
after the holiday of the second day of the conference. This should be very quick. I just would like to invite you for the next PyData Prague meetup, which will happen shockingly in Prague. So I guess you know the mission of the PyData. So it's basically about data science, Python, and everything around it. So if you will be at the time in Prague, you are most definitely welcome. It will happen on the 18th of October in LMC. That's actually a company I come from. We have a tea room here. I hope you enjoy the tea. So we have a tea room also in the office. So if you will come to the meetup, there will be some. And as well as some alcohol and soft drinks and a lot of food. And as well, very nice talks. For example, first speaker who is confirmed already will be from Rossum, if I remember correctly. And it will be about machine translations. So this is about a meetup. I would like to say also that we already had like 11 meetups before the COVID and during the COVID and after the COVID. Here are some pictures from the latest meetups. It was very nice. It happened, shockingly, again in Prague. And we have a lot of accounts on Facebook, Twitter, LinkedIn, so check it out. And Meetup RSVP is on meetup.com, so if you want to come there, just register and come. Yeah, sure. We are still looking for one speaker, so you can be one of you can be that guy or a girl. And the last thing, we have a YouTube channel full of videos from the other meetups, so check it out. You can find it just if you write PyData Prague. It's under the PyData channel in general. So this is it. And do you have any questions about our little community? Where is it? Thank you, guys. So can I just unplug it? Yeah, okay, good. Thanks.
Nemáme link. Skús nastavenia. Malo by to ísť po Full HDčku von. Display, display. Aha, to je display. Display settings. Scaled. A chceme Full HDčku, malo by to byť. Toto? Dám. Stále nemáme, dobre, ja to skúsim takto ešte. Ok, môžeme vyskúšať tú druhú dokýmku, tak. Tak skúsme ešte toto teda. Širokou.
Už tam čosi je. Máme. Super.
Dobre, máme. Dole si vieš pozrieť, čo ti ide von. Dobre.
OK. Dobre. To sa tam nejako neskoruje.
Je to chytené u mňa. OK.
OK, super. Tak ďakujem za sprevádzkovanie, už nám všetko beží. This presentation will be in Slovak language, but the slides are in English, so I'm sorry, but we are talking about the Slovak community, cloud native community, almost about Kubernetes. So at first, I would like to talk about what is Cloud Native Computing Foundation. Cloud Native Computing Foundation is dcerskou organizáciou Linux Computing Foundation. A je to v podstate neziskové združenie, ktoré spája open sourceové projekty, nadšencov a spoločnosti spoločne na jednom neutrálnom mieste. Tu mám Cloud Native Computing definíciu, je to také trošku zložité, alebo vyzerá to dosť tak ako strašidelne, ale chcel by som tam upozorniť na jednu vec, čo tam nehovorí sa o čom, a to je Kubernetes ako taký. Kubernetes, ktorý ako kľúčová technológia v Cloud Native Computing nie je súčasťou tejto definície. Hovorí sa tu všetko o mikroservisoch, o immutable infrastructure a o rôznych ďalších veciach, o deklaratívnych apinách. Chcel by som pár slov o tom, že kto sme a čo robíme. Takže sme Združenie pre podporu Cloud Native technológií. Máme na to neziskové občianske združenie, ktoré organizuje pravidelné meetupy, na ktoré by som vás potom aj v závere chcel pozvať. Čo sme, alebo ako už v podstate momentálne fungujeme, sme na trhu viac ako 3 roky. Máme viac ako 400 členov momentálne už na meetup.com. Mali sme viac ako 1700 ľudí na našich meetupoch a máme veľmi veľa fanúšikov na Facebooku alebo aj na ostatných médiách. Tiež na nejaký taký priemerný meetup chodí povedzme od tých 30 do tých 50-60 ľudí. Už sme v podstate spravili momentálne viac ako 30 meetupov a jednu konferenciu. Toto bola konferencia, ktorú sme robili tento rok. Je to konferencia Kubernetes Community Days Czech and Slovak. Bola to virtuálna konferencia a uskutočnila sa v apríli. Tiež niekedy ešte nemáme momentálne na plánu, ale budúci rok by sme chceli urobiť pokračovanie, pravdepodobne už vo fyzickom prostredí. Celá naša v podstate fungovanie a organizácia je k dispozícii na Facebooku alebo na YouTube channeli, kde máme naše videá, všetky dispozícii sú tam nahrané aj prezentácie, aj záznamy, videozáznamy. Aktuálne sme prechádzali s meetup.com na community CNCF.io/Bratislava, takže keby sa niekto chcel pripojiť alebo zapojiť do našej komunity, môže si načítať tento QR kód alebo navštíviť URL-čku a tam si prikliknúť a dá sa potom bez problémov prihlásiť na naše meetupy. Máme tiež aj samostatný Slack kanál, kde je viac ako 300 ľudí momentálne už prihlásených, takže pokiaľ by chcel niekto komunikovať alebo mal nejaký problém s prevádzkou, tak ako kľudne sa môže prihlásiť. Dobre, takže toto sú nejaké naše komunity, kde fungujeme. To je v podstate, jak som vravel, to community CNCF.io/Bratislava, Facebook alebo ten Slack. Čo teraz najbližšie plánujeme, takže toto je nejaký taký harmonogram našich aktivít. Tu by som chcel ukázať, že sme v podstate pomerne aktívni. Snažíme sa robiť pravidelne meetupy. Najbližšie budeme mať teraz v septembri ešte meetup ohľadne observability and analysis a monitoringu. Ďalší mesiac bude o management tooloch sa budeme baviť, potom v novembri by sme sa chceli baviť o bare metale a hlavne o ARM procesoroch. Vždycky robíme tak 2-krát do roka aj také neformálne meetupy. Jeden býva v júli a druhý býva v decembri. To bývajú buď nejaké také ako pivo alebo nejaké tieto vianočné trhy. No a ešte potom v tom januári by sme chceli robiť Kubernetes operátorov. Dobre, to bolo z mojej strany všetko teda, takže ak má niekto záujem sa zapojiť do komunity alebo sa dozvedieť viac, tak si ma kľudne odchyťte, rád poviem nejaké podrobnosti alebo čo bude treba. Ďakujem zatiaľ za pozornosť.
Držme Linux. Fedora. Co tady je? Něco tady je. Tady Let's hope for the best.
Okay. To máme hore.
Ještě no? Jo, jasně. A jak to přehodím? Is it working? Nope. Ještě no. External. Word. Yes. Okay.
Okay.
You can go.
Dobre, Patia, máme.
Okay. So, hello everyone. After a fierce discussion with my colleagues, I have a question for you. How often do you leave your mobile device at home? When you're leaving, of course. I guess not very often. And the other question is, what do you mostly do when you're looking at your screen? Like, I have to confess, that's mine. But just let's face it, we are all addicts, or almost all. I will not partialize it that much. We feel almost constantly the urge to play with those little devices and check and interact and swipe a lot. And it seems that it's here to stay with us because the dopamine shots we get from it is just, it's really hard to beat. So we can still play with those devices and wait for those likes under the new photos we posted on Instagram or some other favorite social network. Or we can erase the blank points from the maps. We still have them in 2022. This is a topic related to the yesterday's talks, so I wanted to do a quick follow-up on yet another possibility, how to contribute to open source. And this is MapSwipe. So the idea behind the MapSwipe is that it's in a mobile app. You can install it on your mobile. Through the quests, through some gamification techniques, tapping and swiping, it helps to respond in the places of the world where crises are most probable to happen, where the first response team need to get on time to the people that live somewhere where the maps are not yet built. So you can be the hero and the adventurer at the same time. You can save people by increasing their visibility on the maps. The idea is quite simple. You can choose your mission, you can choose the geo you want to focus on, and then you get the quest. You can either find buildings or roads or waterways or some other quests I don't know about. Then you tap when you spot the building or the goal of your activity. If you can't spot anything, because the clouds, for example, cover the imagery, then you just tap 3 times and it's red. So basically they use the system of flagging like green, yellow, red. Quite intuitive, I'd say. Oops, sorry. So this is an application that's open sourced. Its source code is hosted on GitHub. I mention it on Pycon SK also because the backend of the application is written in Python. So you can contribute to the maps either by downloading and mapping and helping the teams out there, or you can also contribute to the source code work it. So I'd say grab it, do it, while waiting for those likes. Thank you very much.
Z druhej strany.
Máme HDMIčko.
HDMIčko je...
Toto dole to bude vidno na hľadáku.
OK. Nice. Dobre, ale prepína sa týmto?
Môžeš dať hore.
Čo?
Dobre. Prepne to kolega z režie. Ešte mikrofónky trošku nasmerujem.
Jasné.
OK, môžeš patriť.
So, hi guys, I will be today talking about cool things you can do with ClickHouse. So, let's start with some history. ClickHouse is an OLAP database that was built in Yandex, that is something like Google, but in Russia, and they use it in their Yandex Metrica. Luckily, it's open source, so nothing to worry. And also, it has like built a really big community in all around the world. So what they use ClickHouse is basically Yandex Metrica, which is basically something like Google Analytics. So it tracks users, what they do on the websites, and then it's like processing in the back and displaying it like Google Analytics, basically. So why do they actually need this ClickHouse, and they don't use something like MySQL or another relational database? So basically, this is column-oriented database, so it's built for like big data ingestion, like gigabytes per second per server. It can process these data like really fast. It can do aggregations and stuff like that. But the drawback is that these data are mostly immutable. Also, it provides time-oriented features like window views, so you can calculate like aggregations for past 10 seconds and stuff like that. And other databases like MySQL or MongoDB are really not suitable for stuff like that. So you can go.
And one of the beautiful use cases of ClickHouse is Plausible, which is a sort of alternative for Google Analytics, or they call it lightweight because it's like 45 times smaller. So it's open source still for tracking your website traffic. And it's fully compliant with privacy regulations like in Europe, also in America, because how it's working, it's hashing basically everything about you. It's not providing any session ID from the cookies or anything. So it starts tracking the moment you actually enter your website, and it's anonymizing everything based on your domain, from device you joined, also what time you actually joined. And like every 24 hours, this is recalculated, so you don't have to be worrying about. They have like even the Plausible has a lot of use cases. For example, you can do A/B tests on your website with the data that you collect from Plausible, or within the marketing, you can use UTM tags to track your ads, emails, social media posts. So basically, you can track how many participants are, or like, for example, with Slido, how many participants joined from Slido that type really into the browser, or how many people came from Facebook or Google. And I'll show you some beautiful graphs later on. Or you can set your own goals as well. For example, you want to see how many people click on a certain button, or like whether they prefer this way or that way. So as I said already, see the test. Okay, so if they're not collecting your personal data, what data is actually collected? So as I mentioned, source of visit, so where you came from, when did this happen? If you, for example, set up cookies, so like you can use Plausible with Bloomreach, or former Exponent, and also Google Analytics at the same time. So then you're collecting different data, but it's another talk. So you can grant like what consent you gave. So you can say there's a personal goal, like did you give them just analytic consent or the consent to collect all the data? You can track the time spent on the page, the entry page, exit page, so where did they go after they visited your page, custom clicks, country, operating system, device, or even the browser. So these are some nice. They also provide you with dashboard where you start. You can see, for example, page visits on one of the Slido's page. Like you can see the total number in the day. There was 121. It was today, just one of the random pages. Number of unique visitors, because obviously, like within the 24 hours, I can decide that I would open Slido twice at least. And there you can see also the sources and different devices. So like for us, it's important to see whether you came from a mobile, so like we can decide what to optimize better. So I guess thank you for everything. And that's it.
Yesterday it worked, so I think it should work again. Seems like it works.
Sure.
Yeah, no, yes, well, that's true. Hello, my name is Cristian. Maybe you remember me from my lighting talk yesterday. So I wanted to give a talk about a different topic. So while I was preparing those slides, I must confess it's the first time that I'm in Slovakia, and I didn't know anything about the country, anything. I am from South America, and for me, like geography in Europe, still like a mystery sometimes. Oh, there is that country. And I was, when I was even putting the flag on this little map that I showed at the beginning, I was like Google like 4 times, like just to be 100% sure it was the recent flag. It was like no political like messages, whatever, because I didn't want to mess it up, right? So I started to think, what do we have in common? Like you, like people from Slovakia, and myself, like from South America. And then I thought about Python. You remember Miro's talk about like how complicated names are. I suffer from them myself in Germany and everything. Like I have an accent on the A, so it's not Christian, it's Christian. I'm not Christian as well, but whatever. And then what do we have in common? Like we need to learn English to interact with the other people in tech, right? So I was really happy because a long time ago, with a group of people, we decided to start translating the documentation of Python to Spanish. And if you're not aware, we are, of course, we have better positioned there because there is the list of all the countries that speak Spanish. So a lot of people. It was really fun. And yeah, I mean, we had a little repository here with many contributions, and even someone did a graphic there with all the names of people contributing to stuff. So I say, cool. So I will look the Slovak version of, and there was nothing. So I said, how can I motivate the community in Slovakia to start, digging more into Python stuff? So then I remember the talk by Peter yesterday that he briefly mentioned some unspoken version of Python, and I decided to go to the repo, see Python, and compile it myself. So here, well, you can see that, I have a typical Python binary, and I compiled the latest version from the C Python repository that you all are aware of. And I execute it. And then I noticed that there was something weird already. So I decided to say, okay, well, this is Python. So as you know, Python is a calculator. Yes, we can do math. You can also check for things like, for example, how do you check if a variable is a string? Like, how do we check if S is a string? So if you are good programmers like I am, do you know that you can check it like this, right? So then if you have this is valid Python code, you can try it. And there are many other things, like how do you check, for example, like if a number is a power of 2? It's really simple. So let's say you have a number, and then of course, you need to use the way of defining, like, bitwise operation. And then if you have, like, for example, a number that is not a power of 2, you can check it as well, right? So I said, okay, well, whatever, everything seems fine for me, like everything is Python. And then I see I did a little help. Sorry, I did a dir of the things that we have in this here. And then I noticed that it was a special translate function. So I said, okay, translate. Where do we put it there? Oh, you cannot see it. Oh, really sorry. So maybe there, using the country code. Okay, fair enough. So I said, okay, translate. And then that weird thing started to happen, right? And then, okay, fair enough. And I was completely new. So this morning, I started to open all the Google Translate dictionaries. I started to ask a few people around. Maybe you ask me, like, what is the equivalent? How can I say this in Python? And then I say, okay, well, whatever. So first of all, I have 1 minute left. So how do you check if an element is in a list? If this is in the list, how do I check it? With? Exactly. What do you check if this is not on the list? Of course. And then you can do even more nice things, like I said, okay, well, I love for loops in general. So I said, okay, let's write a for loops, all right? So I said, okay, so and then you can say, I don't know, like you can check if something is like that. And since I don't have this, I remember that I put this here, so maybe it's the and then you can have parallel numbers here. So if you are interested in this, yesterday you couldn't see my social information, media, whatever. So this is my name. You can find me then on social media there. If you want to know the patches that I did, just write me up. Thanks.
regain it. It's the same screen?
Yep.
Also.
Okay.
Hi everyone, I'm Danny and I'm from Italy, and for this reason today I'm talking to you about how to make pizza with Python and Django. Well, you can start creating an object called pizza with white flour. Then you can add olive oil. You can add tomato sauce. And then you need to add toppings. Well, maybe another kind of toppings. Don't try this, please. So maybe you want to roll back our last instruction and update with proper toppings. How you can do it? Using maybe Django version for Django, and is an extension to the Django web framework that provides version control for model instances. You can roll back at any point in a model instance history. You can recover deleted in model instances, and all of this with a simple admin integration. You can install it using pip, add reversion to installed apps in Django settings, and run the first migration. You can integrate into your admin like this, registering the pizza model, extending version admin. And in the admin page, you can see a nice recover button in the model list. And in the change page, you can see the history button. You can register your models for reversion and using reversion API, like this one, just registering everything or just single fields. And so you can roll back your pizza object to a previous version. You can update your toppings using a proper toppings, please. And you can bake your pizza. What about Django REST framework? Well, if you want to integrate Django version in REST framework, you can use this package I made myself a few months ago. You can add two middlewares in reversion, and you can register your model in the same way and extending your model view set using history model view sets or other mix-in you can see in the documentation. You have a couple of endpoints, like history endpoint, deleted and revert for listing your history, deleted records, and reverting an object. Here's the mix-ins, and that's it. Thank you, Arthur, for suggesting me this talk, and these are the links if you want to follow back.
Oops. Tady mám slidy. Mám tady něco zmáčknout. Oh, great, thanks. So we can go. Hi, yesterday I had a presentation about creating maps in Folium, and after that presentation I was approached by one of you asking how did you make those slides, and it was sort of apparent that those slides are from a Jupyter Notebook, so I wanted to show you here now how to convert a Jupyter Notebook into a slide deck. And it's very brief, so I will spend a bit seconds with interacting with you. How many of you work in Jupyter Slides, at least occasionally? Could you raise your hand?
So I hope it will be interesting for everyone, although I guess just half of the people say they find this environment familiar. So basically, look, you can take a Jupyter notebook and convert it into HTML document. Notice that there is this arrow here. So if I click on write, I get to section basics. Basically, one slide is one or more cells in the Jupyter, and you must set that cell how it should be rendered. So I set a cell which contains text section 1 basics to slide, and you see another arrow here. So if I go to right, I go to another slide, and if I go to back, there is also arrow down, which says subslide. So the other type of cell you can have is a subslide. It can contain code, it can contain markdown. So this is how it looks like. And now I go to the Jupyter notebook to show you how to get this, right? So that's the Jupyter notebook. You remember that very first slide was intro slide deck for the lightning talk. And that's my first cell here. Then this is another cell, and another cell. How do I say which of them should be the main slide and which of them should be the sub-slide, so the one that you go to below? Well, now the thing that you should learn if you want to do this, you must go to this view cell toolbar and activate slideshow. See the difference? Here I got these drop-downs, slide type. And back to that presentation. If I want to have the main slide, I select slide. This is another main slide, and this is a sub-slide. So what's the difference? Main slide has no sub-chapter. This is the first slide of a chapter. This is another main slide, and if I go down, I want to really develop that chapter. It's a sub-slide. That's the entire magic. There are also cells which you can suppress. If you have some password here, you say skip, and yeah, that's it. And how to get it? So I noted it down for you. You either do it through this graphic way, download as, you see it here, right? Reveal.js slides. Or if you come with some extra requirements, like I want to use another template, I want to suppress the code, or vice versa, I want only show the code and not the outputs, then you can access these slides through a command line. The command is simply Jupyter nbconvert notebook name, 2 slides and options, and I also prepared an example of that. So I am in that directory with slides from Jupyter Lightning Talk IP notebook. Now I run this thing, this Jupyter nbconvert. Are you able to read it? Or I just read? Well, so it's Jupyter nbconvert, what notebook to convert, and then parameters. One of them is 2 slides, and the other ones would be like suppress code or whatever template you want to use. I click on that, a moment of magic now, and it tells me, yeah, this notebook was converted to slides. So if I list the content of the directory, you see there is HTML there. If I go there, yeah, this is the brand new thing which you have seen beforehand. So that's it, really, to wrap it, activate these options for slide type here in view, and then either download or go through command line. Can we have multiple cells on one slide? Yes, let's talk about it. It's called fragment, actually. Yeah, thanks.
Hello, folks. While I'm plugging in, I want to ask one question. Who of you is enjoying connecting with amazing Python community and folks at Pycon Slovakia? Raise hands. Yay! The conference is amazing, right? Yeah. Woo. Yes. So I'm going to talk about personal brand for a developer. It's like totally non-technical talk, but it should be useful as we are all at the conference. No, and it's not working, so.
Yep.
Is it?
It is, yeah.
So as we are all at this amazing conference, it can be super useful for all of us tech people. So let me introduce myself. I'm Elena Osipova. I'm DevRel and Tech Community Manager at Kiwi.com. And by my job description, I work with developers, and I listen a lot about all the projects our developers are working on. Developer wrote an open source library that we decided to use instead of existing solution, or our auto booking tribe were migrating to Camunda workflow engine, and it was epic. So I'm hearing a lot of stories, and I'm proposing them to go public with it, to go visible with it. And imposter syndrome kicks in, and they are starting to tell me this: I'm not skilled enough. I don't know. I'm not sure. I'm not ready to go public. I'm not ready for public speaking. Can you relate to this? Yes? OK. And it can be even funnier. Oh, sorry. Oops, it's not working anymore. OK. Yeah, my slide stopped working. Yeah. So yeah, basically, ooh, that's unfortunate. You cannot help me with it, right?
What do we have here? Okay,
it's like
for some reason.
It's like not working at all.
Let's do standard programmer.
Yeah, guys, sorry about that. It happens. Should I like just keep talking? But no, it's like I've been preparing the slides for like an hour. Are you kidding me? I think my colleague is like super popular now.
Yep. Sorry for that.
Will you add me some time at least? I love my laptop. Is it working now?
Come on. Yep.
Yes?
Yes, now it's working.
OK, so yeah, it can be even more interesting. Like, I have no interesting topics. My size of the merge is like too small after pandemics. So yeah, imposter syndrome. But I want to tell you one thing. You are not the first one to talk about this, and it's fine. Your topic cannot be like 100% fresh, but your point of view, your opinion can be really valuable for the community. And strong personal brand can also lead you to more interesting projects, to more valuable connections and great people, and even better salary, actually, and new role. So before you start working on a personal brand, try to define who you are. You can first try to ask your friends and colleagues, who do they think you are? You will hear a lot of interesting, exciting stuff about yourself, even surprising. Or you can also check out this thing by Carl Jung, which is used a lot in branding. And you can try to think if you are a trickster or lover or explorer. It's really interesting. I cannot cover it. I cannot cover this thing now during my lightning, but just check it out by yourself. Just Google it. You should set your goal. Just try to think if you want to work on a personal brand for getting a new job or better salary or just meet new people or promote your project. Just set up the clear goal and start working. And this Pycon Slovakia is really a nice time to do so. Grow your network, talk to people. Most likely today a lot of people will be going for beers. Just find us in Code KiwiCom t-shirts. We will be talking to people a lot. Write an article, start your own blog. Apply to talk at the conference, next Pycon Slovakia or EuroPython. Join local Python user groups. They constantly looking for fresh faces. Be on social media. Twitter works perfectly for tech people. You can follow me, you can follow other people. I met a lot of people there, and it's amazing. Or you can also use LinkedIn, but I'm not a big fan. Create content, contribute to open source. I think Carolina presented great project today, and Hacktoberfest is ahead of us. Find support to grow as a public speaker, find a mentor, ask your DevRel person or tech community manager or just peers, and they will definitely help you to get to your first meetup or a conference. Be authentic, do what you love, do what you are passionate about, and I don't know, I'm pretty sure it's gonna be fun. If you want to connect and talk more about tech community building, Python, I'm here at Twitter, and have a nice conference.
Yes, it does.
Hello, I'm Thomas, and I'm going to tell you about Pi Week and the game we're developing this week, actually. If you see here, September 2022, the Red Planet Challenge is underway, and it's 8 hours and 70 minutes to go. So if you want to quickly develop a game in the next 8 hours and you don't have anything else to do, you can still do that today. The next challenge is going to be in March 2023, I guess. So it's always 2 times a year. Show of hands, who knows what Pi Week is? Okay, some of you. Who has already participated in Pi Week at some point? Okay, a few, nice. Who has participated in this Pi Week? Okay, great. So, task to do for next time, go and participate. And maybe after this lightning talk, you will. So again, Pi Week is a biannual game challenge. It's all online, happens all online. And the point is, you basically create a game in 1 week you can use existing libraries like Pygame or something else, but you're not allowed to use any code that you haven't published before, because the idea is that everybody starts at the same page, more or less. Intended to be challenging and fun, so there is some rating and so on, so you can like vote which games you like best in different categories and so on. But yeah, the point is having fun, creating games in Python, maybe learning Python by creating games and so on. There are a few rules that you have to follow. You can either do an individual entry, which means that you do it all by yourself, or you can have a team-based one, which means with some friends and so on. And that's actually what we did this time with the Python user group in Vienna. We had a team challenge, and I'm going to show you the game really soon now. Then you have to write it from scratch, so you can use existing libraries, but basically you have to write everything from scratch that's related to the game. So you cannot like create something for the game, except if you publish it, I think something like 30 days before the challenge starts. 1 week, which is nice because that means that you don't waste too much time if it doesn't work out, so 1 week. And the theme is selected by voting and so on. You can read all the rest and so on. The challenge this September is the Red Planet. And so basically, you have to create a game that's somehow related to that. It doesn't really have to be like very serious and so on. For example, we chose the topic "the red planted," like in plants, for our entry. The initial discussion looked something like that. So that's like the first draft we did on Sunday or Saturday. Like we're going to do something like with plants and flies and so on. Had lots of ideas, and we threw lots of those ideas away, basically. And so we ended up at like 6 days ago this week creating the game and so on. That's how it looked on Monday, I think. Then we added some plant stuff there. We went ahead and decided to have different like areas. So some are more fertile than others. So looks like that. And then we wanted to do something with the topic, which is like Red Planet. So we made a planet, looked a bit weird. Iterated over it, made the plants actually on the planet, and so on and so forth. Until eventually we tried something super weird, which didn't work out. We tried to make it super realistic, which looked super ugly. So reverted back to a more pixel art comic style, and there's something like that here. Different cursor artwork, and yeah, went from the initial one that's here in the center to the ugly one here, and then to something that's hopefully a bit more balanced. yeah. There are, of course, some bugs when you develop stuff. Too many items spawned, super weird. Yeah, and then, of course, you iterate, and it gets more fun. I got 1 more minute, so I'm going to skip over some of the things, and I'm going to just show you the game. That's the current state of the game as of this afternoon. So again, we call it red planted, which I guess still follows the rule of let red plant somehow. You basically can look at the instructions, which is super small to read here, but yeah, you can do only so much in 1 week, and then you play the game. You get a little backstory. So basically command gardener, and you have to defeat your planet for the space flies. You can either squash them, or yeah, if they go away with your tomatoes, then it's game over. I'm skipping over those parts, and of course, the problem is while developing, that's really slow, and I only have 20 seconds left. So of course, there's a dash fast mode for debugging. So you go in there, and then of course, they sprout very quickly. There's also audio, by the way, which I think kind of works. So there's basically just the space flies over there. And yeah, check it out over this URL.
I don't have the slides, so whoever's next can start preparing slides in front of me so we won't have technical problems.
So who's the number -3?
The next one, 5-week, become a manager, Mava. Okay. Okay. You can start the clock. So, who here doesn't know what HTTP codes are? So I can assume everybody knows what HTTP codes are. Okay. So I'm assuming everybody knows. Okay. So let's play a game. In my job, I have to connect with a lot of APIs. So let's say I provide the wrong credentials. Which HTTP code do you think I should get back? Yeah? Okay? True. Okay, let's play another game. Which, if you don't count 403 or 401, and you don't count the 300 and 100 one, which 5 codes do you think I got from multiple APIs for getting the wrong credentials?
200.
Yeah, that's one. 500 was also correct. 503 I also got. 404, surprisingly, I never got, but that would be interesting to hear a case when that happened. Okay, there's still 2 left. I also didn't get that one. I would also be interested in that case. Also didn't get that one. Yeah? I think it was 490. Was it correct? 18. I got 18 for permissions not being correct, not for wrong credentials. Even though it's weird because teapot and coffee making doesn't have anything to do with credentials. So yeah, my point, but here you can start to see that the guessing sort of started happening, going in the random directions. And the point that I wanted to make for the users of the API, if you're creating them, please make sure to have used a correct HTTP code, because this type of errors are really, really annoying to debug. And that was my entire point. Thank you.
Do we have the speaker from Become a Manager? Okay. Well, I have a MacBook and I have an HDMI. Is that going to work?
monitor. It should appear here.
It's nothing. Oh, give it some time. Okay. Oh, nice. Okay. Okay, perfect. It's fine. Okay. Hi, everyone. Yesterday, Miro had his talk, and he's coming after this one. So I thought it would be fair to insert myself before his talk, because last time or yesterday he said that his first talk was the lightning talk at EuroPython. So I want to talk a bit about EuroPython. Who in the audience knows what EuroPython is? Okay, lots of people. Who have ever been to EuroPython before? Okay, great. So for those who don't know, the EuroPython is a conference. It's kind of like this one because it's about Python. It's Europe. Normally, when I do those lightning talks, I do them to announce where the next EuroPython is going to be. But this year we already had a conference. It was in Dublin. If you haven't been there or haven't seen it, you can go to the website and catch up with the live streams and with the pictures and all the amazing keynotes and everything. But we don't have the location for the EuroPython 2023 yet. So what I can share or announce today is what we published about an hour ago, which is the community call for venues. Normally, finding the location for the EuroPython is a long and complicated process, and part of that process is asking the community where the community wants the EuroPython to go. And that's what this blog post is about. You can go to blog.europython.eu to read all the details and see all the timelines. But I'm going to give you a TLDR. If you have an idea where the EuroPython should go in 2023 and beyond, you can go read it and fill in the form. If you know anyone who would be interested in proposing locations, you can also share it, tweet it out. You can retweet our tweet from earlier today. And yeah, one more thing that I would like to mention is that EuroPython is a community-organized conference. It's organized by EuroPython Society. That's the NGO based in Sweden. And all the profits that are generated from the conference are going to the EuroPython Society grant program, which is later used to support conferences all over Europe, including this one. We're a community partner of the Pycon Slovakia. We really like the conference, and we also really like the educational projects that you guys are doing here. And if you have any other ideas of where that money from the grant program could go, either to a conference or to other Python project that you're doing somewhere in Europe, please send us an email to board@europython.eu, and we'll be happy to help. And now on to Miro's talk.
Who wanted to become a manager talk? No? Not here? Okay, so thank you. I have a secret tip, but I don't see any organizers from Pycon SK. Maybe EuroPython in Bratislava wouldn't be such a bad idea. Okay, I will be quick because everyone is already hungry and we want to go to the dinner somewhere. My title of my lightning talk is on inches and feet. So about this imperial measurement system. Well, I'm completely for metric system, and I use metric system everywhere I can. My week starts on Monday. My clock has 24 hours, and so I try to, or I use it when I need some data as much as possible. But sometimes it is practical to have some unit for measurement with you. And these are like inches or feet or some other lengths of your body. And since we are already all grown up, in most cases, we don't grow so much. And we know that, for example, 1 inch, how much is it? Like 2.5 centimeters. And for example, this, when I stretch my hand, this is almost exactly 23 centimeters. Well, with the foot is a little bit difficult because the shoes are of different length that I use, so there is more or less 1 centimeter. But, well, if I need to measure some distance, this works quite well. So how much time do I have? So when I do one, well, let's take the longer one. So it's like 1 and 2 and 3, a little bit more. So it would be like 80 centimeters maybe. But when I already start like counting and measuring it, and I say like, okay, now I am at 10, and I do a line here and then go back, like subtract 5 inches and then add again 5 inches, then most probably I will not land at the same line because, well, depends on how I press the inch, and well, my inch is not 2.24, it is depending on how I press it, it is sometimes 1 millimeter less, 1 millimeter more, so it's approximately. And now we are moving to the programming topic, and these are the floats. Actually, everything that you use in physics, these are floats, and these are not exact. So even if I calculate that 80 centimeters should be something like 8 times 4, 32 inches, then it will be not exactly 32 inches, and each time I measure it will be a little bit different. And when I add and subtract, I can like plus 5, minus 5, plus 5, minus 5. After 1 million iterations, I can land like 200 meters further away from there. So if in programming you do anything with physics, then use floats. But if you don't use physics and you have some exact numbers, then use integers, please. 1 hour has 3,600 seconds, not 3,600.0 seconds. Do it in your code, make the code legible, so use the numbers as they are, don't convert them to floats. We are not using Python 2 anymore. If you are dividing the number of seconds and you want to have the number of hours, you don't need to write into your code like float of 3,600 because otherwise you would get some integer division. In Python 3, you can put exactly the integer value for the stuff that it represents. And that's all. I'm looking forward to so many diffs and so many fixed code on GitHub. Thank you very much.
Okay, was this the last lightning talk? Yeah, okay. So we're again behind schedule, so I'll make this really quick. Thank you for coming, and I hope you'll come tomorrow again. We have the last day starting with awesome talks. They'll be only in this Titans room, so please do come. And if you're a volunteer, if you're a speaker, or if you have bought a ticket to the social event and you want to go as a group by foot to the place where the conference dinner is located, so please wait in front of this Titans room, right where next to the area where the volunteers will be gathered, and there'll be one of our volunteers who will guide you to the place where the dinner is happening. So thank you very much and have an awesome night.
Mikrobit je programovateľný mini počítač, ktorý ti dovolí prepojiť informatiku s kreativitou. Dá sa programovať veľmi jednoducho a ovládať tak, aby robil presne to, čo chceš. O pár minút sme zvládli rozsvietiť vlastný obrázok na displeji a o chvíľu sme už obrázky diaľkovo prepínali druhým mikrobitom.